Hey everyone, Mike Settele here, and in this video, I'm going to go through SAT practice test number 6 in the Bluebook app. I am going to do it in grind mode. What this means is that I'm going to go through in extremely careful detail. I will literally talk you through every single thought that enters my mind, every decision that I make along the way. We are not really going to do this according to the time limit. I have other videos for that. This is really meant to give you basically a window into my mind so that you can see how many decisions I'm making as I take the test, how I think through each strategy, whether I decide to use that strategy or not. So this is going to be extremely detailed, and hopefully it can show you some things about the way that I think about the test that you can then use for the way that you think about the test. As always with my practice test videos, do not watch this video unless you yourself have already taken practice SAT number 6. I'm going to spoil all of the answers. So that's not going to be helpful if you haven't taken the test. You want to make sure you take it yourself first. Also, if you are trying to review a few questions from practice test 6, this probably isn't the best video for that. I do have individual videos for every single question on practice test 6 and all of the Bluebook practice tests. You can find those most easily probably on my website. There is a button that says practice tests. Click it, select practice test 6. You will see all the modules there. I also have another video of me taking practice test 6 for the first time ever with the timer on. So I don't see the questions. I don't know the answers. I'm just answering them kind of like you would as if you were taking the test for the first time as well. That is a separate video. That can be very, very helpful if you are interested in working on your pacing, trying to determine what decisions to make when the clock is ticking down. So this is yet another video about practice test number 6, and it is going to turn the timer off. So let me show you what I'm going to do in Bluebook. I'm going to select practice test 6, and I'm going to click testing with accommodations. And then for reading, I'm going to give myself more than double time. For math, I'm going to give myself more than double time. I'm going to turn on extra breaks, extended breaks, breaks as needed, basically everything except these bottom two. And what this is doing is it's still going to have a timer, but it's basically unlimited. It's going to be so much time that you're not really going to have to worry about it. And this can be useful if you want to go back to a practice test for some reason and kind of work through the questions like I'm doing in a much more deliberate way. It can be helpful. But when you take a practice test for the first time, you should take it with the regular amount of time that you will have on your SAT. This extra time thing is only for people who are approved with those accommodations. And the reason we're not checking these bottom boxes is these alter the test. So you're not going to take the same practice test 6 if you click at least this one. I don't know about this bottom one, but I will be talking. I will be doing the text to speech for you. So there will be no need to do it in the machine. So we're going to keep it with the extra breaks and all of that. I'm also going to use another feature of my website alongside all of this, my strategy trainer, which you can get from my SAT resource library. Just follow pretty much any link to my website that you will find on the internet. It'll take you to this page, click strategy trainer. And essentially what this is going to do is tell us the kind of preliminary steps, the simplest things to think about for each type of SAT question. So this can be really helpful once you've maybe seen a couple of my lessons and you have some new strategies that you're trying to use, but you're having trouble remembering when to use them and you need some sort of reminder. This strategy trainer can be helpful. I'm going to use it. I'm going to show you kind of basically how essentially what I tried to do with this thing is make it a version of my brain to kind of show you how I think through each process. So we'll stick to those steps. You'll see more of what I mean when we get there. But I think that is enough for setup. I'm going to pause this video as we get into it. And just as a fair warning too, I know all the answers to this test. I'm going to be looking at them on a different computer as we go to make sure that I don't make any mistakes as we go. So there's really no surprises here. This whole purpose of this exercise is to just give you a very, very deep sense into how I think about every single type of SAT question. So I hope it's helpful. And let's take a little break before we get into reading module 1. All right, and here we are with reading module 1. Notice tons of time. We're not going to use all 2 hours of this module, but we're still going to go through it kind of in the same way we would if we were on the clock. And so the first strategy we have to make sure we follow for reading is to find the grammar questions. We're always going to want to start with grammar. That usually happens around question number 15. In this case, 15 is a passage, so we're going to keep going. And there you go. You'll know you'll hit grammar because it'll say standard English conventions. And so there you go. And the reason we're doing these first is grammar is probably the most predictable part of the reading section. So it's where we're going to lock up a lot of points, assuming we've studied our rules, and we're going to do it very quickly. And that way we're going to end with questions like this one, this passage question, where if we are running out of time, okay, fine, we might have to guess randomly on some hard passages. Not a big deal. The last thing that I want, though, is to have to rush through the grammar, the transitions, the outlines. Those are going to be easier, more predictable questions. I don't want to have to rush through those and make careless mistakes. I want to lock in as many points as I can. The overall main strategy for the SAT, remember, is you just want to get as many questions right as possible. The more questions you get right, the more points you get. So it's not about trying to get certain types of questions. It's that a grammar question might only take you 30 seconds. A passage might take you 3 minutes. So we can get a lot more grammar and stuff like that right in the time it takes us to answer one passage. More right answers, more points. So let's talk through strategy here. We're going to go to my strategy trainer, and we are going to go to grammar. And you can see here that our first or our main strategy for the grammar is to predict the rule. So what we want to do is we want to look at these answer choices, and based on the choices, we should know which kinds of rules matter. So let's make this a little bit bigger. There we go. Very big. And first thing I notice is there's punctuation, right? So that means I'm going to be paying attention to punctuation. But even with that, I want to make sure that I'm doing it in the right order, right? So we're thinking about sentence structure, independent clauses, dependent clauses, and anything that's in this first row, we want to make sure we're looking at first. These are the punctuation situations that have the most concrete rules. And I can see we have a colon in choice A. So essentially, I've memorized what a colon does. A colon is used we need a complete sentence before the colon, and then afterward we could have another complete sentence, or we could have an extra clause. So basically, I have a very clear test for choice A. And to be clear, I'm not picking it, I'm just kind of highlighting it essentially. My test though is I'm gonna read up to the word instrument and see if that sounds like a sentence. So something like this. When a harpsichord's keys are pressed, the strings inside the instrument. Can I stop there? Can I just end the thought there? No, definitely not. That's not a sentence. I feel like I have to keep going, right? The strings inside the instrument, what? They have to do something. So right now I've proven choice A wrong, right? The colon doesn't work because there isn't a complete sentence beforehand. There's no other options here that match our first row, but I do see in our second step here, we see there are dashes and there is a dash here. Now, dashes can be used in two ways. The most common way is if we see two dashes, we know that that's a way to insert extra information in the sentence. So right now I'm looking, do I see another dash? No. So this is the other way. And essentially, if we have a single dash, it works the same way as a colon. So already this is probably wrong for the same reason, is we don't have a sentence to start things off. We need it to be a sentence, and then we can use the single dash to add on an extra piece. But I just don't see that here, right? When a harpsichord's keys are pressed, the strings inside the instrument. Again, I can't stop there, so that gets rid of this. And now the choice is between no punctuation at all or a comma. And notice commas are last in our list because commas have so many different functions, and it really is dependent on the situation. So it's not so much now that I'm looking at a particular rule, I'm just reading the sentence and deciding, is there a break in the sentence at this point? Is there something kind of that adds on a clause or whatever? So let's clear this out. When a harpsichord's keys are pressed, the strings inside the instrument are plucked, not struck. Yeah, as I'm reading that, it's very clear to me, I don't need any sort of punctuation. This is a clear, connected thought. And so I'll specifically highlight what the entire sentence is. This is the main sentence. The strings inside the instrument are plucked. Then we have other commas in the sentence. And why are they there? Well, they're there to add on an extra clause, right? So this, when a harpsichord's keys are pressed, that's an extra clause that's kind of leading into the sentence. The comma is there to show the glue, the connection between this main yellow sentence and this pink clause. And then not struck is also kind of adding on an extra piece. So sometimes we say that two commas are used to interrupt a sentence, right? But here it's kind of the opposite of that, right? The yellow is the sentence, and we're using two commas to add stuff on either side. And to be really clear, the pieces on either side of the yellow have nothing to do with each other. They're just kind of random pieces that are leading in and leading out. And so they're not like connected in their own way. It's not like we could just say, when a harpsichord's keys are pressed, not struck. that's not a sentence. That's nothing. Those are just extra pieces attached to the yellow. So to be clear, all of this would be going through my mind just at a much faster speed as I'm taking the test. So this is an easy question. I'm still going to check to make sure I didn't make a careless mistake. So this was question 16. And sure enough, yes, B is the answer. I can confirm. And I wouldn't be drawing all these like highlights necessarily on the test just for the sake of speed, but I'm doing it here for your benefit to kind of show you what my mind is seeing as I go through. So hopefully that was helpful. And now we can move on to the next question. Here, again, I'm thinking about predicting the rule. What's going on? Well, there's no punctuation here. These are verbs. Right, so these verbs are changing, and when verbs are changing, we have a very specific order that we have to go through. So first things first is we're going to check for agreement. In other words, we're going to look at these verbs, and we're going to try to classify them as either singular or plural. So let's do this here. I'm going to add a little note. Okay, that's fine, I guess. Can I back it up? All right, that's better. Now, normally on the SAT, I never use this note feature. You have scratch paper and you can use your scratch paper. You can get more scratch paper if you run out. So by all means, use a pen and paper, pencil and paper. It's much easier. But for the sake of just having everything on the screen for you guys, I'm going to just do it here. And what I'm basically doing is I'm just going down the list. And in my mind, it's very easy to know what is what here. So I know just from memory that create is a plural verb. Right? If I needed to, I could make a sentence. I could say, they create art. So they, plural, create art. But I wouldn't say, he create art, right? That sounds bad because we would say he creates art. We can see that's choice D. So that's essentially what we're doing is we're categorizing each of these as singular or plural. Now, ideally, like me, you can kind of just do it automatically from memory. I know which verbs are singular and plural because I've done this so much. I don't need to make little sentences in my brain. I know that verbs that end in S are singular and verbs that don't are plural, words like are and have being kind of like ones you got to recognize instantly. So right away, what this tells me then in terms of this question is it's probably creates, because the fact that I could categorize all four of these choices as definitively singular or plural, we'll see later, I bet, that there are cases where that won't always happen. But if we can categorize each of them as either definitively singular or plural, it means it's a question about whether the verbs are singular and plural. And the way that this tends to work is we have what I call the 3 versus 1 strategy, where if 3 of them are of one type and 1 is the other, it's the one that's different that's right. This 3 versus 1 thing really only works on verb agreement questions. And even then, sometimes it falls apart, but it's very reliable as far as strategies go and patterns go. So it's worth it. Now, if you had no idea what was going on and you just needed to move on to the next question because of time, I honestly have no problem with you just picking D and continuing. But what we should really do if we can is try to prove the singular verb is correct by finding a singular subject. So let's look at the sentence and notice in this example and in the previous sentence, there's extra stuff at the beginning of these passages, but I'm not reading it because I know that certain rules are only focused on the single sentence, right? So before when we were dealing with punctuation, the punctuation in other sentences has nothing to do with the punctuation in the sentence with the blank. Same thing here with verbs. The subject of the other sentence has nothing to do with the verb in this sentence. So I'm trying to match the subject that goes with this verb in this blank. So it says, it's an example of anti-metaboly, a writing technique that creates emphasis by repeating a statement in a reversed order. So here I would say technique, right? A technique creates emphasis. That I believe is the subject. It's kind of interesting because we also have another subject verb pair basically contained in this single word it's, right? It is a subject and is a verb. And those two things are both singular and they go together here. But then we have this kind of extra clause and the word that kind of confuses things. And this is why I really like this 3 versus 1 strategy and kind of trying to trust that a little bit more is sentences are confusing and they're going to try on harder questions to distract us with other types of structures and things that get in the way of us finding the subject. So it's better to kind of find the right verb first so we know what we're looking for as we look at the sentence. So technique is singular, creates a singular, seems good. Moving on. All right. Obviously, this question is about question marks. And here it is. I was like, that's somewhere in here. It is a punctuation question, but question marks are kind of like their own thing. It's mostly just very simple. Do I have a question or do I have a statement? So again, I'm not going to really read anything else. I'm just going to kind of read what's here. The toxic nature of some of these materials recently led a team from the University of Sheffield to investigate how could their use be better regulated. Right? So that's just choice A. I'm just throwing it in to have something, right? But it's not a sentence, right? There's no reason to have a sentence there. Like a question there. It's a sentence, a statement. So that sounds weird. I might try choice C because it also has a question mark and kind of, you can hear the difference between a question and a sentence. The toxic nature of some of these materials recently led a team from the University of Sheffield to investigate how their use could be better regulated. Right? You can hear my voice kind of being weird, and that's not how it goes. But I kind of like a version of that doesn't end in a question mark, right? Let's just state it, right? The toxic nature of some of these materials recently led a team from the University of Sheffield to investigate how their use could be better regulated. That's what I want to say. The fact that there's the word how doesn't mean that we need it to be a question, right? We think of how as a question word, right? You know, who, what, when, where, why, how. Those are question words. But they don't have to ask a question. If there's no question, there's no question mark. And usually that's something that just from speaking English, you can hear. A question sounds different than a statement, right? We could have asked just kind of by itself. We could have kind of going back to A for a second. If we started the sentence with the word how, then we would need a question mark. How could their use be better regulated? That's a question. That would require a question mark. But that's not what we were given, right? We were given all this extra stuff leading into that kind of nullifies the question. It makes it not a question. And so there you go. And D, I just know is the wording of the question without the question marks. That's gonna also sound like a question, but it has the period. So that's wrong too. So these are usually very easy questions if you speak English. The only reason I think people tend to get them wrong is the fact that there are choices with question marks makes them kind of like freak out a little bit. And they're like, oh, I must need a question mark. Otherwise, why would they offer it to me? But no, not always. Sometimes yes, but it depends on the situation. So just read it, see how it sounds. If it sounds like a question, put a question mark. That's it. All right, next. All right, these are verbs again, right? So we're coming back down to here. So I'm still going to go through the same process. I'm going to try to think about singulars and plurals. But when I do that, let's see if I can do it here. Okay, good. When I do that, I'm going to fail, right? So if I look at A, will be illuminating, that is both singular and plural, right? I could say, he will be illuminating the room with a flashlight. He, one person. Or I could say, they will be illuminating the room with a flashlight, right? That's multiple people. And that's the thing is most verbs in English actually don't have this property of being singular or plural. Some of them do. So choice B, that's singular, right? He illuminates the room. That's fine. C is also both. He would illuminate the room, they would illuminate the room. So again, this is a verb that has both, and something like D is especially also not going to take that property of being singular or plural. He illuminated the room, they illuminated the room. It's the same whether we're talking about one person or multiple people, so it doesn't have that property. And this is a good sign that even though we checked for agreement, the rule doesn't apply. But we still need to check because the number of times people jump to some of these other rules and verbs thinking it's about something like past, present, future, but it's actually about agreement. That's where the trapped answers come from. That's where they get things wrong. So this process at times can feel very much like a waste of time because you're doing steps that you're like, it doesn't matter. Why am I doing this? But the point is, we do those steps to prevent ourselves from falling for a trap, to catch the mistake before it happens. So the order is very, very important here. And I'm doing this in my head very quickly during the test, every single time. So I've gone through that. It's not agreement. This other rule is tough to talk about without examples, but it doesn't apply here. Essentially, to and ing is kind of my own made up rule that captures a lot of different types of questions on the test where essentially we would be getting verbs in the to form and in the ing form. So if I saw something like to illuminate here, or we do kind of have illuminating, but it's not quite the same thing. If I saw those versions of the verb, I might be thinking of the to and ing rule, which you can see in my trainer is about sentence structure. That is not what's happening here, so we can move on. And now we get to the verb rule that everyone really wants it to be about, past, present, future, tense. When does this take place, right? This is the verb rule that most people jump to first. but it's the one that we should go to last. We have to rule out the other two because they are trickier. So now that we're at that point though, this is a rule where usually, if at least if you're a native English speaker, the tense should be obvious. You are going to pick a tense based on just how it sounds. So your instincts will be really good. But for something like this, we probably do want to now read the whole passage because since the timing of the sentence matters, we might get clues about the timing based on the rest of the passage. So let's just do that. Each night in Gijón, Spain, a section of the city's marina is bathed in a soft green glow. The source of the glow is the Árbol de la Sidra. So we got is here, right? We got is here again, so verbs. A large sculpture made up of 3,200 recycled glass bottles. A lamp inside the tree-shaped structure illuminates the green glass is kind of what I want to say here because we're talking in the present tense. Is, illuminates. Those are all saying it's happening right now. It is just the way it is. It's not will be, right? There's nothing in here that indicates this is a future event. This is happening now. These lamps are there, right? So it's not the future. Would illuminate is similarly kind of like a future, like the lamp inside the tree-shaped structure would illuminate the green glass if they plugged it in, right? It suggests that there's like a condition, but no, it is the way it is. It illuminates it. And illuminated is past tense, right? That suggests that it's over, but we have no evidence of that. So usually we'll be able to hear it. But remember, we have to read the full passage because if I just read this sentence, then a lot of these other choices actually sound good, right? Without context, there's nothing wrong with saying a lamp inside the tree-shaped structure illuminated the green glass, right? It could be in the past tense. We don't have anything else suggesting one way or the other. So when we get to past, present, future, you've got to look at the whole. Sometimes we're matching verbs across multiple sentences, but regardless, the context can affect the answer. I have been checking the answers as we go to be sure, and yep, choice B is the answer here. So pretty good. Let's move on. Okay, so what is this about? Well, I noticed two things. I noticed that the its is changing, right? We have its, and then it's changing to their. So that's one thing. I also noticed that we have, I'll kind of highlight here, we have different versions of the word phrase with different apostrophes. So some might consider this two separate rules. Some people might say it's the same rule. A couple different ways to go. We do want to talk about those apostrophes, which in most cases indicate possession. And we also want to talk about pronouns. And notice that's singular and plural as well. Personally, I find pronouns easier to think about because I can count. Am I talking about one thing or multiple things? That's an easier thing for me to think about. So I'm mostly just going to start there out of personal preference. And at the very least, that will eliminate two choices. So for pronouns, I tend to read everything because sometimes a pronoun can refer to a noun that's in a different sentence. So it's not like a subject and a verb, even though it's still singular and plural. We are thinking about this with a larger context. You can refer to nouns all over the place. So let's just read the whole thing. French philosopher René Descartes doubted whether he could prove his own existence. Eventually, he found proof in his famous phrase, "I think, therefore I am." The phrase's simplicity masks its complexity. Only those who exist would be able to ponder their existence. Okay, so it's about a single phrase, right? That's what we're talking about. So it's not there. There is plural. It's is singular. So that's the difference between those two words. You have to memorize that. A lot of people, for some reason, think the word there has to do with people and its has to do with objects. No, you could refer to a person as an it if you really wanted. They'd probably be insulted, but you can definitely refer to things with there, right? I mean, I have to sharpen, I need multiple. I have to sharpen these pencils because their points are dull, right? Multiple, their points are dull. So that's something you just memorize, and that allows us now to eliminate two answers because we know we need a singular. And then now let's compare the word phrase, right? It's got an apostrophe, right? There was a choice where it didn't have one, but that's gone, so we don't have to worry about that. Now we have to decide, where does this apostrophe go? Does it go after the S or before? Well, again, this is the thing that we memorize. Normally with apostrophes questions, the first thing to decide is whether we need an apostrophe at all. That decision has been made for us. But then our decision is, well, what's the difference? So let's kind of put it here, do another one of these notes. If the apostrophe comes before the S, that usually indicates that the word is singular. If the apostrophe comes after the S, that usually indicates that the word is plural. So notice we're still thinking about singulars and plurals. In reality, this rule is a little bit more complicated because sometimes we don't put another S if the word already ends in S, right? So it could end in S for other reasons and still be singular, right? So like I could say something like my boss's car, and now it's kind of confusing. Some people would write it like this: my boss's car broke down. And notice the word ends in S, we're adding another. Some people would say, no, my boss's car broke down, and just leave it like this, where there's no another extra S because it already ends in S. This is one of those things in English that's tough, but that's never going to happen in the SAT. What matters here is the word phrase, right? Phrase is singular and phrases would be plural. There's a clear difference. So that's essentially what we're doing is phrase is the word in choice, this is backwards, but in choice D, and phrases is the word in choice A. And so we're making it possessive in either choice. So we got to decide, are we talking about one phrase or multiple phrases? And that's the exact thing we talked about with the pronouns, right? The phrase is simplicity. We're talking about one phrase. The phrase, I think, therefore I am, the one they referenced as singular before. So we need choice D because it has both the singular pronoun referring back to the phrase and the word phrase itself, which is singular, but then we make it possessive with the apostrophe S. So that's a lot, but if you know these rules, this is maybe a 30-second question, and it's very easy. So I know I'm talking a lot about it, but I'm trying to, like I said, grind mode. We're in grind mode. We're trying to grind out every little thought process that we have. But I do like on this question that it's almost like two questions in one, right? You treat it as two separate things. Don't try to do them both at once. Every time in the SAT, you feel your brain multitasking, doing two tasks, you've now increased the chance of doing one of those tasks wrong. So always try to break the choices down and think of it as separate decisions that you're making, not as one big decision. This was two separate decisions. Moving on. Okay, so here I see right away, predicting the rule, choice C has a colon, right? So again, colons are high in my list, so I'm gonna try to test that out. Do I have a sentence before the word character? So we're reading up to here, basically, up to the word character. Fans of the film Moana may not know that the deep and humorous voice behind the character. What? What about it? What about the voice, right? You didn't say anything. It didn't do anything, right? It feels like we're continuing, right? So I don't think that this is going to work. There's maybe kind of a sentence. You could say something like fans of the film Moana may not know and kind of stop there. It wouldn't be a very good sentence, but it would be complete, I'm pretty sure. But then we continue with this word that, and that kind of almost like tacks on a new sentence in a way that needs to also conclude. So it's not happening here. But I do recognize what this is. This is very clearly to me a positives question. It is about the way that commas are used to kind of put in extra information. So there's a kind of general rule I'm following with this, and I have a video on this. You should watch my video on positives. But essentially, if we have two things. We have a term and then a definition. So let me tell you it like this. We're going to use two commas when the term comes before the definition, and then we kind of continue with our sentence. We're typically going to use 0 commas when the definition comes first and leads right into the term, and we continue on with the sentence, right? So this is typically how it goes. And when you write essays, you almost always choose the 2 comma option. Both are correct, but you almost always just out of habit use the 2 comma option. So your brain is kind of conditioned to pick the 2 comma option. Now notice here, we don't have that, but that's unusual. So I'm still thinking about this, even though it's technically not even a choice. What I'm thinking about though is, well, what is the term? What is the definition, right? The term is like, what would you Google? What would you type into Wikipedia? If you wanted to get specific information about this thing, what is it you would type? I would type Tamatoa the crab, right? That's the title of the Wikipedia article, right? And then what is the definition? What is this? What's the first sentence of the Wikipedia article going to tell me? It's going to tell me it's a character, right? So character in this movie, essentially. So notice the definition here comes first, right? Character comes before Tamatoa the crab. So it's probably the case that I need 0 commas. So that would be choice A. And I can verify that. There might be reasons I needed a comma somewhere else because of something else in the sentence. Maybe there's some sort of other structural element. But for now, it doesn't seem like we need one. Let's take a look. Fans of the film Moana may not know that the deep and humorous voice behind the character Tamatoa the crab belongs to comedian, actor, and musician Jermaine Clement, right? So there are commas, right? Why are these here? These commas are here because it's a list. It's a list of 3 things: comedian, actor, musician, right? So those commas have a purpose. But I wouldn't need another one. This is just a continuous thought. It's just going through, and we can see the word belongs. That was kind of our verb that before we were missing that made the sentence sound incomplete. We tried out the colon. So yeah, I'm sticking to my rule. I have no reason to doubt the process here. With positives, 0 commas is what we get when we have the definition of the term. I have that option. I don't see any reason to break that rule. And yeah, that is the answer. Moving on, we are now in transition questions. Okay, so these are different. So let's change our strategy trainer. And yeah, you can see here our main strategy is to dumb summarize the words, right? We don't normally talk saying things like on the contrary, but we know what it means, right? So we have these kind of dumber versions of these words. Most transition words are going to fall into 4 categories: for, but, and, so, and for example. So not every word falls in there. You see I gave some common ones here, but this is not complete. This is not a complete list. And there are choices that don't fall into any of those. But my first move usually with these questions is to just categorize them and get a better sense of what I'm dealing with. So on the contrary is definitely a but, right? We can see contrast is here, right? So that's what but does. It makes a contrast. For example is for example. So that one's easy. Previously is a good example of one that is not in the 4 main categories, but is very obvious what it means. It has to do with time passing, right? First this happened, then this happened, previously this happened, next this will happen, right? Time is in some way, or sequence is in some way involved. And as a result, that is a very obvious so. And there it is, first on my list for so, right? So these are things that with practice you can memorize. It literally will take me 3 seconds to categorize all 4 of these choices very quickly. Sometimes I do on my scratch paper, write it out. But for here, we just type it so you can see. Now, when I go to the sentence, I'm reading and I'm looking for strong words. Anything that tells me maybe a little bit about the relationship between these sentences is going to be helpful. And as I plug into that blank, I'm not plugging in on the contrary. That's weird. My brain doesn't hear that very well, but it knows the word but. It can recognize that word very easily because I use the word but 1,000 times a day. So we're reading everything, but let's see. Celebrated Tiwa potter Maria Martinez made her signature all-black ceramic vessels using a heating technique called reduction firing. This technique involves smothering the flame surrounding the clay vessel. The vessel takes on a shiny black hue. Okay, well, it's not a but, right? So this technique involves smothering the flame surrounding the clay vessel, but the vessel takes on a shiny black hue. There's no contrast there. These just seem like steps in a process. So I don't see any reason why we'd be contrasting them. It's also not a for example. This technique involves smothering the flame surrounding the clay vessel. For example, the vessel takes on a shiny black hue. The color of the vessel is not an example of the smothering. It's not an example of how the flame interacts with it. It's a consequence, right? And so that leads me probably to choice D, because so feels right here. This technique involves smothering the flame surrounding the clay vessel, so the vessel takes on a shiny black hue, right? As a result of the way the flame is around the vessel, it takes on this color. That's previously isn't terrible, but it doesn't make sense, right? You're putting the flame in, it's turned a different color before that, before you put the flame on it. No, it's getting the color afterwards. So previously is flipping the sequence here. It's flipping the time. So yeah, I wouldn't necessarily say as a result if I were saying this myself, but like, that's not the point, right? Is it's kind of a simpler version is so. This technique involves smothering the flame, so the vessel takes on a shiny black hue. It's as a result of that, yes. So that's definitely the answer. I would have no issue with a question like this. Moving on. All right, so let's get the same process here. We're going to start by categorizing these words. I know some of them are obvious. We should know that however is but. Indeed is a little trickier. The short version is it adds emphasis, right? So it's not one of our 4 main categories here, but it adds emphasis to things. So sometimes that's tricky because you can add emphasis to a contrast, you can add emphasis to a consequence, you can add emphasis and just reiterate something, be more like an and. So indeed is one of those words I'm not really picking unless everything else feels wrong. So we'll kind of leave it aside for now. Second is very clearly like a sequence thing. First this happened, second this happened. And likewise is basically an and. And so it's used to kind of relate to equal things or to just kind of move on to the next point, essentially. So we get a lot of variety in these choices. So let's again go to the passage and see if there's anything that kind of stands out. In the early 1970s, Albert Papa took up graffiti art, spraying his work onto what was at the time an unconventional surface, concrete. So Albert's son David has chosen an unusual canvas for his new art project, Fractured. In this remarkable work, the artist draws charcoal faces onto fragmented ice flows in Finland, creating the visual effect of a face slowly fracturing. So strong words, all right? We're going to talk about this a lot when we get to the vocab and the passages. What is a strong word? A strong word is something that indicates some sort of relationship or just really adds meaning to the sentences. So I see some strong words. I see the word unconventional, right? Albert Papa is doing something unconventional. Albert's son David is doing something unusual. Well, both of those words mean the same thing. If you're unconventional, you're not following the norm. If you're unusual, you're not following the norm, the usual way of things, right? So the fact that both of these people are being described in essentially the same way tells me, first of all, it's not a however, right? We're not contrasting them. Now, some of you might read this and think of it as a contrast, right? Oh, one guy is using graffiti, the other guy's using ice. That's a difference. That's a contrast. But the strong words here are saying, no, we're trying to say these people are the same. So it's definitely not second, right? I mean, yes, it's his son, so he came second, but it's not, we're not trying to order these events. We're trying to relate them. So here's a good example where it's hard for me to prove indeed wrong, but likewise is a perfect fit here, right? Because it's an and, right? Albert is unconventional, is using an unconventional surface, and his son is using an unusual canvas, right? There's a symmetry there, right? Indeed would be more like if we said something like Albert Papa loved to use unconventional surfaces for his art. Indeed, at one point, he used concrete, which at the time was weird. I don't know. I'm not good at coming up with sentences in the moment, but that would be if we were kind of reiterating something about Albert or David, right, as an individual. Here, these are two different people, so indeed is not a good fit. But I think this is just a good example where it's more that D fits better. It likewise fits better. And so that's the one I'm going to go with. I'm going to double check. Yes, it is the right answer. So there we go. That's how I would do this one. But notice those words, I'm highlighting them for your benefit. But to be quite honest, when I read this, it's almost like I see them highlighted already. As I'm reading them, it's kind of like popping out, right? That's how you want to train your brain, is to latch on to those kinds of words and be like, oh, there's a reason they're saying this, right? Unconventional, unusual. Those are not there by accident. I don't care that it was graffiti art. I don't care that it was ice or charcoal. I don't care about that. This is a word that I know what it means regardless of context. And it's the fact that it's the same word twice, essentially. That's a big hint. That's the SAT giving you a clue. Let's move on. Another transition. So another one where we're going to categorize the words. For this reason is a so, essentially. I don't know if that's in the list. Yes, it is. For this reason in the list. B, then, is another sequence time word. In addition is and specifically is for example, and that should also be in the list. Yes, it is. There you go. And so is in addition. So there we go. These are meant to, I think these are the top 20. I think I at some point did a full census of all the transition questions released by College Board, and the top 20 were these ones, or at least the top 20 maybe that are in these four categories. I might be leaving out things like Indeed, but the fact is you're going to see these same ones over and over again. There are others, but you're going to keep seeing the same things. That's why it's better to spend time memorizing transition words than it is to memorize other vocabulary words, because any vocabulary word is more random. So let's look again for strong words as we read. Mary Ellen Pleasant, a successful entrepreneur during the Gold Rush era, earned the moniker Mother of Human Rights in California after successfully challenging discrimination in the state. So she's successful. She's successful again. Earned, all these positive words, right? Challenging is good when you're challenging discrimination. In 1866, she sued a streetcar company for denying her and other black riders service, a suit she eventually won when the California Supreme Court declared it illegal for carriers to exclude passengers based on race. So this sounds like an example, just some reading, right? Mary Ellen Pleasant was a successful entrepreneur. She successfully challenged discrimination. For example, in 1866, that feels right. Let's double check. So could it be so? Mary Ellen Pleasant, a successful entrepreneur in the gold rush era, earned the moniker Mother of Human Rights in California after successfully challenging discrimination in the state. So in 1866, she sued a streetcar company. No. That makes it sound like the suing of the streetcar company happened because she had already successfully challenged discrimination. That's not what we want to say. The suing of the streetcar company is the example of her successfully challenging discrimination. So this is wrong. It's not a time thing for the same reason. There's not two events here. There's one event. And for example, is a perfect fit. This is the example of her successfully challenging discrimination. So that's all good. In addition, isn't necessarily like terrible here and is never really going to be like wrong. We could always kind of talk by saying and just moving on to our next point. But the thing to know for and words is generally they're going to be our last resort. We're only really going to pick them if everything else fails. Maybe there was a little of that last time with the indeed, where indeed is also kind of like a don't pick it unless everything else fails. But yeah, this is a case where I don't even need to really consider it. This is very clearly an example. So hopefully by simplifying these words to their category, you're able to notice the relationship very quickly. To me, this is obvious that we are giving an example of the challenging of discrimination. And so we're just matching that. So yeah, D is the answer. And another one of these, as a result, is so. I feel like we've seen that one before. In other words, is its own thing. So we'll talk about that one, but let's keep moving for now. In addition is and for example is for example. So yeah, in other words, kind of lives in its own world. I'll say this for now. In other words is almost always wrong. It's a very common answer choice, but it's almost always wrong. But it's not always wrong, so you can't just eliminate it, but it's got a very specific usage, and it literally just means what it says. We are about to say the same thing that we just said in other words. We're not going to add to it. We're not going to draw some conclusion from it. We are just going to say the exact same thing and repeat ourselves, essentially. So this is for repetition. So let's see what we got. The Inca of South America used intricately knotted string devices called quipus to record countable information like population data and payments. They may have used quipus to record more complex information like stories and myths, according to researchers. So there's a contrast here, right? Something countable is mathematical, very straightforward, and yet there's something more complex. All right, so, okay, that doesn't sound already like an example. It doesn't sound like in other words, because you're not saying more countable information. You're saying something new. So this is a good example where I'd definitely get rid of B, because it would need to give more information about the countable information. Like I just need to say that twice. It's also, yeah, what did I say? It's not a for example, because it's not the myths and stories are not an example of population data or payments. It's not an example of something countable. You can't count a myth. So it's not an example. Together, both of these things are examples of things that the Inca did with the quipus. So this is where we have to remember to stay on task. Our task for these transition questions is not to summarize the entire passage. It is to fit a word specifically in that blank. So the passage as a whole is maybe some examples of what these quipus were used for, but the blank is not, the complex information, the stories and myths are not examples of countable information. So that's wrong. And it's not a result, right? The fact that they're using these things for stories and myths, that's not a result. That's not a result of the population data, right? And you can just read the word so in there. The Inca of South America used intricately knotted string devices called quipus to record countable information like population data and payments. So they may have used quipus to record more complex information like stories and myths, according to researchers. No, the fact that they're using it to count doesn't cause them to also use it for myths. That's not the thing. So here, I said something before that we don't pick and words unless everything else fails. Here, everything else failed, right? Nothing else makes sense. And it makes sense that we would use an and because they used it to count stuff and they used it for stories and myths, right? It's a perfect and, it's adding on. So yeah, that is the answer here. This is me just following the strategy. I'm not picking C first, even though it's the right answer. I'm not looking at that and going like, oh, that's definitely it. I have a process. I have to look at the other choices and make sure, because a lot of times there will be an and word that kind of works, but there's something else that's better, that conveys that relationship better. And we have to make sure that that's not right first. So let's take a look at the next one. This is a good question. All right, now we're on to these outlines. And this is these are always gonna be the last question. They're always gonna be some of the easiest questions. And this is why, again, we wanted to start with grammar, is I don't want you rushing through these at the end. It looks like there's a lot to read, but they're actually really simple. So we wanna make sure we have enough time to do these. These are easy points. So how do we do them? We follow the instructions. We read the question first, right? So here is what we're gonna read. It's going to give us an instruction about the goal that the answer choice needs to accomplish, and we're just going to follow that instruction. So I'm not going to read the bullet points. I'm going to read the instructions. So read the instructions. The student wants to emphasize Janaki Amal's achievement. So let's read here. We're going to emphasize the achievement. I don't even know what the achievement is, but I'm hoping that by reading these choices, I know what it sounds like to emphasize an achievement. And so this is where the strong words filter comes in, is we're just going to filter out any choices that don't sound like they're emphasizing some sort of achievement, right? If it doesn't accomplish that goal, just get rid of it. So A, by crossbreeding the imported sugarcane species Saccharum of whatever with grasses native to India, Amal succeeded, that sounds like an achievement, in creating sugarcane hybrids well suited to India's climate. Now that may just be all made up information. Maybe he didn't do that. I don't know. But sounds like an achievement. So we'll just kind of keep it like that for now. Let's continue to B. In the 1930s, the Imperial Sugarcane Institute, which enlisted Amal, sought to limit dependence on imported sugarcane. Well, okay, but did he succeed in doing that? Did she? I don't know if it's a man or a woman, but doesn't matter. It doesn't sound like they achieved anything here. So this is just a statement about what they wanted to do, but there's no achievement. Amal was enlisted by the Imperial Sugarcane Institute at a time when a local variety of sugarcane needed to be produced. Did they achieve the production of it, right? Did they do that? I don't know. This is just saying what they needed to do. An achievement means that there's some sort of accomplishment of that goal. D, as part of efforts to breed a local variety of sugarcane, an imported sugarcane species called whatever was crossbred with grasses native to India. Okay, was it successful? Did this person do it, right? Like, this is a good example of like, I don't need to read these bullet points here. This is the only thing that accomplishes this goal, right? The instructions were clear. I don't care if this is the most interesting sentence. I don't care if it's complete in terms of what I'm supposed to know about Amal from the bullet points. I only care what they asked me for, right? So this is a clear case where I'd just be picking this and moving on, and I would be right. A is the answer. So if you wanted to, you could always go in here. Some of the hard ones we'll probably see in the hard module. We may need to do that, but most of the time, if you know what the goal is asking, is only going to be one answer that even makes any sense. All right. Student wants to specify how the salt enables energy storage. So for me, the key word here is how. That's an often overlooked word, but if you describe how something happens, it needs to, I kind of almost need like a process, right? I need some sort of mechanism. So I'm also looking at this part about, how the salt enables energy storage. That's important too. But the word how stands out to me as a very strong word in the instruction that might be overlooked. So let's take a look. Scientists have developed a freeze-thaw battery that contains molten salt, which liquefies when heated and solidifies at room temperature. Okay, but how does that enable energy storage, right? I can kind of even just turn this into another question. How does the salt enable energy storage? If the choice doesn't seem to be answering that, it's not a good choice, right? So is the liquefying or the solidifying the thing that does it? This has nothing to do with energy storage. So this just seems wrong to me. It doesn't seem to answer that question. B, the stored energy in a freeze-thaw battery, which contains molten salt, can be used by reheating the battery. Okay, the stored energy in a freeze-thaw battery, which contains molten salt, can be used by reheating the battery. So how does the salt enable the energy storage? It is molten? I don't know. I don't like this choice. I feel like I'm stretching it. But, sometimes with these, we don't have the background information, right? So we should just kind of be generous and keep a choice around. So maybe this works. C, when the molten salt in a freeze-thaw battery solidifies at room temperature, energy stops flowing and can be stored in the battery. So how does the salt enable the energy storage? It solidifies and energy stops flowing. I feel like it's easier for me to answer the question with something like this. So, okay, let's look at D though. Molten salt allows a freeze-thaw battery to retain 92% of its charge after 12 weeks. Okay. How though? How does it allow it to change its charge, to preserve its charge, right? Like, how does that work? So far I'm leaning towards C, but this might be one where I'm going to go to the outline because I'm a little uncertain. You know, it's the first module too. I probably have time. So I might just want to be sure, like, let's make sure this is actually getting to the answer here. So it says the freeze-thaw battery can retain 92%. The battery contains molten salt, type of salt that liquefies when heated and solidifies at room temperature. When the salt is in a liquid state, energy flows. When the salt is in a solid state, energy stops flowing and is stored in the battery. So how does the salt enable the energy storage? It solidifies, right? It's kind of what we're saying. The stored frozen energy can be used by reheating. Okay, so when the molten salt in a freeze-thaw battery solidifies at room temperature, energy stops flowing and can be stored, right? So it's saying the right stuff. It's answering this part of it. This feels right. This is, the facts are correct, right? If it solidifies, right, the energy stops flowing. That's what it says. The energy stops and can be stored in the battery, right? So there you go. That seems right. And that is the answer here. So there we go. But this one took a little bit more work, mostly because it's the science stuff that I'm a little nervous of. You know, you're not supposed to know anything about this topic in order to get this right. But, you know, it's okay to be a little bit nervous and just be like, maybe I'm misjudging this or misreading this or something. But the bullets are there if you need them. But I really think this all starts with the word how, and understanding that, like, basically, even though this is written as a sentence, it functions like a question. And so if we turn it back into a question, we should expect to find the answer very easily in the correct answer. And so that's what the difference between, for me, like B and D versus C is. I feel like in order to answer the question, how does the salt enable energy storage, I have to kind of like twist these words and interpret things. Whereas with C, it just says it. How does it enable energy storage? Well, it solidifies and that stops the energy flow and that allows it to be stored. Right? I'm mostly just reading choice C to get the answer. That's a good sign. That's what we want. All right, so where to next? Well, we got to go back. We got to go back to the beginning and do question number 1. All right, so let's switch this over to vocabulary. And it's pretty simple steps here, right? So first things first, we're going to read the paragraph. Read the paragraph. We don't know anything. So read the paragraph, look for strong words that relate to the blank or underline. So very similar to what we did for transitions, right? Pay attention to connotation, repetition, contrast. So think about that again with the transition questions. We were thinking, are these contrasting? Is these examples, right? There's certain kinds of relationships that exist in English between sentences that we just kind of use again and again. So we shouldn't be surprised if they keep coming up again and again in SAT questions as well. So strong words, it's a hard concept to define, but essentially the more you do it, the more you kind of hear me talking about it, the more you'll get a sense of what counts as a strong word. Carmen Lomas Garza is not a strong word. I don't care about this person. No offense, Carmen. I don't care about you. This isn't about you. This is about this blank. So let's see. Whether Carmen Lomas Garza is creating small paintings and illustrations or large public artworks, is a little bit of a contrast, small, large, such as Baile, a copper cutout of traditional Mexican dance in the San Francisco International Airport. She is blank direct experience, drawing from memories of her childhood in Texas or details of her current surroundings in California. So I like this word drawing. And I like the structure here. She is blank direct experience, drawing from memories, right? You can tell with this comma that the part after the comma is kind of defining, repeating what came before it. So this is where the dumb summary step comes in. Come up with your own simple word for the blank or underline. As much as possible, steal the strong word from the paragraph. Watch out for twisted relationships such as negative words right before the blank. Well, we don't have any of those right now. So how am I going to fill this blank? Well, I'm just going to use the word drawing again. Right? So my dumb summary is drawing, right? Or sorry, drawing from, if we want to make it really fit, right? So she is drawing from direct experience, drawing from memories of her childhood, right? So drawing like extracting, right? So let's see if there's now a word. Let's make a match. Is there a word in the choices that kind of goes with that? So drawing from something is complemented by it? No, compliment someone is to see something nice. So she is uncertain. No, uncertain has nothing to do with withdrawing something, right? It has nothing to do with that. She's unbothered by it. No, that doesn't even make any sense. This is not about whether she's annoyed by anything. If you're inspired by experience, you are drawing from that experience. It is influencing you. So yes, that seems like a good fit. Everything else here is just kind of random. So there you go. But, would you have gotten this answer right just by kind of reading the 4 choices in the blank and kind of seeing what sounds best? Yes, probably. This is not a hard question. But it is one where if we can do the strategies on the easier things and get used to that, then when we really need the strategy, when we really need this kind of training, this way of thinking, then it's already deeply implanted in our minds, right? So this is why even on easy things, I'm going through a process. I'm looking for these certain kinds of words and I'm filling in the blank. I'm using my scratch paper. All of this stuff is less about the easy questions that I know I'm going to get right anyway. It's more about setting myself up for the hard ones later, right? So use that first module to kind of start getting everything in place. You're really going to need to be much faster about this when you get to the hard module. So that was the answer. By the way, D is the answer. Let's look at number 2. And same thing. Let's kind of read it. So disproving the common misconception of native art as blank. So already I'm nervous. These are both negative words. So this kind of gets to some of this here that I'm trying to highlight. Right there. So I don't know what they do yet. I'm not going to worry about it. I've got to read everything, but I'm already aware of these strong words having an effect on that blank. So disproving the common misconception of native art as blank. The painters whose work appears in the collection of the National Museum of the American Indian employ a range of styles. Okay. There are artists working in the traditional arts of their specific tribal communities, artists working in European modernist or abstract, American abstract expressionist art traditions, and artists blending various traditions to do something wholly new. So this last sentence is just reiterating the main point, right? The strong word here is range of styles. And so this last sentence is just telling me a range of styles. So this blank has something to do with that. But notice, what do we have right before the blank? Disproving the common misconception of native art as blank. So native art is range of styles, right? So this blank is saying the art, how can I phrase this? So misconception, meaning an incorrect belief of the art, is going to be what then, right? So if we're negating what we're saying, right, then we want to say it's not a range of styles, right? So I'm going somewhere with this, trust me here. Essentially, my dumb summary is going to be unvaried, right? This is my dumb summary for the blank. That's what I want to put in the blank. The reason I'm coming up with that is they're saying that these people have a varied type of art. It's got a variety of styles, right? A range of styles. It's varied, right? So the art is varied. So we're disproving that the art is unvaried, right? Notice there's this double negative thing happening. This is what we worry about. This is what I call a twisted relationship, right? They're messing with us. We understand what the passage is trying to say, but the blank is undermining that passage. It's saying the opposite because of these kind of negative words. We're disproving the idea that it's unvaried, and now we're saying that it is varied, right? So if it's not unvaried, it is varied. Hopefully that makes sense, because that's the whole point, is they're trying to confuse us here. But essentially now I know what I'm looking for. I'm looking for a word that means unvaried. Uncontroversial, that means that we're arguing about it or we're not arguing about it in this case. So nope, doesn't matter. Individualistic, well, that to me sounds like it means varied, because if you're an individual, if you're doing your own thing, then it's specific to you. But we want to say that it's not individualized. It's this kind of the same. Theoretical, that doesn't make any sense. That's to do with like theories and science. Homogeneous or homogeneous, depending on how you pronounce it, means that something is the same throughout, right? It's consistent. It's unvaried. This is like a perfect case where like a harder version of a very simple word exists, right? Like this is what I think of as like a classic SAT word, right? There's a common word we all know that we use all the time, and then there's an SAT word that means the exact same thing that, most people don't know. And so that's where we get these hard questions. So this to me is obvious because I know that word. But I don't think even knowing that word guarantees a right answer here because of the twisted nature of this passage. But notice that I saw the danger coming within the first 2-3 words of this thing, right? I knew that they were messing with the way that blank was going to relate to everything else. You have to train yourself to know that too. Negative words near the blank, that's something to pay attention to. So This is, according to College Board, this is a medium question. I would say it's venturing on the harder side, but it's still following a very predictable pattern. Let's put it at that. It's following a predictable pattern. Even though we're flipping the meaning, it's a very clear opposite. So yeah, that's how I think about it. All right, same thing. Let's go to the passage. Recent measurements of the mass of the W boson, a subatomic particle, were notable not only for the mere fact that the particle's mass differed from expectations. So this is kind of a structure here. Not only for the mere fact that the particle's mass differed from expectations, but for the blank of that difference. The measured mass of the W boson was 7 standard deviations higher than predicted. So you don't have to know what standard deviation is to know this. It's different from what's predicted, but the standard model of particle physics. So it's not only that it was different, but it's the size of that difference. Now, I'm not necessarily stealing a word here, right? I'm kind of filling it in with my own instinct, but you're telling me it's a very, very big difference, right? So that's kind of, it just makes sense to put a word like that. Not only, but also is a tricky thing in English because it sounds like a contrast, and it kind of can be, but it's usually a way to kind of heighten something, right? It's not only that it was different, but that it was very different, right? That's essentially what that phrase does. So it's good to get comfortable with that. You'll see that in SAT questions. But essentially now I'm looking for a word that means size, cause, no, existence, no, implication, no, scale. Yeah, the size of something, the scale of it. Yeah, this is obvious. Let's see, what is the College Board thing? Yeah, they also think it's a medium question. I agree with that. But yeah, this is one where, right, it's not a contrast in the more classic sense of like positive, negative, but we're showing some sort of difference, right? And so ideally, like I said, we would like to steal our dumb summary from the words that are in the blank, but you want to be able to do that, right? This is kind of a long series of strong words together that kind of convey a very strong idea. And so I'm just kind of summarizing that idea for the blank. Moving on. More of these. Okay. Birds sing to communicate over potentially great distances. For this reason, many researchers believe that birds in densely vegetated habitats generally sing at lower frequencies than birds living in comparatively sparse habitats, since dense vegetation tends to blank the distance that high frequency sounds can travel. Okay, I remember this question being a little weird. So I definitely noticed we're making some sort of comparison. We're talking here about the dense vegetation, right? So densely vegetated sing at lower frequencies, right? Okay. Dense vegetation is blank. The distance high frequency. So I don't know. Stop. I don't know. I don't know what's going on here, but there's some sort of relationship. Maybe if I knew more about how sound worked, it would be easier to fill in that blank, but sometimes you don't know. So let's just kind of go with that, right? Let's just try out the different choices, right? So let's try exceed. So dense vegetation tends to exceed the distance that high frequency sounds can travel. No. Exceed means to kind of go beyond. So you might think of exceed here meaning like it lengthens the distance. It makes the distance longer, but that's not what exceed means. It's not how it's used. So in this case, we're saying that the vegetation exceeds the distance that the sound can travel. That makes it sound like the vegetation, the trees, are traveling further than the sound, right? Like the trees themselves are getting up and moving and going faster and going out of the range of the sound, right? The birds are too loud and too annoying, so these trees have had enough. They're out of there. They're out of the forest, right? That literally doesn't make sense, right? That's not what we're trying to say. This would be a case where I think if you picked A, the problem here is something that I call usage, right? Exceed, in a very simple sense, means to go beyond, to make larger, right? So it in a very simple sense, you could talk about distances getting longer, but the usage of this word in this blank doesn't make sense when you have the deeper understanding of how the word exceed is used. That is something that's very hard to pick up if English is not your first language, because it's not enough to just memorize a definition. Based on the definition, exceed isn't such a bad thing to put in this blank. And this is why I'm struggling to explain why it's wrong. It's very much just like, it doesn't make sense. So if you picked it, because it sounded good to you and you kind of had a rough definition. I understand, but it is not used in the way that this blank needs us to use it. And sometimes that is what happens. And for people who are not native English speakers, that can be very frustrating. My advice is just keep reading things in English, keep watching TV, watching movies in English, and you will just, without even realizing it, pick up more and more of that kind of comfort with the language that you need to eliminate a choice like that. Diminish, though, okay, so dense vegetation tends to diminish the distance that high frequency sounds can travel. Well, even though that's the opposite meaning in like a very simple sense, that word could work, right? If the dense vegetation diminishes the distance, right? I mean, in that sense, it causes the distance to be less, right? So, okay, does that make sense, right? So if the birds are in the densely vegetated habitats, they're singing at lower frequencies than birds in sparse, meaning more spread out habitats, since the dense vegetation tends to diminish the distance that high frequency sounds can travel. So notice the contrast there, right? Higher and lower. So they're not singing at higher frequencies because the dense vegetation is making it so that high frequency sound can't go very far. So they sing at a lower frequency to get past the fact that the vegetation is silencing them in a way. So that does make sense. Usage-wise, that could work. We're saying that the vegetation is causing the distance to shrink, not that the vegetation itself is going a shorter distance. The vegetation is stuck there. Now, encompass means to kind of surround. You can't, in this case, we're not really talking about encompassing a distance. We're trying to change the distance in some way, affect it. So encompass just means to kind of surround. I don't even think this makes sense in a usage sense either, right? I don't know that you would ever say that like a forest encompasses a certain distance. It encompasses maybe a certain area, but distance is like a linear distance, not area like a forest can cover. So this also just feels wrong for kind of not making sense in English kind of reasons. A lot of people also pick conceal here. Conceal is a word that means to hide, but you're not hiding the distance, right? It's sound. It can't see anything. So it's not concealing the distance that high frequency sounds can travel. It's not like we're, unsure of how far the sound can go. If anything, the birds know how far the song can go. That's why they're changing their frequencies of their songs so that they can overcome this limitation that they're facing. So conceal is about hiding things. You don't hide sound. It doesn't make sense. It doesn't make sense again. So I do think that this is a case where usage is a big factor here. If you know the simple definitions of these words, I think a lot more choices sound good here. But if you're much more comfortable with English, only B makes sense. So if that's the reason you got it wrong, that's frustrating. But luckily, there will not be many questions like this on the test. So that's a good thing. Okay, now we're at the passages. And so this is where, on the real test, even in the first module, I would say you want to start thinking about your pacing. And even if you still feel like you got plenty of time, passages can suck up a lot of time without you realizing. So you want to be looking at things and saying, does this one look like it's going to take a long time? Does this one look like it's going to be kind of hard? Even in the first module, there can be a passage that comes up pretty quick that takes 4 or 5 minutes. And that suddenly takes you going from, I have tons of time and I'm very comfortable, to, oh my God, I'm going to have to guess randomly, right? So we kind of need to go into the passages knowing that danger is always lurking. So you're always trying to think of, let me skip around and find the easiest things to do. To me, this isn't going to be a bad one because these choices are kind of short. It's a literature question, but 1943, that's fairly recent in terms of the English language. If we were talking about 1843, maybe you'd skip it because language has changed a lot in that time, but this is very modern, so it should be fine. And we're asked a very general question, main purpose of the text. So just follow the instructions. Most of the time, the instructions will be fairly straightforward like this one, and so nothing there. Now we're going to read that passage, though, and see, as always, if there's certain strong words that convey a lot of meaning. So Francie, a young girl, visits the library often. All right, good. Good for her. Francie thought that all the books in the world were in that library, and she had a plan about reading all the books in the world. She was reading a book a day in alphabetical order and not skipping the dry ones. She remembered that the first author had been Abbott. She had been reading a book a day for a long time now, and she was still in the bees. Already she had read about bees and buffaloes, Bermuda vacations, and Byzantine architecture. For all her enthusiasm, she had to admit that some of the bees had been hard going, but Francie was a reader. So this sentence kind of summarizes the whole thing, right? This is a case where there's so much repetition, right? All the books in the world, right? As she's reading all the books, she's reading, right? She's not skipping, right? She's reading again, reading. So what's my dumb summary of this passage? Let's go here with it, right? She reads a lot, right? Dumb summaries. There's a reason I call it dumb summary. You do not need to kind of be descriptive here, right? Like just get the main point. You're not impressing anyone by providing more details. You do not need to summarize the fact that she read about bees and buffaloes and Bermuda vacations. That's an irrelevant detail that simply conveys the larger, dumber point that she's reading a lot. So, okay, let's see if there's something that sounds like that she reads a lot. To illustrate Francie's enjoyment of an unusual topic. Well, this is where we're kind of looking for trap answers here. This is also back to strong words, is as I'm reading these choices, I am kind of like looking for words in the choice that can have a pretty powerful effect, right? So unusual. Is this about an unusual topic? Well, maybe some of these topics you would find unusual, bees and buffaloes and Byzantine architecture, but it's not an unusual topic. It's not one topic that she's reading about. She's reading about a bunch of different things, right? So that one word unusual stands out to me. It conveys a very strong meaning. So I don't like that for this choice. It's not also related to our dumb summary here. B, to explain why Francie prefers reading over other activities. Well, I love a question word in a choice because it allows us to turn the choice into a question. Why does Francie prefer reading over other activities? If you can answer that question by just reading something verbatim back to from this text, that's a good choice. So why does Francie prefer reading over activities? Does it ever say here? It says she's reading. Why is she reading instead of playing hopscotch or video games? I don't know. Because she likes to read? I don't know, right? See, I'm guessing at the answer. That's not good. The answer's got to be there. So there's nothing there. Plus a preference, right? As I don't know why she prefers it. That has a lot to do with maybe making a comparison. So I don't like that. But let's look at C. To portray Francie's determination to meet a goal. Okay, so here's a good example of I don't have a question word, but I have an ability to turn this into a question. What's the goal, right? What's the goal? The goal is to read all the books, right? She had a plan. Let's use pink here, right? A plan to read all the books in the world. Is a plan a goal? Yeah, seems good. Is she determined to do it? Well, she's reading about all these bees and buffaloes despite maybe not liking it, right? It's hard going, right? So, can't highlight well today. I don't know. Seems like she's pushing through even though she maybe not want to. So she seems determined, right? That's its own little strong word. So two things in here that are pretty important ideas, very strong ideas, and both of them check out, right? So not everything that's strong is bad. It's just giving us something to go look for in the passage. Let's look at D though. We can't just pick the first thing we like. To describe a book that Francie greatly admires. Okay, well, if it describes a book that she greatly admires, what is the book? Does it mention a single book here? Well, not really. Maybe one was written about Abbott. It doesn't say that she greatly admires it, though. She remembers it. Is remembering something the same as greatly admiring it? I don't think so, right? So it lists a bunch of other books in the middle here, but nowhere does it say that she greatly admired these things. So this is another one that's just too strong. It's saying things we don't have. So yeah, not a hard question. But even on this one, where maybe you would have picked C kind of just naturally anyway, it feels like a good summary of the passage. There's still a process that we're following. And with reading across the entire section, we don't know if a question is hard or not as we're doing it, right? It might seem really easy, but then have some sort of trick that most people are falling for because they're missing a key word in the passage, right? Or it may seem really hard. It's very dense and very difficult topic. And yet, because there's a strong word that's very obvious, the answer is very obvious. And so sometimes it's also hard to read the other way. For reference, the College Board considers this a medium question. And yeah, I kind of agree. I think it's easy, but fine. All right, let's move on. And yes, just to confirm, C is the answer. Which choice best describes the function of the underlined portion? This is basically another main idea question, except now we're focusing on this. But even though our question and answer are going to be mostly about that, we still need to read everything. So let's see what we get. The people of medieval Europe have traditionally been seen as uninterested in cleanliness and hygiene, but modern research has shown that this is largely a myth. So anytime I see the word but in a passage, it's interesting to me. I often say that but is the strongest word in any passage. Oh, I say it right here. The strongest word in any passage is but. Literally, it's a but here. And so why is that important? Well, we traditionally thought one thing, but modern research has shown something else, right? So sometimes that's important. According to historian Eleanor Janega, most medieval towns in Europe had at least one public bathhouse, which often offered both full immersion baths and more affordably, steam baths. While such amenities were available mainly to town dwellers, so that's a but, regular bathing in rivers and streams or daily sponge baths at home were common practices throughout medieval Europe. So not every but word is but, right? While is a but. It's showing a contrast, and that's part of our underline. So what's the function of this underlined portion? Contrast, something maybe like this. I'll try to use some of the dumb summaries that I have here, right? So I have these not equal ones, right? This kind of feels like in a way to say that like town is not equal to, what do they call it? Non-towns, like the country, I guess, something like that. There's some sort of contrast between how they bathed, but it's also kind of saying they both bathed. So you could also say it's kind of more of like they actually equal each other. They're doing the same thing. So different ways of looking at it. But notice it's about the relationship. I think this word while is going to end up being the most important word. But let's take a look. It asserts that in medieval Europe, steam baths are more popular in rural areas than in urban ones. Okay, so here we have one of our classic trap answer wedges, right? It's a comparison. We're using the word more. We're saying we're rating the popularity. So if I go here, it's saying what's available to town dwellers. It's contrasting what they did, but it's not saying one thing is more popular than another, right? It's not like they hated the whatever it was, steam baths out in the country, right? In the rural areas. It's not about what they thought of it. It's just what's available, right? So that's a difference. But notice I'm focused on the difference because I noticed a certain kind of word in the choice that is telling me like, is this comparison in the passage, right? It's giving me a task and then I'm going to check to see if that's in there and I don't see it. B, it describes a limitation of earlier historian studies of medieval European bathing habits. Well, I think that parts of the passage maybe do that, but I don't know that the underlined portion does. Right? So it describes a limitation, right? So, okay, what's the limitation? What's the limitation of the earlier studies? That amenities were available mainly to town dwellers? I don't think so. Maybe it's a limitation because there's an archaeological record of the steam bath because there's bricks or whatever and pipes. Whereas a river is always going to be just a river, right? So there's no evidence that someone bathed in it, I guess. But notice how much talking I'm doing. I don't like that. I don't like that I have to provide that answer. The underline should provide it. So let's look at C. It concedes that not all people in medieval Europe had access to public bathhouses, right? So concede means to kind of give in, right? So is it true? Are they conceding? Are they giving in that not all people in medieval Europe had access to public bathhouses? Right. Such amenities, the public bathhouses, right? These were mainly available to town dwellers. So not everyone had them because other people had to go to the river, right? So notice this also is giving me something to talk about. Not all people had access to these things. So that's kind of, in a sense, this idea of a quantifier, right? It's quantifying it. It's I'm not saying a specific number, but it's specifically telling me what number it's not, right? It's not all people, right? Or it's not zero people, right? It's the extreme ends of the number line, right? It's not infinite or the max, whatever that may be, and it's not zero, right? There's some middle ground, and that's okay. That's giving me a lot of wiggle room. So I like that, and it is true, right? That some people didn't have them. That says that. Let's look at D, though. It explains why Janega decided to study the popularity of public bathhouses. So we said this before. If there's a question word, ask the question. So why did she decide to study this? I don't know. She just did. I think it's an odd thing to study. She's thinking about dead people naked. I don't know. That's kind of weird. But hey, whatever gets you off, that's fine. So C seems to be the answer here. I can't answer this question. This one required me to do way too much talking. So this would be a case where I would pick C pretty confidently. And let me just verify. Yes, that is the answer. So there we go. Moving on. These are still questions I'd probably do. I'm thinking of ones I might skip, but the passage doesn't seem very long. The choices don't seem very long. So these would be ones I would just kind of continue to do in order. Main purpose of the text I love because just dumb summaries are great. So let's see. When classical pianist Martha Argerich performs, it appears, oh, it's a strong word, as if the music is coming to her spontaneously, right? It appears spontaneous, but maybe it's not. Let's see. She's highly skilled technically, but because of how freely she plays and her willingness to take risks, she seems relaxed and natural, right? She seems relaxed and natural. Her apparent ease, however, it's another but, is due to a tremendous amount of preparation, right? So the key here is now she's prepared, right? Despite Argerich's experience and virtuosity, she never takes for granted that she knows a piece of music. Instead, another but, she approaches the music as if encountering it for the first time and tries to understand it anew, right? So this is a lot to highlight, but it's strong in the same way that preparation is strong, right? It's hitting the same idea. If you take something for granted, it means you make kind of an assumption. You're overconfident, right? So she's not taking it for granted that she knows the music, right? She's not overconfident in her knowledge, right? She's approaching it as if encountering it for the first time. So I like that she's prepared, right? She appears to be relaxed. She's not. She's prepared. So what's my dumb summary? I don't know. Martha prepared, right? And so notice I have some sample dumb summaries here. I'll try to work them in as I can. To me, this kind of falls in this category with just me being a little bit more specific, right? X being Martha and good I've changed to prepared because they were more specific, but it's the same idea, right? That's kind of what we want to see. Versus maybe we could also even add just relaxed, right? I mean, that's another kind of idea they got, the comparison idea. But point is, dumb summary, just keep it dumb. You don't have to include everything. Let's look at the choices. Let the choices do a lot of the work for us here. To provide details about there's another question word, how Argerich identifies which pieces of music she will perform. So how does she identify which pieces? I don't know. It wasn't about that. It wasn't about the specific pieces she chooses. It's how she plays the pieces, right? So I don't know how she identifies them. I don't care. To assert that Argerich's performances look effortless. Okay, I remember reading that. That sounds pretty good. Because of how she prepares for them. Right? Prepared. She's prepared. They look effortless, but they're not. So I don't know. I like that. It might be leaving things out, but I really like that choice. So let's look at C. To discuss the kinds of music, Argerich feels most comfortable encountering for the first time. Okay, so what kinds of music is she comfortable encountering? Does it say, like, she likes classical, she likes modern, she likes, I don't know, the different types of music that she would even be exposed to. I don't know, I don't care, right? The point is, I don't know. It should say, right? So that doesn't make sense. What they're doing is what I often call a copy-paste trap. Let's see what happens if I do this and this. Oh, okay, cool. Copy-paste. They're using a phrase that they know you saw, and it's almost identical, right? Encountering for the first time, encountering it for the first time, right? So they know that you're like, oh, it's there and it's there. That's good. Matching, right? But just because the words match really well doesn't mean the idea matches, right? I'm focusing on more like a word like most, right? We're ranking things. We're saying we need to know exactly which kinds of pieces she's the most comfortable with, right? That's a comparison word. And they're not ranking the different things. In fact, when they talk about her encountering it for the first time, she's not actually encountering it for the first time. She's approaching it as if encountering it for the first time. That as if adds a tremendous amount to this passage. It's saying it's her mentality. She's thinking of, because she's prepared, she's approaching in the music, and she's able to kind of be very careful about what she's doing because she's trying to understand it anew. She's trying to get a fresh perspective on it. So just the way she prepares, but it's not literally someone's handing her some sheet music and she's playing it. That's not what they're saying. So this is a very big trap. They know you're attracted to long phrases that are repetitive. So they're trying to get you there. D, to describe the unique way, unique is very strong, that Argerich approaches music she hasn't performed before. Again, this is just wrong. It's a misreading of it. She has performed it. She has performed it. She's it's as if encountering it for the first time. As if means it's just a mental thing, right? Plus, unique is very strong, right? Like, this is unique. She's the only one who does this. Now, granted, this passage is only about her, but let's see. Does it say anywhere that what she's doing is unique, right? So when she does this, it appears blah, blah, blah. She's highly skilled. Doesn't say she's unique, right? Okay, she seems relaxed. Her ease is due to tremendous effort. Despite her experience and virtuosity, right? She never takes for granted that she knows music. She approaches music as if encountered for the first time. At no point does it compare Martha to anyone else. We get a lot of compliments of Martha Argerich, but we do not compare her to anyone else. Just because she's amazing doesn't mean everyone else sucks. And so to say that she's unique, we need in the passage it to say, no one else is doing this. Only Martha has figured out this special way of playing the piano. Doesn't say that. So even if you were confused about this idea of is she actually encountering her for the first time or not, it doesn't matter. You got to notice that word unique. That word is doing a lot of work here. And so there we go. Now we're picking B. I'm going to verify that that is correct. It is. This is a great question. This is a great example too of our dumb summary basically just being the choice, right? That doesn't always happen, but it's nice when it does. But a lot to take away from this one, a lot of things that I'd be noticing as I was taking this test. Again, this is grind mode. We're really looking deeply, but these are this kind of trap, this idea of what this means, all of these things, these words like unique, these are things I'm noticing instantaneously as I'm going because I'm prepared. It may look effortless when I do it and I take an SAT, but no, I am prepared. And notice how, this is great, I'm trying to act as if I'm encountering these questions for the first time, right? I'm talking you through the process as if I've never seen it before. I have the answers right here. I've taught these questions 1,000 times. So good for you, Martha. You and I are on the same page. We're doing the same thing. All right. Here's a question that even first module, I might skip it first. I'm going to do it in order just for the sake of the video being, coherent for people who are trying to find certain questions. But this might be one that I'd skip just because there's two passages. Look at the choices are kind of long. These double text questions tend to get a little kind of hairy. So I would just say, even first module, even if you got plenty of time left, leave this for last. Come back, do other stuff. But let's do it in order for the sake of just simplicity in the video. Same thing though, we're going to read the instructions and here they're important. How would the author of text 2 most likely respond to text 1, right? So sometimes this question is flipped. Sometimes it's saying, what would text 1 say in response to text 2? But no, what does text 2 think? So you don't have to do this, but for those questions where it's what is 2 going to say about 1, I like to sometimes read text 2 first because I want to know what text 2 thinks. That way, when I'm reading text 1, I almost have text 2's ideas in my mind already, and I can be like, oh, this is what they'd say. So let's do that, and let's kind of prep the dumb summary space here. All right, so text 2. So 2. The objects uncovered in this cave are intriguing, but it is premature to characterize them as tools, meaning it's too early to characterize them as tools. The stone pieces are so roughly shaped that they may have simply fractured from rocks during natural geological activity in the cave. Moreover, their unearthing has thus far not been accompanied by discoveries of other signs of human activity or even traces of human DNA from surfaces. So objects, not tools. That's essentially it, right? So I don't really know what we're talking about, but I seem to be clear what they're saying, right? Notice it starts positive, intriguing, and then it quickly flips. And that's why words like but are so important is, the second part of the but is usually the actual point, and the first part is just a distraction. Now we're going to read 1 and see what they're saying. An excavation of this cave that I cannot pronounce in central Mexico has upended the belief that approximately 13,000 years ago, a group known as the Clovis people were the first human inhabitants of North America. More than 200 crude stone tools were found embedded in a layer of earth that is up to 33,150 years old, revealing that humans occupied the cave thousands of years before the Clovis people reached the continent. So this is saying, the tools are important, right? Tools are good. Right, so they disagree, right? What do they disagree on? So here's now where my dumb summary might come in. Text 2 most likely respond to the underlying claim in text 1 is like, I don't know, I liked the word premature. I think that's a good summary of what's going on, right? They, it's premature to say that they're tools, or premature to say that people live there, right? Like just premature. It's text 1 is premature. Okay, so I don't know. Let's see if we get something like that. Let's shift this again. So text 2 would say, but would suggest that it draws a plausible connection between two groups of people, but will need to be confirmed with further study. So I like the end part. Confirming with further study kind of hits the idea of it's premature. What's the connection between two groups of people? What are we talking about? There's two groups of people? I thought there's one group. There's the people who lived in the cave, or maybe didn't live there, right? So I don't know. So I don't, this one doesn't make sense. I don't think it has anything to do with what we're talking about. I might keep it. Maybe I didn't understand something, but plausible, honestly, is the worst part here too, because it says plausible means possible. So this seems to be emphasizing the fact that these tools are useful, but his point is they're not, right? They're not tools. We don't know. So I don't know. I don't really like that choice. It's highlighted mostly because I just accidentally clicked it, but let's move on. By asserting that it rests on an assumption about the stone pieces that is not sufficiently supported by available evidence. This is just a fancy way of saying the objects are not tools, right? They might just be rocks. So I like that. Basically I would ask myself, what is the assumption, right? What is the assumption about these stone pieces? The assumption is that they're tools, but the evidence suggests maybe they're not. So I like that. That seems to be provable. C, by acknowledging that it will most likely be proved correct when the stone pieces undergo more detailed analysis. No. Proved is a very strong word, and correct is the opposite of what we want. They're saying, check 2 is saying they're not tools, right? So it's not that they're correct. No, it's not tools. D, by pointing out that it fails to account for evidence that the Clovis people were active on the continent as early as is commonly thought. Did I misread that? By pointing out that it fails to account for evidence that the Clovis people were active on the continent as early as is commonly thought. I don't even understand what I'm reading here. By pointing out that this statement about the people fails to account for evidence that the Clovis people were active on the continent as early as is commonly thought. Well, isn't the whole point here that humans were there before the Clovis people? That's the big claim. So this is saying there's evidence that the Clovis people were also there. Honestly, this is a good example where I didn't like A. If I'm choosing between B and D, I understand why B is provable, right? I can look at the words that are strong in B and be like, yeah, that matches with what I'm seeing. Whereas D, the fact that I'm even having trouble understanding what it's saying is not a good sign. So this might be one where I would bookmark it and be like, maybe I'm misreading something. Maybe this isn't making sense to me. But sometimes choices don't make sense because they don't make sense. And a big mistake people make when they're running out of time is when they don't understand something, when it doesn't seem to match with the passage and seems kind of random, they're assuming the problem is with them, right? They're like, I'm misunderstanding something. I didn't read it carefully. I don't know. But honestly, sometimes the problem is just the choice is wrong, right? It doesn't make sense because what it's saying is not in the passage. Before I talk a big game about that, let's be sure. Yeah, B is the answer here. So this is definitely a case for me, unless again, I'm misreading something that's obvious, but I just don't really understand what this says. This seems to be talking about the timeline, that we're disagreeing about the timeline of the Clovis people. No, we're disagreeing about whether these rocks are tools or just plain rocks. That's what we're disagreeing on. B is saying that. And it's not using the word tools, notice, but it's doing that SAT thing where it talks about the right stuff using more vague words, right? Less descriptive words that would kind of make us lose track of that. So yeah, this is a question. This is also a medium question. Okay. All right. Well, move on. This is another one that you might skip because look at how long those choices are. That's another kind of dead giveaway that maybe the question is a lot of trouble, is a lot of difficulty. And based on experience, I know people get this wrong a lot. I don't think it's that hard though. Let's see. Main idea of the text, right? So same as it ever was. Read, see what it says. Many literary theorists distinguish between fabula, a narrative's content, and sujet, a narrative's arrangement and presentation events. In the film The Godfather Part 2, the fabula is the story of the Corleone family, and the sujet is the presentation of the story as it alternates between two timelines in 1901 and 1958. But Love the but. But literary theorist Mikhail Bakhtin maintained that fabula and Suzette are insufficient to completely describe a narrative. He held that systematic categorizations of artistic phenomena discount, overlook the subtle way in which meaning is created by interactions between the artist, the work, and the audience. Now look, there's some complexity to what this is saying, but my dumb summary is not going to be complex, right? I'm basically going to say the fabula and the Suzette are bad, right? I'm going to basically do this kind of thing, this dumb summary here, right? X is bad. So we could swap that for insufficient, right? That's a more specific word that they use, right? So that's maybe better. It's more specific, but regardless, this whole first half is here to mislead you. It makes it seem like these concepts are very important and very good, but the word but switches this thing and turns it into no, this guy says they're bad. So let's see if that by itself helps, that kind of connotation idea. A, literary theorist Mikhail Bakhtin argued that there are important characteristics of narratives that are not fully encompassed by two concepts that other theorists have used to analyze narratives. Yeah, not fully encompassed is a more wordy way of saying it's insufficient, right? It's not sufficient. It doesn't completely capture it. So, okay, that's fine. What are the important characteristics of narratives that are overlooked? Something about the audience, right? They talk about some things, the subtle ways in which meaning is created by interactions between the artist, the work, and the audience. Okay, fine. I like it. But notice it doesn't matter, right? I don't need to get that specific for the choice. I just like this piece. Matches very nicely with this strong word. Let's move on to B. Literary theorist Mikhail Bakhtin claimed that meaning is not inherent in a narrative, but is created when an audience encounters a narrative, so that narratives are interpreted differently by different people. So notice just in a dumb way the difference between A and B, right? Well, let's compare. A is saying F and S are bad, right? It's saying those characteristics, those concepts overlook things, right? Okay, so it's matching with our dumb summary. B, on the other hand, let's do this so it's clear. B is saying, I don't even know, claim that meaning is not inherent in a narrative. So something else is good, right? Now notice the difference. They both might in various ways be kind of the same thing, right? If you're saying that these concepts are bad, it implies that other concepts are good. So right now, you might genuinely be between A and B and be like, well, they're just kind of two sides of the same coin. But I like that A is more the side that the passage was going with, whereas B is kind of this weird little thing at the end that I don't understand that's kind of coming in, right? This is about Bakhtin, but it's also about the fabula and the Suzette. A is more about those concepts, even though it doesn't mention them. B is now introducing something else, right? Some way that the audience is interacting with the narrative. Maybe that's down here. So maybe you keep B, but priorities, A still matches better with those strong words and dumb summary we had. So I'm liking that. Let's keep going though. We can talk more about A and B in a second. C, the storytelling methods used in The Godfather Part 2 may seem unusually complicated, but they can be easily understood when two concepts from literary theory are utilized. Well, what are the two concepts? The fabula and the Suzette. But easily understood, you're telling me this is good, right? So you're telling me these concepts are good. We want to say they're bad. This is obviously wrong. Obviously wrong. D, narratives that are told out of chronological order are more difficult for audiences to understand than our narratives presented chronologically. So we have a comparison, right? Was this comparing two different kinds of narrative and saying one type is better than another? They mention that The Godfather alternates between two timelines. So it is moving between. It's not chronological, but it's not saying that's good or bad or easier for the audiences to understand. This is comparing something that has nothing to do with the comparisons in the passage. So at this point, right, assuming you got to make a choice, you're running out of time, A is the obvious better choice. This is one where if pacing is your issue, you've got to realize that maybe you're not at 100% confidence, but you're pretty darn close. This is clearly like an 80% confidence. You've got A matching nicely with your dumb summary. B maybe we can tell a nice little story to make it fit, but A fits as it is. You've got to be able to pick that and move on. And look, if you really have time later, you can come back and start to go a little deeper into why A is better. But this would be, you got to know to pull the plug when you've got success. This is a great match. Now let's look at B more. Right, so he claimed, this is a more positive claim, that meaning is not inherent in a narrative, but is created when an audience encounters a narrative, so that narratives are interpreted differently by different people. So the part that stands out to me most is this and. Narratives are interpreted differently by different people. Does he claim that, right? So where do we get his claim, right? He claims here that these two things are insufficient. Then he held, right? So here's maybe his claim, that systematic categorizations of artistic phenomena, so that's still saying the fabula and the Suzette are bad, right? Discount the subtle way in which meaning is created. So the subtle way in which meaning is created by interactions between the artist, the work, and the audience. Okay. Does that say that narratives are interpreted differently by different people? It's saying there's a meaning created when the artist, the work, and the audience interact. Does it say that that meaning is different for every single member of that audience? No, it does not. Now, it's reasonable to conclude that that might be what he means, but it is not what the passage says. And you are not allowed to assume things, right? Whereas A, we don't need to assume things. He argued that there are important characteristics of narrative, the way these things interact, that are not fully encompassed by these two concepts, fabula and Suzette, that other theorists have used, right? Many theorists have used these things. He's saying they're not great. They're insufficient. They don't capture everything. A is provable every step of the way without us having to assume anything. It's just there in the passage. That is always going to be better when you're stuck between two choices than this kind of thing where you tell your own version of the story and make assumptions. So this is a great question. This one is considered hard by the College Board, and having taught it for a long time, people do get this wrong very frequently, and they try to argue with me. But this is a great example where if you truly understand the strategies, A is kind of like the obvious answer. If you're picking out the right words in the passage, in the choices, and if you're writing very simple, dumb summaries, A is obvious. So if you're not there yet, that's fine. But I love this question because if when this becomes easy for you, you're in 700, 750 territory. Okay, so this is the goal, to make this obvious. So try to think about that, I don't know, as you study. Let's continue. Let's do the next one. This is another one where you might skip it at first because I find sometimes these graph chart questions tend to be a little time consuming and annoying. But again, for the sake of just, we're going to do them in order just for simplicity's sake. Make sure you read the instructions. This one is very straightforward, but sometimes they have different instructions in the question that are very specific. So which choice most effectively use data from the table to complete the statement? We can see the statement ends in a blank. I would still read all of the passage. I don't want to read the chart. It's very obvious what it is, but I usually just go right to the passage. The passage is going to tell you what the chart or the graph means. So try to follow that as you do it. So the passage of time is among the many obstacles faced by scientists who are pursuing de-extinction efforts. That is, efforts to use breeding or a mixture of cloning and genetic engineering to bring back extinct species. Specifically, researchers are concerned the longer a species has been extinct, the less likely it is that a suitable habitat exists for that species. I'm going to highlight here. Among candidate species for de-extinction, this problem would be especially concerning. So basically, right, this is a good example of, well, what's the problem? The problem is that here, it's basically one of these. So we'll copy it in. Oh, I forgot you can't copy paste on this test. So we got to make do. No way to make arrows. So if you increase, what does it say? The length of extinction, then you decrease success. That you'll save it, that you'll get it back. So this problem would be especially concerning for, so now I want the thing that's been extinct the longest, right? It became extinct 11,000 years. That sounds like a long time ago. So I'm kind of summarizing and expecting them to talk about the saber-toothed cat because it's the most extinct of the things, right? So it would be, it'd be especially concerning for the passenger pigeon, which became extinct only a few years after the huia. No, not what I'm looking for, then that's fairly recent. The saber-toothed cat, which became extinct 11,000 years ago. Yeah, okay, fine. Woolly mammoths, which became extinct several thousand years before the saber-toothed cat. First of all, no, they did not. That's not how time works, right? So 11,000 years ago is before 6,400 years ago. So that's not even true. So no. The Caribbean monk seal, which became extinct in 1952. No, who cares? That's fairly recent. So there you go. It's what I expected. Notice it's giving us a sort of relationship. These are another kind of a relationship we see in all sorts of passages. This thing goes up, this thing goes down. You know, it's sometimes good to think in terms of arrows, and that's a benefit of scratch paper, is you can draw whatever you need, and you can't really draw arrows easily on a computer without random key combinations. So there you go. Let's confirm this is the answer. We should probably do that. Yes, B. B is the answer. Okay. How many more do we have? All right, 5. All right. We're getting there. This one's quick, though. These are the kinds of questions that if you are looking for passages that are going to be easy to do, boom, these are the ones, right? You might be scared it's a short story from over 100 years ago, but this is a great example where like the strong words are just handed to you, right? So we have to illustrate the claim. The claim is the strong words. In the story, the narrator expresses mixed feelings about her surroundings. Positive and negative, positive and negative. That's all that means, right? So it's a good example of like connotations really helping us. But there's no interpretation here, right? They're just telling you what they want. Follow instructions. This wallpaper has a kind of sub-pattern in a different shade, a particularly irritating one. Okay, so that's bad. For you can only see in certain lights and not clearly then. Well, this just sounds bad. This doesn't sound mixed. This is only bad. By moonlight, the moon shines in all night when there is a moon. I wouldn't know it as the same paper. I don't know if that's good or bad. That just sounds like a random thing about the moon. I'm really getting quite fond of the big room. All but that horrid wallpaper. So fond means you like it, right? So that's good. And then horrid is something's bad. It's horrible. So that seems mixed. I'm okay with that. Let's look at D though. The color is repellent. So that's bad. Almost revolting, also bad. A smoldering, unclean yellow, strangely faded by the slow turning of sunlight. So this whole thing is negative, but there's no positive. So these are quick. This would be a 30-second question if I did this on the test. So these illustrate the claim questions are some of my favorite. There's not that many of them, but if you can grab one, you got to skip to this and get this. This is an easy couple points. I should still confirm that I'm right. Yes, C is the answer. Good. All right. Another one of these, choices look kind of long. These are skips usually for most people. If the choices look long, it's probably a skip, but let's just see. Which choice most effectively uses data from the table to complete the comparison? The only flowering plant species native to Antarctica, this thing and this other thing, grow in places where the Earth remains free of ice for much of the year. This person wondered how the warming of Antarctica's climate in recent years had affected these species, so she visited a site in Antarctica first in 2009 and later in 2018 to count the number of plants growing there. Canone found that the area of land covered by the two species had significantly expanded during the 9-year period. Both species likely benefited from warming temperatures, the consensus... something. So the consensus is this one. So the bottom row. So it's compare the bottom row to the top, right? So the while, again, that's a but. So there's some sort of contrast. What's different? The area covered in both of them grew, but maybe grew more with the consensus. So that's maybe it. This is different. I don't know. Both species benefited, the consensus thing suppressed the growth of the other one, which covered a smaller area of land in 2018 than it had in 2009. Well, this is not true, right? So first of all, the first part's just bananas wrong, because we don't know that like one plant is killing the other off, right? That's a big claim. It suppressed, it stopped, it contained the growth of the other one. No, they're just plants. Right? So I don't know how they're affecting each other. But also this is not true, right? Am I misreading this? So the other one, the Antarctica, covered a smaller area in 2018 than 2019. No, it didn't. In 2018, 1,576 is bigger than 1,230. So no, that's just not true. It saw a greater expansion than the other Antarctica did, increasing the area of land it covered by more than half. Well, half would be 50%, so more than half, 55. And yeah, it's a greater expansion. 55% increase is bigger than 28%. So that seems right. C, it showed a greater increase in the average size of the individual plants. No, I don't know anything about the individual plants. This is just purely how much space they cover. So nope. Covered land newly freed from ice at a rate 55% faster. No, this is just a misreading of the chart. This is not a rate of increase. This is an area of increase, right? So this is just not understanding what the data is. I don't know this, right? This is not, it's not about speed. I don't know. So this is clearly better. Some of these choices we were able to eliminate because they were inaccurate. The numbers were wrong, but these other inaccuracies are less about like the data being wrong and more just like our interpretation of the data being wrong. So you got to be careful here. This is why you got to read the passage. You got to understand what they're saying basically. Cool. Let's move on. I don't know if you guys can hear that, but one of my neighbors sounds like they're having some sort of party at 5 o'clock on a Wednesday. Cool. All right. I can hear that music very loud. So yeah, B was the answer to the other one. It's distracting me. All right. Luckily, 3 questions left and 20 minutes. So we are using quite a lot of time, even with the double time. Okay. This is another one where you might want to skip it if you're even in the first module running out of time, or even before you start running out of time. Look at how long these answer choices are. This sounds scary, but let's see. This one also has a very specific instruction. This is why even though most of the passage questions are kind of repetitive in what they ask, you still need to read it, right? So which finding, if true, would most directly support the idea advanced by these people? At some point, it's just going to say these people's idea. So that's good. We're going to have a very clear, kind of strong word somewhere in this. As media consumption has become increasingly multi-platform and socially mediated, active news acquisition has diminished in favor of an attitude known as news finds me, in which people passively rely on their social networks and ambient media environments for information about current events. If you did not understand that, don't worry. I would not reread that sentence. I haven't gotten to the point that matters yet. I'm trusting the process here. I would be like, all right, that was weird. Maybe there's important stuff in there. Let's keep going. These people, the people I care about, examine data on a representative group of adults in the United States to determine participants' strength of NFM attitude, political knowledge, and political interest. Although, that's a but, no major election took place sufficiently near the study for these people to identify causality between NFM and voting behavior, they did posit, meaning suggest, that NFM may reduce voting probability through an indirect effect. Okay, that's it. Right? So what am I going to say about this? That's the thing I want to focus on. Yes, there's a lot going on, but this is basically saying an increase in NFM is equal to a decrease in voting, right? Through an indirect effect, meaning there's kind of something in between, right? There's some sort of X factor in between. I don't know what it is. They don't say, but there's something that's causing it, right? It's not just that NFM is affecting the voting, the NFM is affecting something else, and that's affecting the voting, right? So there's like a 3-step process. So maybe that doesn't matter. Maybe the point is just the voting decreases when the NFM increases. But notice how this dumb summary is very like directional, right? I like that. It's matching with these. So let's take a look and see if anything kind of sounds like that. Because we need to support that idea, right? If we had to weaken it, we have to change this relationship in some way. NFM attitude tends to increase in strength as major elections approach, and people are significantly more likely to vote in major elections than in minor elections. So no, right? What is this saying? This is saying an increase in NFM is equal to an increase in voting, right? Significantly more likely to vote, right? So no, that's the opposite of what we want to say. B, NFM attitude is a strong negative effect on political knowledge and interest. Okay, so what does that mean? Well, let's keep reading. And there's known to be a strong positive correlation between political knowledge and interest. Okay, so you got to know what these words mean, right? So if NFM has a strong negative effect, what that means is if you increase one thing, you're going to decrease the other, right? So if you increase NFM, a negative effect on political knowledge and interest, PKI, right? Okay, then it's giving us another relationship. There is a strong positive correlation between political knowledge and interest and the likelihood of voting. So I'm going to do something that seems counterintuitive, but I'm going to say that voting also decreases. Because what is a positive correlation? This is something you need to know for the SAT, right? Same as negative effect. Negative effect means they go in opposite directions, right? Sometimes it's called a negative correlation as well, right? They're opposite. One goes up, the other goes down. A positive correlation means that two things go in the same direction. So yes, it could mean that both go up, but since I already started my dumb summary with the PKI going down, it doesn't matter that it says positive correlation. It's still positive if the two are going in the same direction. So even though both of these are negative, they're negative the same way, right? They're positive in the sense that they are both moving together. That's what it means to be positively correlated, is you move in the same direction. You can write it as up and up, but because of the way we kind of framed this thing, it actually makes more sense for us to write it downward, right? Because I want to match my initial prediction, my initial dumb summary. So if I had flipped to the NFM, that kind of makes it more annoying to do that, because then I've got to kind of flip it again to match the thing. But notice, right? Increase in NFM. Something happens in the middle. Here's our something, right? So check, check, and then leads to a decrease in voting. All three pieces check out, right? They didn't say too much about this middle piece, so we have freedom there. But the point is the ends are the same, right? The ends are the directions we want. So I really like this. This is a good example, though, where you have to know terminology. You have to know what this means in order to be able to get this kind of relationship and understand what they're saying. So I really like it, but of course we've got to look at C and D and that. So let's look at C. Political interest is known to have a strong positive effect on the likelihood of voting. So okay, so political knowledge and interest is a positive effect. So you increase PKI, and you have a positive effect, meaning increase in voting, but shows only a weak positive effect on political knowledge. Oh, wait. Political interest is known to have a strong positive effect on likelihood of voting, but shows only a weak positive effect on political knowledge. So political knowledge and interest are now two different things. So, okay. And NFM attitude shows little correlation with either political knowledge or political interest. So basically, this is just saying there's no relationship at all between the NFM and the voting, right? They're kind of mentioning the PKI thing, they're breaking it apart, and then they're also saying there's no correlation, meaning the ups and downs, we don't know anything. So this is definitely wrong, because we need some sort of relationship. That's kind of the whole point. D, the likelihood of voting increases as the political knowledge increases. So political, knowledge. So increase in political knowledge leads to an increase in voting. Okay. This is so much easier to do on scratch paper, by the way. And the relationship between NFM attitude and political knowledge tends to strengthen as the size of people's social networks increases. Well, first of all, do we ever bring in the size of people's social networks, right? This is now kind of bringing in yet another variable that I don't think we talked about. Now, granted, we didn't talk about political knowledge and interest, so that's also new. But now we're adding like two levels of new things, intermediate, getting in between these two, right? So two X's essentially. But what I'm also confused about this. The relationship between NFM attitude and political knowledge tends to strengthen. That doesn't mean anything. That doesn't tell me whether they both go up or one goes up and the other goes down. That doesn't tell me if it's a positive correlation or a negative correlation. I need to know that to know if these arrows are pointing in the right direction. If the relationship strengthens, that just means, like, think of a scatter plot, like in math, right? Where you have all those dots and then the line that kind of goes between the dots and kind of like averages them out. The more the dots are close to that line, that's a stronger relationship. Now that line can go up or it can go down. The proximity of the dots to the line is what determines the strength of the relationship. So all you're telling me is these dots are close together, but that doesn't tell me the direction of anything. So this is leaving out the information I need to know what's right and wrong. So B is the answer. Even if you were a little unsure of that, I would hope that if you understood what B was saying, you'd be like, well, that's kind of exactly what I was looking for, right? It's got the right relationship. I don't need to interpret anything. It is what it is. So this is a great question. You're going to need this skill of the ups and downs and all that. So hopefully this helped you for that. This is definitely a question where on the real test, I am using my scratch paper for reading. This is way too much stuff to hold in your head. You got to write this out. This is going to be so much easier if you can see it on the page. And yes, B is the answer here. All right, two more. Okay. Logically completes the text. Some people hate these. I like these questions. I don't think these are so bad. So these are ones that I would tend to do. Even if I'm like slightly running out of time, I would prioritize this over maybe that kind of double text passage we saw before. So these, you just, the instruction is finish the story, right? So finish the story. It's going to lead you somewhere. Hopefully there's a clear conclusion. Let's see. In dialects of English spoken in Scotland, the R sound is strongly emphasized when it appears at the end of syllables, as in car, or before other consonant sounds, as in bird. English dialects of the Upland South, a region stretching from Oklahoma to Western Virginia, place similar emphasis on R at the ends of syllables and before other consonant sounds. Historical records show that the Upland South was colonized largely by people whose ancestors came from Scotland. Thus, linguists have concluded, right? So notice the word that I highlighted is similar. Focus on relationships. Relationships matter. You're telling me two things are similar? I'm going to focus on that. Right? Plus, you're emphasizing that by saying that the people from the South, this Upland South, came from Scotland. So linguists have concluded that, I don't know, they brought the R sound thing, right? Like that's what they came with it. They came with their language, right? So it makes sense that similarity is there, right? So I don't know if that's what we're going, but I get the point of this. Let's look at A. The English dialects spoken in the Upland South acquired their emphasis on the R sound from dialects spoken in Scotland, right? So the people from Scotland brought it with them, right? So that sounds right. B, emphasis on the R sound will eventually spread from English dialects spoken in the Upland South to dialects spoken anywhere else. I don't know about elsewhere. I don't care. Who cares? Scotland, Upland South. Stay focused on what it is, right? This is a good example of like this kind of small versus big confusion thing that I talk about in the trainer, where it's like a narrow example does not allow us to kind of make broad conclusions. Like I don't know what else is going to happen with this R. All I know is what happened in the past, what we're talking about here. C, the English dialects spoken in Scotland were influenced by dialects spoken in the Upland South. No, because the people from Scotland were the ones who went to the South. The people in the South are not going back to Scotland, right? You're switching the order here. So were influenced by is putting an order to this, but the Upland South was colonized by the people in Scotland. So you got to put the people in the right place, in the right time, in the right order. So this is switching the order. D, people from Scotland abandoned their emphasis on the R sound after relocating to the Upland South. No, this is the opposite. If they abandoned it, then why are the people in the Upland South sounding like Scottish people, right? Like the whole point is that they talk the same, right? So if they're abandoning it, then you got to explain where this R came from then. But it came from them. They say that, right? So this is obviously A. This is a great example of why, the pacing strategy matters, even in the first module. This is a very easy question, in my opinion. College Board says it's a medium question, but this is very easy and obvious. So I think the reason people get it wrong is they don't have time. So they're guessing randomly. So get to this question. Make sure you have time to answer it. All right, we got 10 minutes for one more. So let's do it as fast as we can. This one looks long, but let's see. In 2016, biological anthropologist Heather F. Smith and her team investigated the evolution of the appendix, an intestinal organ that is present in some mammals, including humans, but is generally thought to have no function. So no function. Studying 533 mammal species, the team found the appendix has emerged independently across multiple lineages in separate instances. So this sounds important, right? Independent, separate. Main ideas are repeated ideas. They're repeating that. And significantly, so they're telling you it's important, hasn't disappeared after emerging in specific lineages. So it hasn't disappeared. I don't know why that's important, but it said significant. So, okay. Moreover, the team determined that species with the organ tend to have higher concentrations of lymphoid tissue, which supports immune responses in the cecum, the organ the appendix is attached to. Therefore, the team hypothesized that the appendix, has nothing to do with immunity, right? So my dumb summary is going to be very simple, right? Appendix is a good version of it, but I'm going to go with appendix equals immunity, right? Because it's good, but it's specifically good for immune responses. They're talking about it that way. They're getting very specific about that. So yeah, I like that. So, okay, right? But notice how it started by saying there's no function. And then we switched, right? We moved through things and it changed, right? So remember, this is a story and the ending of the story is what you're filling in. So you got to be careful that you don't get too distracted by the first sentence, that it might switch as you go. So choice A, it was once present in many non-mammal species, but has since disappeared from those lineages. In a dumb summary way, is that saying that the appendix is for immunity? No. Plus, I don't care about non-mammal species. Right? We're talking about mammals, mammal species, right? Multiple lineages, right? This is about mammals. So don't bring in other animals. Let's stick to the ones we're talking about. B, has been preserved in certain mammal species because it benefits their immune system. Appendix equals immunity. Boom, love it. Let's look at C. Will emerge in a greater number of mammal species because it may serve a necessary function in the immune system. So notice how C is the same as B, but it's just like hyped up, right? B is just saying the simplest thing, right? Why is it still there? Because it benefits immune systems in some way, right? We're not getting specific. But now we're talking, okay, in the future, it will emerge in more, right? All these other mammals are going to start evolving appendixes because of how necessary they are, right? Necessity is one of those words you got to notice, right? Well, is it necessary? Right? Notice the difference, right? It benefits their immune systems. Saying it's good for the immune system is not the same thing as it's necessary for the immune system. So even in that simple, slight difference, there's a difference in degree. There's a difference in the intensity of what we're saying. So C is a great example of like just taking something very simple and very dumb and very bland and just ratcheting it up and making it too extreme. So this is obviously wrong for me, but I think it's a good little side-by-side comparison of like what the SAT is doing to make choices that kind of have a lot of good stuff in them still be wrong, is they take the good stuff too far, essentially. Let's look at D. What are we saying? The appendix likely produced higher concentrations of lymphoid tissue in mammals in the past than it does currently. So this is a comparison. We can see that in the word than. It's also a time thing, a time comparison, right? So we have comparisons or things to watch out for. Are we comparing different things in here in this passage? No, we're kind of just talking about the appendix. Are we talking about time? Where's time? Here, right? Are we making a comparison over time? Is it about the past versus the present? Not really. It's just saying, this thing evolved in the past and it's still here today, and sometimes it hasn't disappeared. So it's not really comparing what it does, right? So I don't know about higher concentrations of lymphoid tissue, right? This is a great example of like, don't overthink it. B is just so obviously a match that maybe D, you can kind of tell some sort of story about, because they do say like higher concentrations of lymphoid tissue. To me, this also might be another one of those copy paste traps that we talked about on an earlier question, where like they know you see this sciencey phrase and they are trying to lure you in with it. But no, this is very obviously just way too specific. This is so bland. We are going to run out of time, but B is the answer here. Right? Did we do everything? Yes. Okay. So just to this is a good point to end on for the first module, because we're definitely going to think about it again in the hard module. But so many times on these passages, we're fighting against an instinct that your English teachers have put into you, right? The instinct is be detailed, be specific, prove that you did the homework, prove that you read the chapter from the book, prove that you read the poem, the short story, whatever it is. Talk about it in very specific, detailed ways. Don't leave anything out. That's how we're taught to write essays, to talk about books in class and all those things. And that's good. It's not a bad thing. But on the SAT, that's not the game we're playing, right? If anything, on the SAT, we end up kind of doing the opposite a lot. The correct answer is often the most bland version of the summary, right? This is why I want you writing a dumb summary and not a smart summary. A smart summary is going to take in all the details. A smart summary is going to include every single point that seems even remotely important. We don't have the time for that. But we also don't need to do that, because the right answer isn't going to include all of those points either. It is a summary. It is including the barest essentials that we need. So for a question like this, B is kind of bland. It's leaving out things, right? Notice it says certain mammal species instead of naming specific species. It benefits their immune system. How? How does it benefit them? Maybe it means higher concentrations of lymphoid tissue. I don't know. I don't know if that's good or bad. But the point is, they're being very vague about the benefit, right? And the passage is maybe being more specific. So this is what frustrates people, is they get rid of something like B because they're like, oh, it doesn't say enough. It doesn't include all of the details. So you pick a choice like D because you don't really understand it, but because it sounds more specific. It sounds better. It sounds more detailed. It sounds more like what your English teacher would want. That is not the game we're playing, right? The more details you include, the more of those details that could be wrong. So what I like about B is it barely includes anything. So it's very easy for us to prove, right? All the two little pieces here are easy to prove with the passage. So when you have choices like, oh, is B or D right? What should I pick? The more vague the answer is, the more bland it is, that's usually a good sign. That's what you want. And if you have truly no clue what's going on in the passage, yeah, generally speaking, choices that sound like they say less are going to be better. So we're definitely going to pick up the pace a little bit in the hard module because this took almost 2 hours. So yeah, we're gonna try to pick it up, but hopefully just from the first module, you already see a lot of these patterns of thought that when we get used to them are going to be faster and easier in the hard module when we need them to be faster and easier. All right, before we start the next section, which will be the hard reading module, you can see that after I ended the first reading module, I got a break because I had turned on that extra breaks thing earlier. So not a bad thing if you're trying to maybe do a practice test a little bit more relaxed, can't hurt, but you don't get this break during the real exam. So let's hit resume testing. And now we are in the same place we were before, right? It starts with question 1, but we're looking for the first grammar question. 15 is a grammar question, but let's back up. 14 is a passage. So we're going to go to 15 first. And the same thing applies, right? We're going to try to predict the rule. I can tell what this rule is really easily. These are clearly verbs. And I can see that A is a plural verb. I'll just do PL. B is singular because of has. C is singular because of epitomizes, ends in S. And D is singular because of was. So A is probably the answer. But let's see if we can verify that. So we're going to read this sentence here. Such iconic French recipes described in surprisingly brief detail in Le Guide Culinaire blank the Victorian French cuisine Escoffier sought to preserve in his encyclopedic book. So I don't speak French, obviously, but does epitomize plural make sense here? Yes, because we're talking about recipes. So such iconic French recipes epitomize the Victorian French cuisine. Yeah, okay, cool. So nice and easy. Nothing really else to say here at this point. You either know that 3 versus 1 rule or you don't. And you can see even on a hard question tends to apply. I will verify it though. Let's get in the habit of checking those answers. And yes, A is the answer. So let's move on. Okay, so this one is about punctuation, right? And I see a period in choice B, and I also see a colon in choice D, right? So these two choices, B and D, are kind of like my top priorities. But, period is the simplest punctuation mark. If there's a sentence before and a sentence after, you got to use a period. So let's see. A ray diagram reveals how this works. Is that a sentence? Yeah, sounds like a sentence. I could just say that. Because the hole's small size restricts light to a single ray, all light passing through the hole can only arrive at a single destination, eliminating diffraction and ensuring a clear image. So there's also a sentence there. I do see some commas though. So whenever I'm dealing with punctuation and trying to think about sentence structure, I don't want to just pay attention to the punctuation in the choices. I also want to pay attention to the punctuation throughout the sentences, right? So what are these other commas doing? I can tell because of the ing verb here that this is an extra clause. And because starting the sentence is telling me we have another extra clause kind of starting things off. So the only part that really matters here in terms of sentence structure is what I just highlighted in blue. That is the sentence. That could stand alone. All light passing through the hole can only arrive at a single destination. I could have that with a capital letter and a period and all would be good. So this works. I would just pick this and basically move on. The only thing I might do is look at D and just be like, it's kind of weird that you have another thing that separates sentences. But if you notice, right, it adds something else here. It adds this it's. Now, why would that matter? Well, that wouldn't affect the yellow sentence here, but it's going to affect the pink and the blue because then this first pink piece becomes another sentence. It is because the whole small size restricts light to a single ray. That's a sentence. That could exist on its own because it's with an apostrophe is it is, which is a subject and a verb, right? So that's a sentence. Then we have the same sentence we had before in blue. All light passing through the hole can only arrive at a single destination. You are joining two sentences with only a comma. You can't do that. That's no good. That does not work. So this is a good example of overcorrecting. right? It's still got a strong punctuation mark that is necessary to separate the two sentences, but it's introduced a word that makes another third sentence, a third independent clause, and creates another kind of run-on problem later on. That's sneaky. It's also sneaky because a lot of people have heard this kind of fake grammar rule that doesn't really exist, but you might have heard this from an English teacher at some point, that you are not allowed in English to start a sentence with the word because. That is a thing that people say. That is not a real rule. I don't know why people say it, but it's a thing. And so some people are going to avoid be because they're going to say you can't start a sentence with because. But this is why, notice, where does that appear in my list of rules here? What you can and cannot start sentences with? Nowhere, right? And this is why this little strategy trainer is so helpful, is it keeps us focused. These are the rules. These are the only things that the SAT asks about. If it's not on this list, it's not on the SAT. So don't let fake rules distract you. Moving on. Okay, another punctuation situation. I see a colon here. So I don't know that it's right, but I'm going to certainly gravitate towards it first because it's high on my list. Dashes are also pretty high, but they're second. So let's look at that colon first. And again, I'm thinking, do I have a sentence before that colon? That's kind of what I'm asking myself. But this is a crazy long sentence. I see some dashes already in it. Oh my gosh, this whole thing is one sentence. So I'm going to read it, but I'm going to try my best to kind of follow the structure as I go. Long attributed to Jacques-Louis David, the preeminent neoclassical painter of his day, the 1801 painting Marie-Joséphine Charlotte Duval de... Why are these all in French? Whatever, gained fresh attention in the 1990s when art historians discovered that the painting, which depicts a solitary young woman sketching, was actually the work of little-known French portrait artist. Right, so I'm stopping there because if the colon is right, that's basically acting like a period. And so we would just stop, but it doesn't sound right there. And there's a lot of extra stuff, right? Long attributed, blah, 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 that's extra. The 1801 painting, the preeminent neoclassical painter, that's just a positive about Jacques-Louis David. So the real sentence starts here and goes to this dash. And the dash is an interruption, so let's ignore that. And then we're kind of maybe stopping at the blank is really how this goes. So let's kind of look just at that yellow. The 1801 painting, whose name I cannot pronounce, gained fresh attention in the 1990s when art historians discovered that the painting was actually the work of little-known French portrait artist. It's so close to being right and being a sentence, but it's missing something. It needs the word right here after of. This painting was actually the work of a little-known French portrait artist. Then C could be right, but as it is, it's not right. And for the same reason, A is going to be wrong because a single dash is going to behave like a colon. And so it's kind of the same problem. Now, it's weird because you've got other dashes in here, but these dashes are already doing their thing. We know what they're doing. They're adding an extra clause in the middle. They're interrupting the sentence. I honestly don't think you'd ever really want to write a sentence with 3 dashes because then it gets confusing which pair of dashes is the extra clause and which one is kind of like, I don't know, and the colon, the single one. But regardless, now I've got to decide, do I need a comma? And it's helpful here to think in terms of these rules. This appositive rule stands out to me. Because if I keep reading and it says little-known French portrait artist Marie-Denise Villers, I recognize that they're using that appositive rule. And, this is where we have either a kind of 2 comma situation when we have the term coming into the definition, or the 0 comma situation where the definition leads into the term, right? So let me get rid of this highlighting here because now we're really just focused on the end. So what's the term? What's the thing that if I wanted to know more about what was happening, I would Google it, I would put it in Wikipedia, Marie-Denise Villers. That's the term, right? Where's the definition? The definition is before little-known French portrait artist, right? So I'll put that in blue. So if the definition comes before the term, definition, term, then we shouldn't use any commas, which points me towards B. Now notice there isn't really a 2 comma option here, and why not? Well, because the second comma would just be the period, right? Like that's kind of happening no matter what. So there wouldn't be a reason to have the second comma because there's no more sentence after the name. But that's essentially what would happen if they kind of rearrange things, right? So they could do that blah, 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 this was actually the work of Marie Denise Villers, comma, a little known French portrait artist, period. That would be just as correct. And that's basically the 2 comma situation where the term, the name, comes first, then we're defining it. But notice again, there's not a second comma because the sentence ends. But it's the same idea. This one is sneaky. It's definitely something that people are going to get wrong because it doesn't look like an appositives question. B is the answer, I've just confirmed. But it's a good example of how this strategy really helps me because it kind of narrows my options, right? I took care of some easy punctuation marks to start, the dashes included. And then I'm still kind of like, all right, I don't want to just think about commas in a vacuum if I can avoid it. Commas are not set. There's really different reasons we might use a comma. But appositives are kind of an exception where the comma is kind of following a little bit of a rule. And so I'm able to apply that and kind of think a little bit more systematically about what's going on. So that really helps me there. Let's move on. Okay, so here I see dashes. I also see a colon, right? So colon, that's higher on my list. Let's do that first, right? So, and this is another longer sentence and another French person. What the heck is going on here? I think it's French. I don't really know for sure, but I'm just going to say call because that's what I want to say. Call paired excerpts of these conversations with photographs, both of interviewees and the items they described. Okay, so that would be a sentence, right? That's me testing D. Does that make sense? Call paired excerpts of these conversations with photographs. Well, that's a sentence, right? So that's fine. That could stand alone. We could put a period at the end of that. And then both of interviewees and the items they described. So that's kind of getting added on with a single dash. So kind of like a colon would do it. And then we have a colon after that. And the colon needs a sentence before. So if we were going to use a dash here, then this second part would also need to be a sentence in order for the colon to make sense. That's kind of my understanding of this. But both of interviewees and the items they described, that's not a sentence. Plus, then from hair to grass to sculptures, the colon is kind of setting us up to ask a question. So the question might be, what are the items they described? But I wouldn't want the word from to be there. I would just want to say hair, grass, sculptures, like kind of like a list. So this has got some weird problems. This is just doing all sorts of weird things, but I'm kind of getting what's happening now. So even sometimes when we go through the process of testing an answer, even when it fails, we're learning something about the structure of the sentence. We're learning how the sentence is built, and that can help us with other choices. Right now, I'm gravitating towards B and C because I understand I have some sort of sentence, and then I have this double dash maybe. So I'm kind of adding stuff. So let's kind of compare what's happening here. In choice B, all of this would be kind of like the extra thing, and then we're kind of picking it up here. Ooh, I didn't get the highlight thing. We're picking it up here at the end, right? Because what is a double dash? A double dash is an interruption. So I've already said that this yellow part could have existed on its own without anything else, with just a period at the end of photographs, right? Call paired excerpts of these conversations with photographs. Period, end of sentence, independent clause. But if we're going to do this double dash thing, then we're essentially saying we're interrupting this thought and we're kind of coming back to it, meaning the part after the dash is part of it. Right? So it's kind of like the yellow picks up again. So let's see how that sounds. Let's ignore the pink for a second, which would be everything between the double dash. So call paired excerpts of these conversations with photographs to powerful effect in her exhibition, The Blind. I don't love it, but it does make sense as a sentence, right? So when the problem most people are going to have is this end part sounds odd. It's not a normal way of talking. But to say that she paired these excerpts with photographs to powerful effect, that means that by doing that, by pairing those things together, it had a powerful effect. You know, it resonated with people. So it's just an odd way of saying that, but it's fine. It is coherent English. So fine. I'm also like, okay, both of interviewees and the items they described, from hair to grass to sculptures. Okay, right. The items they described are the hair to grass to sculptures. I kind of get that. That makes sense. So B feels kind of okay, but I gotta check C because I don't feel confident in this. So let's what does C do, right? How does that affect things? Well, now this pink part is cut short, and the blank includes some yellow, right? So let's show it in the choice, right? So this is going to be pink, and this is going to be yellow. So notice now I'm going to read the yellow, but I've got more. Call paired excerpts of these conversations with photographs from hair to grass to sculptures to powerful effect in our exhibition, The Blind. Well, now this descriptive part, this list, is applying to the word photographs. So does that make sense? Well, some of you are going to have a real tough choice here because both of these B and C equally are kind of weird. But C is not possible, whereas B is. C, you wouldn't say there are photographs from hair to grass to sculptures. That sounds like the hair is like got photographs stuck in it. Like it doesn't make any sense. You might say photographs of hair, grass, and sculptures, but that's not what it says. So this is a case where the wording doesn't make sense. It's B because this from hair to grass to sculptures thing has to be alongside the items that these interviewees described. It's part of them. So that goes there. I might look at A2 and just be sure, but this is kind of really destroying the interruptions, right? I've got a dash, but then I've got a comma. So no, we need some symmetry here. We need these things to be kind of really separated. Plus, again, this piece here in yellow is part of this first sentence. So this would be separating it too much. So this is a tough question. This is one that I would be very confident on, but most people are going to get wrong or at least bookmark. And like I said, the reason is that this phrase to powerful effect is not very natural. So this is going to happen. This would be a question you'd still really want to spend at most a minute on. You got your rules, you're applying your rules. At a certain point, you are kind of relying on your instinct about how the sentences sound. And, it either sounds good or bad. You got to go with it. Just to confirm, though, this is one I'm definitely checking because I might be wrong, but B is the answer. So this is one I've seen. I've taught this test many, many times. I would say more than half of my students get this wrong. No matter how skilled they are at grammar, this question just throws people for a loop. So if that happened to you, no big deal. Still following the rules, though. Speaking of rules, this one is a very important rules question, right? And it's very hard to identify what this is. We can see two kinds of things happening in the choices, right? We have choices where we have punctuation, commas, right? Or no commas, A and D. We also can see that the verbs are changing. Is intending, intends, intending, intends, right? So this is a perfect example where if you understand the rules, it's really obvious what's happening. You've got punctuation plus verbs. That is the to and ing rule, right? So that's right here. Now notice we don't have a to version of the verb though in the choices, right? That's kind of where the name of this rule came from, or at least from me. I made that up because most of the time they ask about this, they're giving us the to version, like to intend, and the ing version, like almost they did in C, intending, right? Or is intending in A. But the hardest versions of this rule might not have both of those or might not have either of them. It's a tricky rule, but the underlying idea is the same, which is we are focused on the sentence structure. The same thing we would always be focused on if punctuation was being tested. So if you see choices that change both the punctuation and the verbs, it's a to and ing question. That means you got to read this entire sentence and pay very close attention to what the structure is. Now I'm going to read A in there just for the sake of having something, but you can't fall in love with it. You got to make sure you read everything. American abstract artist Richard Serra is intending his installations to make passers-by keenly aware of how one's movements are affected by the physical features of one's environment, assembles large-scale steel plates into sculptures that dominate the outdoor spaces they occupy. If you had stopped here, you might pick A, or more likely you would pick D. Those are both traps. Those are missing the point that we have an extra verb later. This word assembles, this is the main verb of the sentence. But by using intends or is intending, we are trying to make those the main verbs of the sentence, right? Richard Serra intends his installations to make passersby keenly aware. Yeah, that sounds great, because that would be totally right if that was the full sentence, but it is not. It continues, right? And notice this comma. What is this doing here? Well, it's breaking things in some way, right? So we have to kind of reassemble them. And it's okay for these hard to and ing questions for you to take multiple tries to kind of assemble the sentence. It doesn't have to be obvious to you the first time through, but you want to understand how the punctuation affects that, right? So here, I can see that this break is telling me that there's some sort of pink and yellow, right? There's two different kinds of things. This isn't a list, right? It could have been a list. We could have said Richard Serra intends his installations to make passersby keenly aware, assembles large-scale steel plates, and goes to IHOP afterwards to celebrate, right? We could do anything and have a third main verb of the sentence and just make the entire sentence a list of actions, essentially. But that's not what it's doing. It ends with the word occupy. So we need to figure out how this pink got there. Why is this different? Well, it probably means we're starting with the yellow and then doing something like we did here to break apart the sentence, to have some sort of interruption. So now I'm looking at choices B and C, right? I want this to be an extra piece. And I think C is going to be the answer because intending, an ing verb, is a good way to kind of get an extra clause in the middle of a sentence. So let's see how that sounds. First, I will read the whole thing. American abstract artist Richard Serra, intending his installations to make passersby keenly aware of how one's movements are affected by the physical features of one's environment, assembles large-scale steel plates into sculptures that dominate the outdoor spaces they occupy, right? So to be clear, this is yellow, this is pink, right? But let's make sure, right? Let's delete the pink, right? By putting two commas around it, we're saying it's extra. So let's treat it as extra. Let's just read the yellow. American abstract artist Richard Serra assembles large-scale steel plates into sculptures that dominate the outdoor spaces they occupy. Yeah, that sounds like a sentence. That sounds good. In fact, it sounds much better without the pink, but you know what? We don't have the ability to delete the entire pink. But the next best thing is putting commas around it, showing that it could be deleted, that it is an interruption. This is a very, very important question. In my experience, when people are losing points on the reading section, it's because of questions like this to an ing rule that's kind of hard to find, right? It's hard to notice. They kind of pick something like D because it sounds really good and they don't read the full sentence. They don't recognize that they're being tricked. Even if you have perfect grammar boxes on your score report, this is probably still something you're getting wrong. So, this is where their practice tests can help more than the real test, because with the practice test, you can see any errors. But tons of people are getting perfect boxes in grammar, but still losing 30 or so points from questions like this. So this is the kind of thing that as soon as I see it on the test, I know I got to be really careful. I'm willing to spend a couple extra seconds on it if needed. But it is a difference maker between a 700 and a 750. Questions like this is exactly where people are losing those points. Let's move on. All right, I see more verbs, but this time I'm recognizing something much easier, right? I know that A is singular, B is plural, C is singular, and D is singular. So already B feels like the answer, but we can see, right? So I'm going for my first rule here, agreement. And so we can read this sentence here. However, in some cases, the toxins the organism uses to protect itself from predation actually increase its attractiveness to predators, right? So that's plural. Why? Because toxins increase its attractiveness, right? So cool. Very easy to prove that. I got a plural, but notice there's other singular things kind of around there trying to mess with us. So this one is very easy. College Board still considers it hard, but you can't get this wrong. This has got to be a 20-second question. All right, now we're into transitions. So let's change our thing here. And we'll do the same thing we've always done. There's a couple of weird things already, though, that make this a little bit more annoying. So let's start, though, with this dumb summaries, right? So in the second place feels like a kind of sequence thing, time. In other words, I forget if that came up in the previous one, but that's kind of just its own thing, right? We use that to repeat information. And D, though, is but, right? So the thing that I noticed, though, as well, is that the blank is not at the start of the sentence where it normally is. It's in the middle, right? It's interrupting the thought. That's weird. So I don't like that. I want to read it as if it were right here between the two sentences, right? So I'm kind of going to move it as I read. So let's just read it and see. Historians agree that the jazz pianist Jelly Roll Morton was exaggerating when he claimed to have invented jazz music. No one can deny that Morton's innovative compositions and remarkable improvisational skills helped shape jazz as a genre during its early years. So my gut tells me it's kind of like a but. So here's how I'd read it. Historians agree that the jazz pianist Jelly Roll Morton was exaggerating when he claimed to have invented the jazz music. But no one can deny that Morton's innovative compositions and remarkable improvisational skills helped shape jazz as a genre during its early years. So it's innovative. He's helping, right? It's negative. If you're exaggerating and lying about inventing something, that's bad. But you can't deny he's still a great jazz guy, right? He still did a bunch of great things. So this feels like a though to me. It's not a so, because if he's exaggerating, why would that cause people to praise him, essentially, right? So it doesn't make sense. Historians agree that jazz pianist Jelly Roll Morton was exaggerating, so no one can deny that he was making innovative compositions. No, if he's lying about that, couldn't he be lying about any other things, right? This doesn't feel like a so. Second place, there's no first place, right? Doesn't make any sense. And in other words, no, because we're not saying the same thing in other words, right? That's pretty obvious. This is clearly a separate point. So this is definitely a but. I don't think this is a particularly hard question. It's considered an easy question by College Board, so I agree with that. But it does have some harder things, right? That ability to kind of move the blank to where you want it to be is useful. So if it's in the middle of the sentence surrounded by commas, move it back to the beginning so it's where you would want it to be. All right, moving on. Same process, right? So this just becomes automatic. This is a but. In fact is kind of its own thing. We'll just leave it as in fact. This is another but, and this is in other words. And in other words is kind of almost always wrong, but let's see. I already don't like C and A because they both basically mean but. So it's very unlikely that one of them would be right and the other wrong if they have essentially the same meaning. So that's something to think about. I do notice that these are also not capitalized. However, in this case, they are following a semicolon, which is the same as a period. So essentially, they're still starting a sentence. So where they are in the sentence is fine here. But let's see what we got. Biographer Michael Gorin notes that the novelist Henry James lived in a world of second thoughts, frequently tinkering with his novels and stories after their initial publication. So tinkering. However, so we got a but, the differences between the 1881 first edition and the 1908 edition of his novel A Portrait of a Lady are extreme, even by James's standards, right? So he's tinkering. This is extreme. Some critics regard the two editions as two different novels altogether. Okay, so this confirms what I thought before. There's a clear trap though, right? The whole passage is a contrast. But we're not going to add a contrast to this spot because that spot is not a contrast. The whole thing is. We're not summarizing the whole thing. We're just focusing on these two related pieces. They're saying that there are extreme differences between his novels, or between two versions of his novels. And then they're saying that there's two different novels. They essentially are two different novels altogether. That's reiterating what we just said, right? That's saying the same thing twice, essentially. So that is definitely not a contrast, which I knew kind of from the strategy, but I can see why people might still pick that as there's a however, they're tempted. Now you might be thinking, okay, well, if it's saying the same thing, shouldn't we say in other words? But no, it's still, we gotta be very literal with in other words. In other words, it literally means we are saying the exact same point, the exact same piece of information with just different words than we did the first time, right? It's literal repetition, not continuation of an idea, repetition. In fact, is a way of kind of adding emphasis. So to me, that's more of what's happening here, right? The differences between the two novels, the two editions, are extreme. Even for a guy who loved to change things, right? In fact, some critics regard the two editions as two different novels altogether, right? It's heightening it. The first part here is not saying that they are different novels. So that's why in other words doesn't work. It's not saying the same thing twice. It's taking that point. These are very different books and heightening it, exaggerating it, emphasizing it by saying they're so different that maybe we should even just think of them as two different novels. So B is the answer. I'm going to check that though, because I'm a little uncertain. B is the answer. One thing helping me here that I definitely think about, it's not anywhere in this strategy thing because it's a little bit more complex. But in other words is one of the most commonly wrong answers, right? It's right occasionally, so we can't just always cross it out. But I would need really good evidence to pick it. I would need to be looking at this and be saying, yeah, they're just saying the same thing twice. But it's very rare that that's going to happen. So if you were like genuinely between B and D here, my advice is in other words is almost always wrong. So you can just if you got to pick the thing that's, more likely right. That's kind of the way it goes. In other words, it's just usually a bad choice. So, like I said, it's right occasionally, so you can't always just cross it out. But if I were stuck, I'm definitely saying B is a better bet, and it is right here. Okay, these seem more normal. Let's see if this is going to be easy or not. So A is but, B is time, maybe. Then can be kind of tricky. So we'll maybe come back to it. Moreover is and for example. Okay. Now notice here, we're doing the same thing we saw before. The blank is in the middle of the sentence. So I'm going to move it so that it exists over here instead, right? So let's see. In hindsight, given the ideas about the natural world circulating among British scientists in the 1800s, the theory of natural selection was an obvious next step. Strong word, obvious, right? So it's obvious. It may not have been a coincidence that Charles Darwin and Alfred Wallace arrived at the concept independently. Okay. And indeed is a word that adds emphasis. So let's see what that's doing there. Indeed, contrary to the popular myth of the lone genius, theirs is not the first paradigm shifting theory to have emerged from multiple scholars working in parallel. So not a coincidence. Notice there's repetition here. Main ideas are repeated ideas. So I'm having trouble thinking about what this is doing, but strong words are helping me here, right? I'm trying to understand the relationship between these sentences. So it's obvious. So it's not a coincidence, right? If it was an obvious next step, then it's not a coincidence that these people figured it out independently, right? It was obvious. Okay, let me think this through, right? This is one I want to be sure. The theory of natural selection was an obvious next step, but it may not have been a coincidence that these people arrived at the concept independently. No, we're definitely not contrasting. If it's obvious, then it's logical. It follows from that they would have both just happened to come up with it. It's obvious, right? Moreover is an and word, and is usually just kind of my last resort. That's another strategy thing, is you can always kind of say and between things, right? And doesn't do anything. So it's kind of like it's always right in a way if nothing else works. But the whole point of these is we want to actually have a transition. So and is not really a transition. So it's not so much I'm crossing C out, but I would have to really prove B wrong in order to do that. But let's look at, for example, well, that's also wrong because it's them arriving at it independently is not an example of it being obvious. It's kind of like proof of it being obvious, but that's not the same thing, right? The theory of natural selection was an obvious next step. For example, it may not have been a coincidence that these people arrived at the concept independently. No, it's not an example. It's not an example of being obvious. Now, why is then a word that has to do with time coming in here? Well, because then sometimes can be more of a so, right? Just think of how it works when we're talking about it with time. First this happened, then this other thing happened. Well, why did the second thing happen? As a response, as a consequence, as an effect of the first thing, right? So is a cause and effect word. So I'm going to substitute that in there. The theory of natural selection was an obvious next step. So it may not have been a coincidence that these people arrived at it independently. It was obvious. So no wonder they both thought of it. Yeah. This is a good question. Yeah. It's one where we're kind of having to be a little more flexible with some of these things, but I'm still following the strategy, still thinking a bit that way. This is another one that I would kind of be challenged by during the test, but still wouldn't take me more than a minute. So it's a good question for the hard module. And yes, B is the answer. Let's move on. Another word's coming up again. Okay. Let's just do what we've always been doing, right? This gets routine at a certain point, which is what we want. The less thinking you do on the SAT, the better, ironically. So A, time afterwards. Yeah, okay. B, we keep talking about another words and what it means. C is an and word. D is a but word. Okay. In a recent study, researchers examined the sleeping and waking habits of a group of dairy cows to determine if the cows' patterns of activity suggested that the animals were diurnal, nocturnal, or crepuscular. Good word. The researchers studied whether the cows were most active in the daytime, diurnal, nighttime, nocturnal, or at dawn and dusk, crepuscular. Okay, well, afterward doesn't seem to make sense, right? Because this isn't like a first step and a second step. They're the same step, right? They're examining the sleeping habits. They're studying their sleeping habits, right? So there's no, like, first they did this, then they did that. So no, this is wrong. However, it's not a but. They're saying they studied their sleeping habits. And again, they studied their sleeping habits. So there's no but here. Now, again, additionally is a one that I said we want this to be our last resort. We don't want to use it unless everything else is wrong. But we also have, in other words, which I said is almost always wrong. But let's think about it here, right? Are we saying the same exact thing in other words? I think so, right? They examine the sleeping and waking habits of a group of dairy cows to determine if the cows' patterns of activity suggest that the animals were diurnal, nocturnal, or crepuscular. In other words, they examined whether the cows were most active, so their pattern of activity occurred in the daytime, nighttime, or dawn and dusk, right? What is daytime? Diurnal, nocturnal, nighttime, crepuscular, dawn and dusk. I'm so glad, in other words, came up on this test. I forgot that it does in this way, but this is it. This is a very obvious case where we have not said anything new. The second sentence is literally just a rearranging of the first sentence. We have added nothing to it. It's a perfect case for in other words. So there you go. So I'm still not picking C because it's not an additional thought, right? It's the same thought. But this is a good example of how, yes, I stand by what I said earlier. In other words, is one of the most obvious, constant, wrong answers on these transition questions, but it can be right. So we have to just be aware of that and be flexible enough to pick it when the situation calls for it, which is what happened here. All right, these things. Okay. These tend to get a little harder, these outlines in this hard module, but we still start in the same place, which is, and to confirm, B was the answer for the other one, in other words. We still want to start with the instructions, right? What do they want? They want to emphasize a similarity, that's a big word, between P waves and S waves. Okay, let's just see if this says they're similar in some way. P waves and S waves both travel beneath Earth's surface, causing the ground to move. Okay, well, I like it says both, so that's pretty good. P waves travel away from an earthquake's starting point at a higher rate of speed than do S waves. Well, if it's a higher rate of speed, that's a difference, not a similarity. Spreading out from the focus of an earthquake, P waves move the ground backward and forward. Yeah, but what about S waves, right? You got to bring up both. Although PA waves and S waves start at the same point, they behave very differently. Well, no, again, you're saying they're different, not similar. So perfect. Even in the hard module, sometimes you don't need anything but to just follow instructions. They wanted a similarity. A gives a similarity. That's definitely the answer. College Board considers this a medium question. So I don't know. Seems pretty easy to me. Definitely not the kind of thing you want to get wrong. And this is why we start with grammar questions so that we have time to kind of get to this and lock in these points. Cool. So next one, the student wants to indicate the California red-legged frog's FWS classification category. So, okay, you're going to indicate it. This is a good example of something we've seen in other places in the test is turn sentences into questions when they can be turned into questions, right? So if you're indicating it, right? Okay, what is the red-legged frog's category? If the choice doesn't answer that, it's wrong, right? If you're indicating it, you're telling me you got to answer this question. So species on the FWS list, which include the California red-legged frog, are classified as either endangered or threatened. So what is the red-legged frog's category? Is it endangered? Is it threatened? I don't know, right? They're saying other species on the list have these things, but they didn't say which one the frog is. So no. The California red-legged frog appears in the FW list of at-risk species. So I don't think this is right, but is at-risk species like a category? I don't know. I haven't read the bullet points yet. But let's just leave it for now. I don't think this is right. I feel like it's defining the list and not telling me the category. But let's see. According to the FWS, the California red-legged frog is in the endangered category. That sounds much better. In danger of extinction throughout most or all of its range. So clearly a difference between B and C. I like C better, but I still got to read D. I got to make sure things are working here. Likely to soon become endangered, the California red-legged frog is classified as threatened. Uh-oh. Well, what happened? Right? We use strong words. We cross out any choices that do not accomplish the goal. A, maybe B. But then we have to wedge these things apart. Because if multiple answers seem to accomplish the goal, which C and D at least do, we have to find a wedge that separates them. It will likely be that only one choice includes the correct facts. Check the student notes bulleted outline to verify the facts. Yes, well, right. Notice they give different answers to this question. What is the red-legged frog's category? This one says it's endangered. This one says it's threatened. This one says it's at risk. So I guess we're still maybe thinking about B, but let's just see. All right. It should say somewhere, blah, 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 blah. A species is likely to soon become endangered as threatened. Okay, that's related. The California red-legged frog is likely to soon become endangered. So notice all we're really doing is mixing these 2 points together. The frog is soon to become endangered. What does that mean? That means it's threatened. D is the answer. Now that's obvious. You cannot get this wrong. If you get this wrong, I bet it's because you picked C, because you found something that was like, oh my God, this is exactly what I was told to find, and you were too lazy to read D, or you read it more out of like as a chore than as an actual test of whether that D could be right. Like a lot of people do this thing where they're like, oh, I've read all the answer choices, but they mostly decide on an answer and then look at the other 2 choices and kind of read the words, but they don't process it. They don't think about it. They've already made up their mind that choice C is right. And they're reading D just to kind of be able to defend themselves later if their tutor or whatever tells them you should read all the answer choices, right? So if you would know, if that's you, when I talk about that, if you're the kind of person who looks at the other choices just out of an obligation, that's not what we're doing. We are a judge. We cannot rule on the case until we've heard all the evidence. Choice D is just as valuable as evidence as choice C is, right? And it's not a coincidence that choice C sounds really, really, really good and comes before D. The SAT is absolutely here testing your ability to kind of have some impulse control and be thorough in your process. And so many people are picking C because they just make up their mind as soon as they get to something. So if that's you, that is such a stupid way to approach the entire SAT and especially these outline questions. So yeah, D is the answer. All right, last one of these. All right, student wants to make a generalization. I hate that word. About the materials used in Dow replicas. Okay. So generalization, the reason I hate that word is that could just mean anything. It's like summary, right? Like you're just saying something general. You're not getting into specifics maybe, but maybe it's not so bad if you get into specifics, but okay. Let's just look at the choices and see what we get. A traditional material that was used to stitch together the hulls of ancient dhows, coconut palm fiber rope, is still used by shipbuilders. Okay, well, is it used by shipbuilders in the Dow replicas? Right, it doesn't say. It says it was in the ancient dhows, but that's not the same thing. A replica is something new, right? They're remaking it. So maybe, but I don't know. It feels like it's not about the Dow replicas. It's just about these materials. I don't know. Something's off there. The ancient Arab dhow was a sailing vessel used primarily for trade and distinguishable by its triangular sails. Okay, well, that's a generalization about the dhow. It's not about the replicas. It's not about the materials. Although most materials used in dhow replicas are traditional, some modern materials are used. Okay, it's about the replicas. It's about the materials. And it's a generalization because notice it doesn't mention any materials, right? It doesn't get specific. It's very general talking about them. Some are modern, some are traditional, right? Okay, I like that. Let's look at D. Contemporary shipbuilders in Oman build replicas of the dhow, which was an ancient sailing vessel with a stitched hull construction. Okay, again, what are you really saying about the materials, right? The stitched hull construction, is that a material? This would be a case where I'm picking C and moving on. I just feel like it's so obviously the answer. It's hitting all the points. In order for me to make A or D right, I would need to really stretch the meaning of some of these words and these instructions. Plus, how would C be wrong, right? Another way to sometimes approach these questions on the passages as well is kind of the only way for A or D to be right is if C is also right? Because it's so vague. Although most materials used in dhow replicas are traditional, some modern materials are used. It's so vague. How would you, what's wrong with that? I guess maybe the only thing is the word most is a quantifier. And we might want to look at the bullets and see are actually most of the materials traditional? Let's see. Blah, 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 the sales, blah, blah, blah. Okay, contemporary shipbuilders in Oman use a mix of modern and traditional materials. Okay, most of the materials are traditional. Cool, okay. Replica hulls are stitched together using the same traditional coconut palm fiber rope used on the hulls of ancient dhow. So yeah, most are traditional, some are modern. That's literally what it says. So yeah, this is not, and C is the answer, but I feel like maybe just through my own practice, it's very obvious to me that C's the answer without even looking at this. All right, we got to go back to start. We're making good time. Let's do vocab. All right, so as always with these, we're reading the paragraph. We are looking for strong words, anything that kind of helps us understand this blank. So the War of 1812 has blank place in historical memory in Britain. All right, don't try to fill that blank yet. We don't know anything. We just know it's a blank. Partly because it is overshadowed, that's a strong word, by the much larger concurrent conflict against Napoleonic France, and partly because it essentially maintained the geopolitical status quo for Britain. The country neither gained nor lost significant territory or position as a result of its participation in the war. So, okay, I don't even know what to highlight here. Like status quo, it's kind of a phrase you should be comfortable with. They kind of define it here, but status quo is the same before and after, essentially. So they neither gained nor lost. I like the word overshadowed, though, right? So I'm going to be very lazy here, right? I'm going to try to get my dumb summary and fill in that blank in the laziest way possible. So I'm going to say the War of 1812 has an overshadowed place in historical memory. Okay, so maybe another version would be like unimportant or something, but okay. Well, tenuous means weak, kind of like, not hanging on strongly. So maybe that could work. If it's overshadowed, it's unimportant. Tenuous, not strong. Okay, I get it. Enduring, certainly not, though, right? That's a positive word, and this is definitely a negative. Contentious means that people are arguing about it, right? So are people arguing about this? Now, you might think so, right? Because people argue about history all the time, but does the passage back that up, right? It doesn't seem to be something that people are debating, right? It seems like they agree. They agree it's been overshadowed. They agree it maintained the status quo, right? There's no argument here. No. And conspicuous means it's prominent. It's noticeable. So that's the opposite of overshadowed. So no. I love this question. These are tougher words, but to me, I don't know, the passage just gives us the definition. It's fairly obvious that that's what we want. And so maybe you don't know what tenuous means, but I don't know, these other three, yeah, enduring you should certainly be getting rid of. If you picked that, you just kind of made up stuff and you were too afraid to pick a tough word. So that is completely wrong. But I would say all three of these other words are like classic SAT words. These are words to study, conspicuous, contentious, tenuous. You will see those words again. Those are all like classic, common SAT words. So if you've been studying vocab, you should have encountered them. If not, well, then yeah, no wonder you got this wrong. Let's move on. Okay, same process. In 1891, design artist William Morris co-founded the Kelmscott Press, which printed editions of books using pre-industrial methods. Historians argue that Morris's repudiation of industrialization is blank the Kelmscott edition's use of handmade materials, and intricate ornamentation reminiscent of medieval manuscripts. Oh, colons are good. Colons are good on the SAT vocab. These meticulously handcrafted elements exemplify the artistry involved. Okay, this is a tough one. Right? So historians argue that Morris's repudiation, meaning rejection of industrialization, is blank the Kelmscott edition's use of handmade materials and intricate ornamentation reminiscent of medieval manuscripts. So I'm basically asking myself, are we continuing this idea? I think so. So I think what we can say here is historians argue that Morris's repudiation of industrialization is exemplified by the Kelmscott Press edition's use of handmade materials, right? So just to be clear, he's rejecting industrialization by using handmade materials, right? That makes sense, right? In other words, the part before the blank and the part after the blank kind of follow from each other, right? So I wouldn't want to say something like is proven wrong. Like basically he's saying he hates industrialization, but then he's making all of his stuff in a factory, right? That would be a good example of like a contradiction, some sort of, he's lying in some way. But they're saying here, no, right? His handcrafted elements exemplify the artistry involved. I'm kind of using the word exemplify in a slightly different way, but I like this. And the colon usually tells me I'm going to repeat something. So I'm going to take advantage of this. So insensible to means that you cannot sense it. You can't make sense of it. But again, the before and after the blank seem to make sense with each other. So I don't even know how that would work. Manifest is a word you guys use all the time because it's a very popular word these days. I'm going to manifest a 1600 on the SAT, but that's not really what the word means. It doesn't mean imagine or kind of like set it as a goal, but it does mean to kind of like show or demonstrate. So his rejection of industry is shown in his use of handmade materials. I get that. That feels right. Scrutinize is to kind of examine something closely. I don't even know how that would make sense here. It just doesn't make sense. And complicated by is maybe the opposite, right? This is maybe what I was trying to get at before of like, if he's kind of lying, he's saying, I hate industrialization and manufacturing is bad. And then he's going ahead and doing it anyway. That would be a good example where it's like, he says one thing, but that's complicated. What he says is complicated by what he does. He says one thing, he does the other. There's a complication between his words and actions, right? But that's not what's happening here. The words match the actions. He says he hates industrialization, so he's using all these handmade materials. Good question here. Again, hard module, knowing more vocab is going to help, and not knowing vocab is going to hurt. So you might have to start guessing. But this is one where I think what I would call maybe a twisted relationships passage where understanding the relationship of the blank is more important. But yeah, I don't know. It does seem like we're copying stuff. All right, more. Okay, so beginning of the passage. Blank the longstanding trend of overemphasizing teenagers and young adults in research on social media use. So this seems important. Scholars have recently begun to expand their focus to include the fastest growing cohort of social media users, senior citizens. Okay, so the problem is we're overemphasizing teenagers and young adults, so we're expanding our focus to other people, right? So this is a problem, this is a solution, so we're fixing, right? That's kind of what I want to say here. Dumb summary. Fixing the long-standing trend, right? Now notice that's not in the passage, but it's just a basic understanding of the structure of the sentence, right? You kind of hinging around this comma of like, okay, there's a problem, there's a solution, we're fixing the problem. Exacerbate means to make it worse. Redress means to fix. Epitomize means to exemplify, to kind of like show off or kind of be a good example of the problem. But no, we're fixing the problem. And precluding basically means to kind of like exclude, essentially. And that just doesn't make sense here. It's kind of making it irrelevant, but or making an exception of it. But no, we're fixing the problem. This is a good example where I'm like, redress just means fix, like don't force it. So there you go. Again, hard words. The more hard words you know, the better you're going to do on these. And my main strategy for this is if you are understanding what should go in the blank, but you're not then being able to find the match. Yeah, like I say here, go with your gut and move on. You can't spend a minute debating what these words mean. You either know it or you don't, or you've got a feeling that you can rely on. So the vocab fairy is not going to come down and whisper the definition in your ear. So you got to understand with these vocab ones, when you've gone as far as you can, and your best move is to pick a choice and give up and move on. Go with your gut. You've got probably some vague memory of some of these words, so follow that memory. But honestly, like use the time in the passages where you actually stand a chance of working it out and solving it. So let's just make sure this is the answer. Yes, it is. I know the answer because I know the words. All right. These are the weird vocab ones. I don't find these particularly hard usually, but they are a little bit different. Is the words in the blank already for us, but we're given some options of what it can mean. So the narrator is riding in a taxi down a street lined with food vendors and shoppers in Paris, France. Okay, the multitude of Paris seems to be dressed in blue every day but Sunday, when, for the most part, they put on an unbelievably festive black. Here they were now, in blue, disputing every inch our passage with their wagons, hand trucks, their bursting baskets, carried at an angle, steeply self-confident in the back. I have no idea what they're talking about. Okay. Use the choices. Are they arguing about their passage? Are these people, like, fighting about it? I don't think so. It doesn't sound like anyone's talking, right? They're pulling trucks and carrying baskets. right? They're not like saying, no, 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 you can't come here. This is closed, right? Like at least there's nothing saying that. However, this is obviously a trap because what does it mean to dispute something? It means to, argue about it. So this is wrong. This is clearly a different usage of the word. And that's maybe the main game that these kind of, what I call nearly means questions because of how the question sounds. What these nearly means questions are actually doing is they're giving us a word we have a very obvious common definition of, and then they're using it in an unusual way. So if you're totally stuck, don't pick the obvious definition. Pick something else, especially in the hard module. Easy modules, maybe the obvious definition is right. But here, let's see, disapproving sounds a lot like arguing, right? They're disapproving. They're saying, no, you shouldn't have come this way. This is bad. You're breaking our rules. I don't think so. We don't get that, right? There's just vendors on a street. So that doesn't seem to make sense. Asserting possession of, so like stealing, taking. Here they were now in blue, asserting possession of every inch our passage. So they're taking their route. What does that mean to assert possession of an inch? I don't know. Providing resistance to? Okay. Right, here they are now in blue, providing resistance to every inch our passage. Okay. Yeah, because they have wagons and hand trucks and baskets, and you're in their, like, you guys are in each other's way, right? You're riding in a taxi down a street, but that street is lined with food vendors and shoppers. So they are out in the street, and you are in a taxi driving past all these people, and they're getting in your way because they're people in a street. Like, this makes sense, right? And now I want to be clear. I knew this answer beforehand. I've taught this question a million times, but this is one where the first time I ever did it, I didn't really have that answer. But getting to this answer is very much about just experimenting and kind of putting it in there and thinking, like, could this make sense? I don't read this and have an obvious kind of guess, like an obvious dumb summary of what disputing means here. I'm not aware of it. It's too weird of a passage. But I don't have to come up with something out of nowhere. I have 4 somethings right here in the choices. So why don't I just use those and kind of work it back? And my job is to kind of just be like, what's the path of least resistance, to kind of use the same language here, right? The path of least resistance is like, oh yeah, they're driving in a taxi down a street with a lot of people. The people getting in the way, providing resistance, right? I could maybe make some argument and saying like, oh, and also the people are yelling at them as they go, like, you shouldn't be here. This is our street, blah, blah, blah. But like, that requires more work than just like, yeah, they're in their way, right? So the path of least resistance, we'll see this in the passages too, is always going to be your best answer. Whatever requires you to do less talking, less thinking, that's going to be best. So there we go. All right, passage time. All right, so as we are thinking about passages, I will once again try to bring up pacing strategies. Hard module though, you're gonna run out of time. Most people are gonna run out of time. So it's fine. You got to think about sacrifices and what you would sacrifice to me. These choices are kind of long, but not so bad. Plus it's an underlined sentence. The passage isn't that long. I'd probably do this question. So what does it want to function the underlined sentence? So cool, nice and easy. Read the passage, look for strong words. Let's see what we got. On painter William H. Johnson's return to the United States in 1938 after a decade in Europe, his style underwent an abrupt transformation. Okay, that sounds important. Turning away from landscapes painted in an expressionist style, a style that often involves using fluid, distorted shapes, and thick, textured brushstrokes to express the artist's subjective experience of reality, Johnson began painting portraits of Black Americans in a bold new way. So he's turning away from one thing. He begins something new. It's a new way, right? So I don't care about all this garbage in the middle about the painting. I don't care. I just care that it's new. He's transforming, and look, 3 words that kind of reiterate that. Evocative of African sculpture and American and Scandinavian folk art, these portraits feature flat, deliberately oversimplified figures in a vibrant but limited color palette. Okay. What does this do? My dumb summary is it just gives an example of the transformation, right? So, okay. I mean, I guess I can write that down. Example of transformation. Transformation. Ugh. Spelling doesn't count. It elaborates on the previous sentence's statement about a transitional moment in Johnson's artistic career. Does it elaborate on the previous sentence saying it's a transformation? Yeah, okay. Transition, transformation, same word. It provides information about Johnson's travels in support of a claim about his artistic influences, which is advanced in the following sentence. So no, it's not talking about his travels. It's talking about his painting. And in support of a claim about his artistic influences, no, I guess they're kind of talking about the influences here, but it's not about his influence. It's about his style. So it's not quite the same. So no, A is definitely better. It recounts a moment in Johnson's personal life, no it does not, that enables the success of his subsequent career, which is summarized in the following sentence. No. What his personal life? That would be like if he got married or something. No, this is just more about his painting. So this is his professional life, not his personal life. It presents evidence that calls into question, okay, the previous sentence's characterization of Johnson's artistic development. No, calling into question means we're doubting it. They say he made a transformation. Now we're saying he's made a transformation, right? That's the same thing. So no. So A is definitely the answer. This is a very easy question. Medium according to College Board, but A is definitely the answer. Cannot get this wrong. Good choice that we did this. All right. Underline portion, again, kind of longer choices this time, but I don't know. I like these questions, so these would be ones I would do. Scholarly accounts of the Chicano movement, a movement that advocated for the social, political, and cultural empowerment of Mexican Americans and reached its zenith, its height, in the 1960s and 1970s, tend to focus on the most militant, outspoken figures in the movement. The word tend, there's something to that word. It's suggesting, right? It's suggesting of a pattern, right? There's a pattern. Making it seem is another word, uniformly radical, right? So they tend to focus on something. It seems a certain way. Just knowing SATs, I have a feeling they're going to say, but something is wrong with that assessment, right? Geographer Juan Herrera has shown, however, that if we shift our focus toward the way the movement manifested in comparatively low-profile neighborhood institutions and projects, we see participants espousing an array of political orientations and approaches to community activism. So I'm also looking at words like uniform and array, right? It's we thought it was uniform, but it's actually diverse, right? An array means a variety. So what is the point of the underline? To suggest something that's wrong, right? So it's I would say like, it's a misconception, right? We think about it one way, but we should actually think about it another way. But specifically, the underlined portion is the misconception that maybe we want to reverse. So let's just see if anything sounds like that. Remember, point of a dumb summary, right, is to keep it simple. And I'm not necessarily following one of these. Maybe X is bad is kind of creeping in here, or like X doesn't matter, right? The idea that their uniform doesn't matter, something like that. But don't force it, right? Just kind of go with it. But the shorter, the stupider, the better. It presents a trend in scholarship on the Chicano movement that the text claims has been reevaluated by researchers in light of Herrera's work on the movement's participants. Okay, well, it's definitely a trend. So I like that, right? Tend, seem, okay. The text claim has been reevaluated. It says Herrera has a different view. Do other researchers have a different view? I'm trying to just highlight that one word. Maybe. I don't know. I don't know about this choice. I'm not picking it. It just clicks when I click there. But I'm nervous about this. We don't really talk about other researchers. So I don't like that. But I might be being too careful here. B, it identifies an aspect of the Chicano movement that the text implies was overemphasized by scholars due to their own political orientations. Okay, well, overemphasized I kind of like, right? They're overemphasizing it being radical, but is that because of their own political orientations? Scholarly accounts tend to focus on these things. It doesn't say why they focus on those things. It doesn't say it's because those people are biased in some way. So I would agree that certain things are overemphasized, but we don't talk about these other scholars. So this is almost wrong, kind of for the same reason I'm very nervous about A, is like we're not really getting into the beliefs of the other researchers, right? So this is one of those kind of common trap answer wedges, right? Do we actually know what these other researchers believe? What they were motivated by? I don't think so. I'm confident getting rid of B here. It describes a common approach. Okay, yeah, common approach. People tend to do something, right? It's common to studying the Chicano movement that, according to the text, obscures the ideological diversity of the movement's participants, right? Now notice, right, this isn't getting into the motivations of the people who take this common approach, right? It's just saying that it obscures the diversity of the movement's participants, the array of orientations. I like that. I like that better than A. Let's look at D. It summarizes the conventional method. So notice how all these choices start with the same kind of correct idea, right? It's a trend that overemphasizes something. It's a common approach. It's a conventional method. This is a classic SAT move, right? The choice is big. And your temptation is to look at it as a unit and say, oh, okay, I got to take all this information in. But notice how I'm kind of looking at little pieces as I go. And certain pieces, if they're all the same, if they check out, that's okay, that's good. But it's not enough to make it right. There's other pieces that might be wrong. So it summarizes the conventional method for analyzing the Chicano movement. Yes, it does, which the text suggests creates a misleading impression. Well, I said that before, right? A misconception of the effectiveness of neighborhood institutions and projects. Well, did we talk about how effective these things were? No, the debate was whether the movement was uniform or diverse, not whether it was effective or not effective, right? It doesn't get into that. So that one word is enough to make that wrong. I would pick C here. I just don't really have evidence that the common approach, the trend in scholarship, has actually been reevaluated. One guy, Juan Herrera, saying that this might be the wrong way to look at it is not enough to say that all the people who looked at it before have now changed their minds, right? It's not saying that the misconception has been corrected. It's just saying a guy says it's a misconception, right? So A is too extreme. Let's just make sure, because this is hard. C is the answer. Yep. But I like this question a lot. Notice all my highlighting I'm doing in the choices, right? There are certain things that popped in the passage, the normal stuff, right? But is the most important word in any passage. I had some other strong words right around the but. What is the but really contrasting? Words like tend and seem, those kind of stand out to me, but really most of the work is here. My dumb summary did not necessarily even help, right? Because all these choices seem to suggest the idea of a misconception. It's then there's some sort of follow-up to that was different among them. So don't worry about it. It didn't bother me that my dumb summary was not that helpful. Either way, it's strong words that get me both things. All right, this looks good, right? Short choices, nice. Okay, according to the text, why are some critics skeptical of the concept behind this thing, right? So follow instructions, right? So at some point they might say something like they doubt, they're skeptical, they're suspicious, something like that. So if they say that, I'm going to pay attention. Since its completion in 2014, Bosco Vertical Forest, a pair of residential towers in Milan, Italy, covered by vegetation, has become a striking symbol of environmental sustainability in architecture. Stefano Boeri intended his design, which features balconies that are home to hundreds of trees, to serve as a model for promoting urban biodiversity. However, favorite word, the concept has faced skepticism. Okay, well, they just said it. Critics note that although the trees used in this thing were specifically cultivated for the project, it's too early to tell if they can thrive in this unusual setting. So, I don't know. So why are some critics skeptical? They kind of just say it, right? The plants might die, right? That's too early to tell if they can thrive. The plants might die. Some essential aspects of Bosco Vertical's design are difficult to adapt to locations other than Milan. Do they ever talk about locations other than Milan? No, they do not. And this is one of our, bottom one here, one of our trap answer wedges. That word other feels like a word you don't need to notice, but it's there, right? Does the choice mention other examples beyond what's in the passage? Yeah, I don't care about other locations. It's not about that. We're skeptical of this one thing in Milan, not other places. The plant life on Bosco Vertical ended up being less varied than Boeri had envisioned. Well, what did he envision? This gets into people's beliefs, right? I don't know. Plus, is it less varied, right? That's a comparison. Okay, right? Comparison. We're not interested in whether it varied. We're interested in whether it survived, whether it lived. So I don't think that's right. The construction of this thing was no less environmentally damaging than the construction of more conventional buildings. No, this is another comparison, right? With the word than as a dead giveaway. But, right, are we comparing this building to others? No, we're skeptical because we don't know about the plants. Let's see if D is right. It is unclear, right? It's skeptical, whether Bosco Vertical can support the plant life included in its design. Yeah, we don't know if it's going to thrive. That's so easy. I am curious what the Yeah, College Board says this is medium. This is a good example of I don't know where they get these difficulties from, but this is about as easy of a passage as you're ever going to see. Certainly in the hard module. So, you got to make sure you get to this. D is the answer. This is very easy. Now, this might be one I would skip. Look at those choices. Oh, that looks awful, right? The passage ain't so bad, but when the choices are essentially as long as the passage, you might be in for some trouble, right? It just means there's a lot to sort through. So I'm going to do this question because I don't want to be going out of order for people who are looking for specific questions. But on the real test, this is probably something I would skip because it just seems like it's going to be a lot. But let's give it a go. Follow instructions. Main idea means just read it and find the strong words. So the same thing we always do. Elizabeth Saidu has identified a negative correlation, between the share of developing countries' economies derived from natural resource extraction and those countries' receipts of foreign investment. This may appear counterintuitive. Okay, that's important. Resource extraction requires initial investments. In extractive technology, for instance, it scales best met by multinational corporations. But Asaidu notes that natural resource industries' boom-bust cycles can destabilize local currencies and increase developing countries' vulnerability to external shocks, creating levels of uncertainty to which foreign investors are typically averse. So yeah, this is going to be really tough, right? Because this is a lot of technical language. But we have some things we can use for our dumb summary, right? We have the idea that there's a negative correlation between things. We could summarize that. The share of developing countries' economies derived from natural resource extraction. So more resources means negative correlation means the other goes down. So less investment, right? Receipts of foreign investment. So that's me just taking this negative correlation, putting it there. But this may appear counterintuitive, right? So I guess what we'd expect is that you'd get more resources and have more investment, something like that. Resource extraction requires initial investment at scales best met by multinational corporations, right? So if you want to get resources out, you got to put more money in. So my relationship probably should be the other way, where investment comes first, but it doesn't really matter, so I'll just leave it. But this person notes that natural resource industries' boom-bust cycle can destabilize local currencies and increase developing countries' vulnerability. So destabilize, vulnerability, shocks, uncertainty, right? So main ideas are repeated ideas. So why is what we expect not happening? Uncertainty. Cool. Is that enough to understand it? I don't know. But that didn't take a lot of effort, right? This is me just being very robotic, right? You've given me a negative correlation. I typed it. One thing goes up, the other thing goes down. Counterintuitive tells me something's not happening according to expectations, right? There's a but. All of that is very easy to understand. I still don't understand deeply what's happening, but it's okay. Let's see what we get. Although it may seem surprising, counterintuitive, that foreign investment declines in developing countries as natural resource extraction makes up a larger share of those countries' economies, right? So more resource, less investment. So, okay. That decline happens because resource extraction requires initial investments too large for foreign investors to supply. So initial investment is too large. Okay. Did they say that? What did they say about this? Right? They said we'd expect more investment. And the initial investment, right? So they talk about that, is at scales best met by corporations. So it requires initial investments too large for foreign investors. No. They're saying the only ones who can make that investment are the foreign investors, right? Those are the guys who do it. They're not doing it because they're uncertain about what's going to happen to their investment. But no. But notice everything up until that part there is correct. This first 2/3, let's say, of this thing, maybe just the first half, is correct. But then the reason they give why it's counterintuitive is wrong. It's not counterintuitive because they don't have the money. It's counterintuitive because they're too risk averse. They're too uncertain about what's going to happen. So this is what the SAT does. Like this whole thing, a lot of it is right. You've got to find the part that's wrong. B, although developing countries tend to become less dependent on foreign investment as natural resource industries make up a larger share of their economies, right? So more resources, less investment. Okay. This change may not occur if the boom-bust cycle of those industries destabilizes local currencies or increases countries' vulnerability to external shocks. To be quite honest, I don't really understand this choice. I see a lot of words that are carrying over. I remember a lot of these phrases. That makes me nervous. That might be like a copy paste trap going on. This might be one that I'd say, all right, let's just leave that choice. I don't quite get it yet. Let's see what C says. Although one might expect that foreign investment would increase as natural resource extraction makes up a larger share of developing countries' economies. Yes, that's literally what we said right here, right? More investment, more resources. That's what we expect. The opposite happens because heavy reliance on natural resources can lead to unattractive conditions for investors. Well, that is like extremely vague, right? What are unattractive conditions, right? Well, uncertainty, vulnerability, shocks, destabilization. Those sound unattractive. Now notice it doesn't use any of those words, whereas B uses a lot of those words, right? Now, weirdly, you'd think that would make me more likely to pick B, but knowing how these traps work, that makes me less likely to pick B. So if I were truly 50-50 between these choices, I'd like C better just because it doesn't quite have all those copy-pasted phrases. However, I also just like C because it seems right? It says what we might expect, right? And it matches our dumb summary. And then the opposite happens, right? Why does it happen? We said it was uncertainty. And the investors are uncertain. There's something unattractive. There's a bunch of unattractive things, right? So that it's hard to prove that wrong, right? That's an easy thing to justify with the passage. So I'm really liking C, but let's look at D. Although foreign investors tend to avoid initial investments in natural resource industries in developing countries, do they tend to avoid it? I don't know. Foreign investment may increase significantly as those industries stabilize and the risk associated with them decline. But that's not what the passage is about, right? It's not saying, this is kind of like saying the opposite of what the passage is saying in a way, right? The passage is saying they don't invest because of uncertainty. This is saying if you remove the uncertainty, they might invest. That's kind of maybe logical, but that's not really the point of the passage, right? But I have a problem with this part here. They tend to avoid initial investments. Why? Why do they tend to avoid it? Do they say that? Right? It says it requires initial investments at scales best met by them. But the boom bust cycle can create uncertainty. So they tend to avoid the initial investment. Maybe that's fine. I don't know. Foreign investment may increase significantly as those industries stabilize. Well, they're talking about the currency stabilizing, not the industry, and the risks of the decline. Maybe. This is a good example of just like by comparison, C seems easier to prove, right? It says what we would expect to happen, right? We check that off. That's literally right here. And then unattractive conditions, we get like 4 of them, right? So all this seems to check out. Now, if this is a real test, there's a 100% chance I'm marking this for review and hoping that I have time to come back and look at it more closely. But at a certain point, even without crossing out B and D confidently, I'm picking C. It feels right. It feels like it's doing what it's supposed to do. It's matching things. So I just want to make sure, and then we'll keep talking about it. But yeah, C is the answer. So yeah, that's exactly what I would expect. And I'm going to stand by what I said. I don't think we really have any proof that they tend to avoid the initial investment. It says there's risks associated with it. Yeah, right. But remember what the whole point of the relationship is that the more their economy is based on natural resource extraction, the more we would expect there to be foreign investment, but it actually ends up going the other way. And I think that's saying it's not about the initial state. It's what's happening over time, right? The initial state is, yeah, you got to invest in order to make the resources come out in the first place. But then what happens over time is as you get more and more dependent on natural resources, you get more and more dependent on a boom bust cycle that's going to destabilize things. So it's not so much about the initial investment. It's about later investments, because now you've created a kind of cycle where you're making things riskier for investors. It's not risky to start necessarily. It's risky as time goes on and the industry grows. That's why I think D is wrong. And it's probably just making too many kind of assumptions about what could have happened, But the passage isn't about what could have happened. It's about what is happening. And C is also about what is happening. So I like that. Is this true? Although developing countries tend to become less dependent on foreign investment as natural resource industries make up a larger share of their economies. I don't know if dependent is the right word there. I want to examine that. This change may not occur if the boom bust cycle of those industries destabilizes local currencies or increases countries. Well, no, right? This is just getting the relationship wrong. Ignoring the word dependent being a potential problem, right? There is less investment as there's more resources. Why is that happening? It's happening because of the boom bust cycle. It's because of the destabilized local currency, right? So if those things happen, it's not that the change may not occur. It will occur. That's what causes this to happen, right? This is breaking the chain of events here. So B I should have more easily noticed is wrong, but C and D are close. It's just that C is what the passage says. D is some speculation about what could happen in some alternative universe. But yeah, there's a lot of here that it's just a little off. And so path of least resistance, we can prove C. Tough question. All right, how we doing here? Okay, let's pick up the pace. Love it. Short. Let's see if we can do it. Based on the text, these people would most likely agree with which statement. Okay, so follow instructions, agree with which statement. This is basically a kind of support weaken kind of deal here. So I sense a little science coming. Some astronomers searching for extraterrestrial life have proposed that atmospheric NH3 ammonia can serve as a biosignature gas, an indication that a planet harbors life. These people evaluated this possibility, finding that on rocky planets, atmospheric NH3 likely couldn't reach detectably high levels in the absence of biological activity. Oof, that's a rough sentence. But, let's change this to blue. The team also found that on so-called mini Neptunes, gas planets smaller than Neptune but with atmospheres similar to Neptune's, atmospheric pressures and temperatures can be high enough to produce atmospheric NH3. So, okay. I'm having trouble with what I'm reading, but I get some things, right? There's a but here, right? So to me, this is a clear case where there's some sort of comparison, right? So I'm kind of looking at maybe like one of these type of dumb summaries here. You're telling me there's rocky planets and there's Neptunes. So this is kind of like a rocky versus Neptune situation. Okay. Are you saying they're the same or different? The but tells me it's probably different, but I need to... This blue sentence is a classic example of that like twisted relationships thing that they do sometimes in the vocab, right? Where there's too many negative words, right? So you're telling me NH3 couldn't reach a high level in the absence of biological activity. So if you have trouble with that, right? Retype it or rewrite it. Couldn't reach detectable, couldn't detect, let's just do that. Couldn't detect in absence of bio. Okay, how would we flip that? So you could detect it in the presence of bio, right? Notice you flip two negatives, you get a positive, right? So you couldn't detect it in the absence of biological activity means that you could detect it in the presence of biological activity. So on a rocky planet, it sounds like you're saying that NH3 is what you said it was, a biosignature gas, right? It's a biosignature gas that tells you that there's life. So, okay. I get that. But on the mini Neptunes, gas planets smaller than Neptune with atmosphere similar to Neptune's, atmospheric pressure and temperatures can be high enough to produce atmospheric NH3. So there, it has nothing to do with life. It's just the quality of the planet. So this is telling me it's not just that we're comparing them. We're specifically contrasting them. I know there's a way to make yeah, there it is. Not equal sign, right? So on a rocky planet, NH3 is life. And on a Neptune, it doesn't mean anything. It's just like part of the planet. Okay, I get it. Let's see if we can find that comparison in some way in the choices. Its presence is more likely to indicate that a planet is a mini Neptune than that the planet is a rocky planet that could support life. Well, that's clearly comparing. But we're not saying which type of planet is more likely. We're not using NH3 to figure out what kind of planet we have. The planet is the planet. We're determining whether the NH3 can be used on a rocky planet or on a Neptune planet to determine whether there's life on that planet. So this is a comparison, but it's the wrong kind of comparison. We're comparing how NH3 operates on each of these planets. We're not trying to figure out what planet we have. We know what planet we have. So no. its absence from a planet that's not a mini Neptune indicates the planet probably doesn't have life. So here we got another one of those, like, can we switch things? But its presence on a planet that is a mini Neptune indicates that the planet probably doesn't have life. That might be true. I'm okay with that switch. That might be true. But the bigger question is, what does it mean for a planet to be not a mini Neptune? Does that mean it's a rocky planet? Are there other types of planets? Right? So that's the thing, is this is only talking about two types of planets. This almost feels like one of these kind of like big versus small things, where it's like, well, I don't know. We're only talking about two things, and now choice B seems to be broadening that out and saying, okay, it doesn't matter what kind of planet you have. If it's not a mini Neptune, then it's going to follow the same rules. But that's not true. We only know the rules for rocky planets and Neptunes. So this is also too broad. It should be treated as a biosignature gas if detected in the atmosphere of a rocky planet, so rocky life, but not if detected in the atmosphere of a mini Neptune. Yeah, that's basically what we said. It doesn't reliably reach high enough concentrations in the atmospheres of rocky planets or mini Neptunes to be treated as a biosignature gas. Well, this is probably the most obvious wrong answer to me if we understood the contrast from the get-go, right? You're telling me rocky planets and Neptunes are different. That's what the passage is saying. The word but really does the job there. This is saying they're the same, right? It doesn't reach high enough concentrations in the rocky planets or the mini Neptunes. You're telling me they're the same here. So no. This is clearly wrong. This is a tough question. I might be a little nervous about it, but I feel like this is a great example of how you should be thinking about dumb summaries, right? Is especially for these science passages, we're going to get a lot of kind of comparisons. This thing is bigger, this thing is better, this thing is smaller, this thing is worse, or whatever. And so a lot of them end up kind of looking like math equations. And so kind of roll with it, try to make it how you want, but understand that a lot of times, we say that comparisons are bad in choices, but really the reality is comparisons are important in choices, and they give us something to test. If the passage is making a comparison, we want the choice to make a comparison too. And that's essentially what C is doing, is it's just saying these are different planets. This NH3 means different things. That's what the passage was saying. Good question. Okay, I love these. This is why you got to skip around, because if you run out of time and don't get to something like this, that's a big loss, right? So we got to illustrate the claim. The claim is just here, right? We got this poem. Speaker describes having contradictory feelings while experiencing the sights and sounds of a spring day. So I'm thinking just as simple as positive, negative. Through primrose tufts in that sweet bower, the periwinkle trailed its reeds, and 'tis my faith that every flower enjoys the air it breathes. This just sounds positive, so no. The budding twigs spread out their fan to catch the breezy air, and I must do all I can that there was pleasure there. Again, sounds positive. The birds around me hopped and played, their thoughts I cannot measure, but the least motion which they made, it seemed a thrill of pleasure. I like the pleasure part. Is it bad that you can't measure it? Is that a bad feeling? I don't know. Maybe, but it doesn't seem strongly bad, so I don't know. Let's see what D has. I heard 1,000 blended notes while in a grove I sat reclined in that sweet mood when pleasant thoughts bring sad thoughts to the mind. Right? Okay, so pleasant thoughts, sad thoughts, huh? Seems kind of contradictory to me. So yeah, this is very obviously the answer. I will check. I realized I didn't check on the last one either, but yeah, I was right about the last one. And I'm right about this one. This is a gift. And they say it's a medium question. But again, this is very easy. Very easy. Just got to know what contradictory means. All right. This is another one I would probably skip if it were the real test. I don't like these graph and chart questions, especially when the choices get very long like this. And even skimming them, notice it looks like the first 5 or 6 words of these is basically the same across the board. So we have a lot of words, but very little change. That can be kind of overwhelming. Again, I will do it in order for the sake of just making the video more coherent, but this is something I'd be nervous about in the real test. I probably would not do this question as soon as I saw it, but we'll do it here. So we have to support their conclusion. So I'm going to read the passage as I always do, right? So they're going to tell me their conclusion in here. I don't know what this means, so I'm not going to bother trying to understand this. They're going to tell me. So these people studied a forest site in which some sugar maple trees receive periodic fertilization with nitrogen to mimic the broader trend of increasing anthropogenic nitrogen deposition in soil. So, okay, nitrogen, there you go. They modeled the radial growth of the trees with and without nitrogen, yes. fertilization under 3 different climate scenarios: the current climate, moderate climate, and extreme change. Cool. Although they found that climate change would negatively affect growth, okay, so that seems important. But although seems that's a but, right? They concluded that anthropogenic nitrogen deposition could more than offset that effect, provided that change is moderate rather than extreme. So, oh boy. Okay, so what are we even supporting here? This is tough to make sense of, but let's try, right? So, increased climate change equals decreased growth. That's the first thing they're saying, but there's a but here, so I gotta really be careful. But they concluded that anthropogenic nitrogen deposition, deposition is from the word deposit, right? They're depositing it, they're putting it there, could more than offset that effect, provided that change is moderate rather than extreme. So that means moderate good, extreme bad. That's kind of what I'm getting there, right? You're offsetting that effect, right? So climate change is bad, but moderate change might be good, or it might be not as bad. Maybe that's another way to put it. I don't really know. Honestly, this is tough. I was right. This is something I would have been very happy to skip. But now let's see what we got. Growth with nitrogen under current climate with nitrogen, this bar, exceeded growth with nitrogen under moderate change, because that's true. But the latter, meaning this one still, exceeded growth without nitrogen under extreme change. Okay. That's all true, but I'm like, who cares, right? Is this saying that the moderate is good? I don't think so, right? Because it's worse than the current one. Plus, anthropogenic nitrogen deposition could more than offset that effect prior to that changes. So this is moderate good, extreme bad with nitrogen. So I feel like we're almost comparing the wrong thing here, right? You're comparing with nitrogen under moderate change and without nitrogen under extreme, right? So how do you compare these two things if you're changing the condition? That seems wrong. I don't know if that's right, but let's get rid of it. Growth without nitrogen under the current climate, growth without nitrogen under the current climate, exceeded growth without nitrogen under moderate change. Yeah, barely. But the latter exceeded growth with nitrogen under extreme change. Again, it seems like you're mixing and matching. We want to compare, like with these two groups, we want to compare gray to gray or black to black. So I don't think that's right. Growth with nitrogen under moderate change exceeded growth without nitrogen under moderate change. So the nitrogen helped. Nitrogen was good, right? But the latter, growth without nitrogen, exceeded growth without nitrogen under extreme change. Yeah, that's true. It's better, right? This is a tough one. Let's look at D. Growth with nitrogen under moderate change. Exceeded growth without nitrogen under the current climate. Okay. Right now, why is that good? Right? Because what they said before is climate change is bad. But look, we're making it actually good with the nitrogen. The nitrogen is more than offsetting the problem, right? Where was that? Could more than offset, meaning you're going beyond, right? Whatever the negative is, right? So from this bar to this bar, you're losing something from this black to this black. But with nitrogen, you're gaining it back, and you're getting more back than you lost, right? So okay, that seems like it's saying it's good. So I'm losing track here, but I'm getting excited. Growth with nitrogen under moderate change. Yes. Exceeded growth without nitrogen under the current climate. Yep. But the latter, this one, exceeded growth with nitrogen under extreme change, because extreme change is bad no matter whether you've got nitrogen or not. I think it's D. This would be one where at this point, I'd probably be leaving this question for last anyway. So I'd be picking a choice with the last few seconds of this module. So I wouldn't really have time to really analyze this. But I feel like this is hitting the main comparisons that I want. Notice, I don't know that I'd be able to kind of make sense of this without having written that dumb summary, right? And it's a two-parter. yes, climate change is bad for growth, but there's this kind of exception. So this word although is doing a lot of work here. And we want to support their conclusion. Notice where their conclusion kind of starts. The word concluded is right there. That the deposition of nitrogen with nitrogen more than offset the effect. So yes, climate change is bad, but nitrogen can help, provided that change is moderate rather than extreme. Meaning, if it's moderate, it'll be good. But if it's extreme, look, even with nitrogen, you've still made things worse, right? So that, to me, feels like the answer. This is what I'm definitely double checking. Yeah, D is the answer. Oof. Rough question. This is why I would leave these for last. You got a tough graph, a tough passage, a tough summary to come up with, and very close choices. I don't really have much more to say. This is just a question that requires a lot of work and a very careful reading of the passage, of at least the last bit of the passage. But, this is why it's hard to get an 800. There's hard questions, and they take a lot of work and a lot of effort, and most people still get them wrong. So yeah, in other words, it's a good sacrifice, right? If you left this for last and you didn't have time for it, what'd you really lose? Would you have gotten it right anyway? Probably not. So a 1 in 4 chance of guessing a random letter and getting it right is probably for you just as good, because that takes 3 seconds, as it would take you 5 minutes maybe to make sense of this thing and get it right. So this is why we skip it and leave it for last, is if your odds of getting it right aren't much better than 25%, even with all the work you're going to put into it, then you might as well just guess. All right, moving on. Again, I don't know. I might skip this one. It would depend on my timing, but, we're supporting a conclusion. They're probably going to say the conclusion in here. The passage doesn't look so bad. The choices don't look so bad, but they are kind of long. Just looking ahead, right? This looks worse. This could be going, we only got a couple questions. So I don't know. I might do this one, if only because I don't want to do the next one, but, we'll do it anyway. Yeah, so same procedure. Under normal atmospheric pressure at Earth's surface, water molecules form a tetrahedral network stabilized by hydrogen bonds between adjacent molecules. Extreme high pressures, such as can be found in deep ocean waters, destabilizes these bonds and compresses water's structure, allowing water molecules within organisms to permeate proteins and impede crucial biological functions. Okay, so a couple things I'm noticing, right? Stable. Then we have destabilized, right? Something flipped. And then this seems bad, right? Impede means to kind of block. And then we have a yet, so there's a but. Yet, deep sea organisms known as piezophiles have adapted to extreme pressure. Studies have found a positive correlation, so we'll come back to that, between the depths that various piezophiles inhabit and concentrations of a compound called trimethylamine N oxide, TMAO, in their muscle tissues, which has led to a team of researchers to hypothesize that TMAO reduces water's compressibility. So, okay, they just give you what they want, right? So we need to support that. So what's my dumb summary here, right? If you increase TMAO, then you reduce water's compressibility. So how do I want to write that? So yeah, you could say less compression. We could also say, right, because they talk a lot about stabilizing, right? So less compression means maybe more stable. I don't know. That's kind of tricky, right? Because notice that the arrow goes in different directions depending on how we want to look at it. I don't know that one is right or wrong, but because they kept talking about stabilizing, I don't know. I'd like to get that in there. It just feels, main ideas are repeated ideas. Here, you see, I repeat that a lot. Main ideas, repeated ideas. So yeah. Okay. Let's see. Water molecules are found to be impervious to TMAO even when the water molecule's tetrahedral configuration has been distorted by high pressure. So impervious means it's unaffected, right? So if that water molecule is unaffected by TMAO, then this whole thing breaks down, right? The whole point is the TMAO matters, right? Something matters or doesn't matter, right? You're telling me TMAO matters. This choice is saying it doesn't matter. So this can't be right. No, but notice impervious, if you don't know the word, this choice is, I don't know if it even makes sense. B, examination of TMAO's molecular structure shows that TMAO molecules retain their shape even as pressure increases. So, okay, if you increased pressure, right? A positive correlation between the depths that various piezophilus inhabit and concentrations of a compound called, okay, so here, let's try this. This is getting to be a very long thing, right? So if you increase pressure, you increase TMAO, right? If you increase TMO, you either decrease compression or increase stabilization, right? So all these things are kind of happening together, right? So we're just kind of looking for various combinations where all the arrows are pointing the right way. So TMAO molecules retain their shape, so they're more stable, even as pressure increases. Maybe. It's not really getting into the amount of TMAO, but okay, let's look and see. A positive correlation is found between concentrations of TMAO and the rate at which water's molecular structure compresses as pressure increases. So, okay, positive correlation means the arrows go in the same direction. So let's see. So is found between concentrations of TMAO. So more TMAO and the rate at which water's structure compresses. So no, right? That's the opposite of what we want. That's using these two pieces. You're saying as TMAO goes up, right? Then the compression goes up, right? But we don't want that. We want compression to go down. We want less compression, I think. So I think that's wrong. D, analysis of water's molecular structure under high pressure reveals that hydrogen bonds are more stable when TMAO is present than when it is not. Okay, so hydrogen bonds are more stable, so more stability when you have TMAO, more TMAO. Okay, so these both seem okay. So let's see, is there something to this, right? What's the difference, right? So this is getting into our dumb summary has filtered out A and C, right? The arrows go the wrong way is essentially the problem with those. Now, B and D seem very similar. They both seem to be hitting our idea. What's different about them, right? So what are some of the things that might be popping up that we can use to wedge these answers apart? Examination of TMAO's molecular structure shows that TMAO molecules retain their shape. Okay. Analysis of water's molecular structure. Okay, well, there you go. This is about TMAO's molecular structure. This is about water's molecular structure. Okay, so this is saying water is more stable. This is saying TMAO is more stable. Which matters, right? Now I have a task, right? So this is kind of like part B. This is my wedge. I use my dumb summary as a filter. Now I need to wedge these apart. So this is something that people need to get used to. Sometimes your dumb summary will not complete the job. That's okay. That doesn't mean the dumb summary was a failure, but it really helped me kind of make some sense of these choices. And now I can look at the thing that's different between the choices, maybe something I didn't think of before. So is it about water or TMAO stability? Water molecules form a tetrahedral network stabilized by hydrogen bonds. Destabilizes these bonds in the water, right? Water molecules permeate proteins. TMAO reduces water's compressibility. It's about water. D. That's the different question. Let's see. D. D is the answer. Great question. Great question to exhibit the kind of thought process and the multi-stepped procedure you need to do. Yes, it is time consuming. There is no shortcut to a question like this, or at least not one that a normal human brain like mine can handle. So I've got to do the work. But the work is, if you notice the right words, the dumb summary basically writes itself. And then, yeah, okay, it doesn't bother me that I still have two choices left. Always try to stay focused on a single task, right? The first passage, the passage is giving me a task initially. And then as I go to the choices and start realizing I've got a couple left, I kind of have to come up with a new task, a second task. But I'm always trying to do just one thing at once. These choices are too complex to take it all in and analyze everything. You got to split it apart. Whether it's what I've been doing where I'm looking at individual words in these choices, splitting it apart that way and analyzing them individually, or now what I'm doing where I'm comparing a specific aspect of the two choices. The less that you make your brain do, the more likely it's going to do what it's doing right. The more tasks you give it, the more you multitask and think about a lot of things at once, something's going to get lost. And when you lose focus when you're reading, it's almost always because you are asking too much of your brain. You have to split it up into smaller bits. Great question. Love this question. Okay. Same thing I said before. I'd probably skip this, but let's just do it. We got 2 left, right? Yeah, 2 left, 23 minutes. Okay. Support. So we're always reading instructions, right? Because at any point they could say weaken, right? They could switch that word to weaken and we'd have a problem. Okay. Some climate models for the Western United States predict that while total annual precipitation may remain unchanged from the present level, precipitation will become more concentrated, concentrated into fewer but more intense rain and snow events. University of Texas climate scientists, simulated how the amount of water entering aquifers and the amount being used for irrigation purposes would change if this were to occur. They concluded that the concentration of precipitation into fewer events would result in a higher number of dry days, triggering more irrigation, but that this change in irrigation output is highly sensitive to the baseline concentration of precipitation that currently exists in an area. Okay. It's a great example of something that the more you practice the SAT, the more you get used to kind of the way they talk, right? So they said two things I've highlighted in yellow. Maybe they're important, but, as I say many, many times, strongest word in any passage is but. There's a but right there. Now, why is that word so important? Because it sometimes invalidates what I said before it. I don't think it's doing that here, but I think it's redirecting my attention. What is the conclusion that I really want to focus on? Or at least the first thing I want to focus on is that the baseline concentration matters. Right? When you say it's highly sensitive to the baseline concentration, I see that is the first column of my table here, right? So the whole table is premised on there being different types of concentrations, right? So you're telling me after a but that matters. To me, that now is the most important thing that matters, right? So I'm going to start with that. That's going to be my filter, right? It might come down to the other stuff as well. But this is a great example of using some pretty dumb summaries. So my dumb summary here is baseline concentration matters, right? This is my first type here. So it matters. Now, why does it matter? I don't know. It's highly sensitive. Basically, I'm looking at these rows. I'm saying, okay, it's row 1 or whatever you want to call this versus row 2, right? So these are different numbers. 4.9 and 11 are different. 0.4 and 9 are different. 0.9 and 7.9 are different. These are bigger numbers, right? So I don't know. Point is, it matters, right? It has an effect. If baseline precipitation is somewhat concentrated, the amount of water being used for irrigation will increase 0.4%, okay, for surface water and 0.9% for groundwater. Whereas, that's a but word, the amount of water entering aquifers will increase 11% if baseline precipitation is evenly distributed. So I don't like this choice because you're trying to make a comparison. You're telling me that the baseline matters, right? You're comparing and contrasting these two rows, but you're not doing it in a good way, right? Why are you comparing 0.4 and 0.9 to 11, right? You should compare 0.4 to 9 or 0.9 to 7.9 or 11 to 4.9, right? Compare up and down. Compare the same thing, right? So this is just a bad comparison. B, if baseline precipitation is somewhat concentrated, water used for irrigation will increase only slightly. Somewhat concentrated, used for irrigation. So that's both of these numbers together, right? Because these are both irrigation numbers, and increase only slightly. Yeah, 0.4%, 0.9%, that's like nothing. Okay. Whereas it will increase by 9% for surface water and 7.9% for groundwater if baseline precipitation is evenly distributed. Notice what we're doing. We are contrasting these two things. We are saying there's a difference, and we're doing it in the right way, right? But I can see what they're doing is they're removing the numbers, right? They're making it less obvious that it's the right comparison by just saying something very vague, like it will increase only slightly. And you might be thinking, well, how's that fair, right? Isn't that an opinion, whether it's a slight increase? No, 0.4% is barely anything, right? We can justify that as only slightly, right? But you're comparing the right things. So this feels like the answer. I obviously have to read C and D, but I like that it's a comparison. It's telling me that the baseline matters because the numbers are different in each row. Let's look at C. If baseline precipitation is somewhat concentrated, the amount of water entering aquifers will increase 4.9%, okay, while, contrast word, the amount being used for irrigation will increase 0.4 and 0.9. Okay, so that's not even comparing the two. This is just telling me one row. I need to contrast the two. So no, not a right comparison. If baseline precipitation is somewhat concentrated, water used for irrigation will decline by a small amount, whereas it will increase 11% for surface water and 9% for groundwater. Where is there a decline, right? The simulated change in annual aquifer Yeah. Percent change. These are positive numbers, so no decline. So this is just a wrong math. The numbers don't say that. So no. So there you go. B is what I thought. That's great. I love that this ends up being easier than I expected it to be, quite honestly, just based on the amount of text there was. But we don't know that, right? We have to make very split-second decisions if we're skipping things and sacrificing questions. We got to be quick about it. You got to look at something for 5 seconds to determine, is this something I'm going to do or not? You can't spend a minute on it and then realize you're over your head. You have to 5-second decision. But notice that what essentially I'm doing here is just thinking about what I've been thinking about for a lot of these science questions is relationships, right? Is it good or is it bad? Are we comparing this or saying one's better or worse or whatever? In this case, just mattering was a very vague way of putting it, because the passage doesn't say one is better or worse. It says it's highly sensitive to the baseline concentration. That just means it matters. It could go either way. I'm not going to assume. I'm going to let the choices tell me which way it goes, but I know that it matters. So I like that. This is a perfect example of this kind of like simple, dumb summary. All right, last reading question. Yes. A logic one, and this would be something I would have skipped too. I love these logic questions. I think they're really good. As a reminder, what are we doing? We have a passage. We are finishing a story, right? So yes, we're reading the passage, finish the story. Where is it headed? That's basically the way to do it. So think about maybe where it starts, but as you get closer, the information gets more important, closer to the end. All right. In 2013, these people compared the feeding behaviors of wild lions in Tanzania's whatever national park with those of captive lions in this other place. So, okay. I can even write that now, right? What it says. I think this is going to matter, right? So this is about what? Wild versus captive, right? The researchers noted that previous studies focused on other carnivores have shown that providing animals with food at regular intervals, as is common in captive settings, regular, may inadvertently facilitate the development of novel stereotypic, i.e. purposely repetitive behaviors by reducing the need for a high degree of cognitive engagement with the environment. The researchers were therefore not altogether surprised. So if you're not surprised, it's exactly what you'd expect. So there's no but here, essentially. This is following from it, right? So wild versus captive, what are they saying is wild. Well, I don't really know what wild does, but I know captive is these novel stereotypic behaviors. So they're repetitive behaviors. That's not how you spell repetitive. I don't know if that is either, but I don't care. Okay. Yeah. So I don't know. Researchers there were not surprised to find that the captive ones did something repetitive. I don't know. Bones from carcasses provided to captive lions showed signs of extensive gnawing beyond the point of nutrient extraction, whereas, it's a but word, bones from prey hunted by wild lions had not. So what are we talking about? Where are we getting bones from, right? This is not part of this at all, right? So some of you are going to think about that. Do I have this somewhere? I would say this is a good example of this, right? Focus on adjectives and verbs, not nouns. Relationships matter, right? So this is in the strong words thing. This is something we think about when we're dealing with the passage, right? Like, for example, I don't care where the national park is. I don't care it's in Tanzania. It doesn't matter. That's a noun. Things like regular, captive, repetitive. These are words that do matter. These are more nouny words, or adjective words, right? I think of the same way when I'm doing a choice, right? Is I don't care that you're talking about bones. That's a noun, right? The bones thing might matter. I don't know. Did they talk about bones in the passage? No. But they did talk about a difference between captive lions and wild lions, right? The wild lions did something. The captive lions did something. The wild lions did not do that. There's a difference. Now, look, maybe the bones thing is truly unrelated to what we're talking about. But in terms of the relationship is exactly what we want. So most people are going to dismiss this choice and say they didn't talk about bones. I look at the choice and I'm like, ooh, you got the right comparison. I don't care anything else. It might be wrong, but I'm keeping it because it has that comparison. So I'm definitely not picking it yet. It's highlighted just because that's the way this thing works. But let's move on. During feeding episodes, captive male lions showed much more aggression than did wild male lions. Okay, so more is another kind of comparison. So you're comparing the captive and the wild, whereas female captive and wild lions showed similar. Okay, so are you saying they're different or not? Right? Well, this is a good example where I think the problem is our comparison has changed, right? It says captive and wild, but let's be careful here, right? What is B really about, right? B is really about male and female, right? We're really comparing those things, right? This is a comparison between the way male lions behave and the way female lions behave. The captive and wild thing is thrown in there to keep us attracted to the choice, but the comparison is shifted. Nothing in this passage was about male and female. So notice the difference. I'm going to eliminate B, and it's similar to the reason most people are going to eliminate A, right? They don't talk about this. But in A, the bones are just kind of like a side quest from the main thing in that choice, which is the comparison between wild and captive lions. In B, the male-female thing is the main piece of it, right? That's the main comparison. So that's why I'm getting rid of it, is it's not that you've brought in something that's not talked about in the passage. It's that we've made a comparison in the passage, but you've made a different comparison in the choice. That's not good. That's the kind of thing we're looking at. Let's look at C. When caretakers placed food in boxes that were cognitively demanding to open, captive lions showed repeated behavior, okay, similar to those that wild lions show in stalk and prey. No, right? You're telling me they are similar, right? We want to show that they're different, right? And why do I know that, right? Because here I said, question mark, right? What do the wild ones do, right? So how do I know that they want them to be different? I should maybe point that out. Providing animals with food at regular intervals is common in captive settings may inadvertently facilitate the development of novel stereotypic behaviors by reducing the need for a high degree of cognitive engagement with the environment, right? If you're in the wild, you're not getting your food in a box, right? Plus, when they say development, right? They're developing these behaviors. These behaviors don't exist in the wild, right? So it's not so much that the wild lions are doing unrepetitive behaviors. It's more just like these behaviors don't exist, right? So these behaviors are just like, non-existent. They're being replaced by these repetitive behaviors, or they're regaining something, right? There's nothing for the wild lions that looks like this, but for the captive ones, there is. But if you're telling me that the wild lions also show this behavior, then the captive lions are not developing it. It just looks different because they're in a zoo instead of in the wild, but it's the same behavior. We want to say that they're different. Something has changed. The captive lions are getting food in a very specific way that is changing their behavior from what it would be in the wild. So C is saying these things are similar. What we want to say is that they're different, the captive and wild. And choice D, captive lions showed a stereotypic behavior of pacing in their enclosures as feeding times approached. Okay, cool. Whereas wild lions showed a stereotypic behavior of pacing before embarking on a hunt. Well, they're doing a sneaky thing here, right? They're using whereas, which is a word that shows a contrast, but there's no contrast, right? They're both pacing, right? Pacing, right? They're both doing the same behavior. It's just different times and different situations, but it's the same behavior. The whole point is they developed this behavior. It's a new behavior. So the wild ones aren't doing it. I knew it was A from the start, mostly because, like I said, throughout this thing, I've taught this test many times. I know the questions, and I know that most people get this question wrong for two reasons. One is they don't actually bother with it because they run out of time before they get to it, which you got to do this question. This is a really good question to do. It's not that it's easy, but I think it's following some really good strategies, right? It lets us kind of use the strategies in a way that's very predictable. So if you're looking for a top score, you have to get this question right. But the most common reason people get it wrong, if they actually do it, is they look at the word bones and they're like, no, it doesn't talk about bones, right? Whereas in C and D, they look at the words novel, stereotypic, and repeated behaviors, cognitively demanding, words that showed up in the passage, and they're like, oh, I like that those words are there. They're matching words. They're not matching ideas. They're not matching relationships. If we think about a passage as a story about a relationship, then it completely changes our perspective on what a good answer choice should be like. It doesn't matter whether it uses new words, right? This is a story that we're finishing. It's possible, that there's some sort of new thing that shows up, right? I mean, you watch a movie and a new character can show up at the end, and it's still the same movie, right? It's still the same story. So the bones are a new character, but it's still telling the same story. It's still telling us about this way that being a captive lion affects your behavior as a lion, right? So this is a great example of what you want to do in your own process of going through these passages to change your behavior so that you don't eliminate a choice like A just because it's got a word that you're like, they didn't mention that. The SAT, especially on the hardest questions, isn't testing whether you can spot a word over here and spot a word over here and match it. You're about to graduate high school. They know you know how to read. This isn't about that, right? This is about something much deeper. This is about understanding the text and understanding the point someone is trying to make. So switch your perspective. That's why I think, especially if you're doing individual practice, not really a practice test where you're probably on the clock and don't have the time to keep going back and forth, but with my strategy trainer, but certainly during practice, have this open, use the strategy trainer so that you can start to see like, okay, can I think of a passage in a way like Mike does that has this kind of more relationship-based summary instead of saying this is a passage about lions. Yeah, okay, great. Good for you. It's a passage about lions. No, it's a passage about a comparison, about behaviors of lions, about how it changes. So it's much more, as I said here, it's much more about the descriptions of what's happening, the adjectives, the actions, the verbs, not the things themselves, not the things. It's not about the nouns. It's what the nouns are doing and what we describe the nouns as doing, right? It's a much more descriptive summary that you want to extract from these passages. So this is one of my favorite questions that the SAT has released. This question here, it just so perfectly encapsulates so many ideas that we really need for the passage. And if you understand those ideas, this is an easy question. It's very easy. If you don't, if you're still treating this as kind of a word search, essentially, the SAT, then this you're going to eliminate A and you're never going to think twice about it. But it's very obviously the right answer to me. Cool. All right. Well, hope that helped. As always, we're going into much more depth with this than I thought. We will do the same thing for the math. I am going to take a break and rest my voice a little bit. You can kind of hear I'm coughing a little bit as we go because it's so much talking, but hopefully this was helpful and gave you a new perspective. And as I said before, this is exactly what I do in the real test. I just do it at much faster speed because I've practiced and I can think very, very fast in this exact same way. But everything I showed you on the screen is exactly the thought process I would have if I were doing it for real on a test with the normal time limits. It's just with practice, it gets really, really fast to notice the right words, notice the right relationships, and apply the right strategies. Okay, another day and another section. So we're going to do the easy or the first math module. I do have some scratch paper ready to go here in my in the corner here so that I will need to at some point draw some things and write some things, but for the most part, I'm going to use Desmos to show most of my thought process. But I do have also a handheld calculator that I would bring to the test. That way I have an ability to just kind of do some quick calculations, but I'll try to do more of that on the screen so that you can see it. But let's just get right into it. And math is going to be the same as basically reading was. There's certain things that we want to do. So let's switch over in our trainer to the main math strategy, which is plug points into equations. And throughout this, even for these easier questions, I'm going to be thinking about, are there points? Are there equations? If I can think about a question in that way, that's usually the way I want to go. So let's see what we can do here. This is the first question, so probably pretty easy, but a certain bird species can fly at an average speed of 16 meters per second when in continuous flight. At this rate, how many meters would this bird fly in 4 seconds? Okay, so basically here you're just kind of using what I would think of as common sense for how to solve like a normal situation. Right, so it can fly at an average speed of 16 meters per second, and then it's going for 4 seconds. So to me, this isn't even a situation where I even think of like myself using math. I'm just like, okay, 16 times 4 is 64, right? It's pretty straightforward. So as much as we are going to think about plugging points into equations, don't use complicated algebra when you don't need to. Just try to think some things through, especially some story questions. You're going to be tempted to write an equation because that's what your math teacher would make you do. But you don't always need to do that. You can sometimes just think about it in a very logical way. So that is the answer. Let's move on. All right, here we have points and equations, right? Or at least we have equations. And so without even reading the question, I'm like, oh, it'd be cool if they gave me points. Well, they say this is line R in the xy plane, a slope of 4, and passes the point 0, 6, which equation defines line R. So different ways to think about this. But honestly, I forgot I can't highlight in math. But my first thought is just like, okay, this point goes in these lines, right? So if I were to put 0 in for all these x's, then all these first terms would go away, leaving me with just the last number. And so the last number has to be 6. Well, this is 4, this is 4, this is -6, this is 6. And then, yeah, you can check, is the slope 4? Yes, well, because we know there's the most common equation we need for the SAT. The most important formula for the SAT is y equals mx plus b. We're going to see lines in all sorts of ways. Here's one way. And yeah, there you go. It has a slope of 4 because that's the M position. So many of you would just deal with that first. It's not wrong to do that. But, don't underestimate the power of, like, if they give you a point and they give you an equation, whether it's an equation that you've seen a million times or one that's completely new to you, points fit in equations. Just plug them in. And I think, it's a good habit to get into. That's, I guess, my point is if you're using strategies on easy questions, then that strategy becomes a habit and it becomes your default move so that you really can use it very efficiently for the hard questions. So yeah, that is the answer. Let's move on. Okay, which expression is equivalent to this? So this is clearly some sort of algebra question, right? We're supposed to think about how you can tell with the parentheses we would factor, right? You would factor. But the way I would think about it, sorry, I'm still getting over a cold. The way I would think about it is, there's two options, right? If I go forward through the question, I'm going to be factoring, right? I'm going to be pulling something out of all these terms. But factoring is basically like complicated division. So I would rather do the opposite, which is just multiplication, right? And it's slightly complicated multiplication. It's distribution, right? But it's to me, that's easier. So this is a good skill that you need for the SAT in both reading and math, right? Is pick the direction that's easier to go. Sometimes it's easier to work from the answers, like we do in kind of grammar, and then figure out what the question wants based on that. So here I would say, all right, well, if I were to multiply this x to the 4th in, I would get 5x to the 5th and minus 6x to the 4th, but where'd my 8x to the 3rd go, right? I wouldn't get that, so gone. Here, if I multiplied x to the 3rd in, right, so 5x to the 5th, that looks good, minus 6x to the 4th, plus 8x to the 3rd, that seems pretty good. But, maybe I made a mistake, right? Don't trust yourself completely. 8x to the 3rd times 5x squared, though, wait a minute, how am I'm getting 40 here? So no, that doesn't make any sense. And then here, I don't even know what's happening. I don't know what they're going for here, but 6, this is just nuts. So no. So there you go. That's the answer. Now, I don't think it's a particularly big deal on a question like this, but if you're really, really, really bad at math, this is the kind of thing where you can let Desmos solve for you. You can essentially go to plug points into equations. Since they're telling us these are equivalent, there's basically an equal sign between this top thing and all these bottom things. And then you can plug points into those equations, this equation, and see if it works. So I'll show you that just for the sake of kind of making my point that you can use this strategy. The thing is, they don't give us any points to plug in, so we have to make up our own. So if I were to do that, what I would do is I'd say, all right, well, is there a number that would work out nicely here? The problem is if I pick something like 0, which is my default move, it's not going to work great. So I would maybe pick something else. And I'll show you how you can use Desmos really quickly to do this. Let's just, instead of using X, let's use A. Because if I use X, Desmos is going to want to graph things, but I don't want to do that. So that allows me to do A as 1, just for the sake of having some number. And then when I retype the top, I'm going to get this version of the equation as a number instead of as a bunch of variables, right? Because I've replaced the x's with a's. I've typed exactly what I saw, and then it's giving me the value of 7. And if I adjust this slider, notice it adjusts the value as well. So let's just keep it at 1 for simplicity's sake. And then the goal is, can I get the same thing in the same equation, right? So if I had no idea what the answer was, I would have to try each equation and I could type them in and be like, oh, okay, this first one, right? A to the fourth times 5a minus 6, 5a minus 6 gives me a different number than the top equation, right? Than the one I'm starting with. So if they're equivalent, they should give me the same number. So it doesn't. So that would prove A wrong. If you've kind of done this originally and with some algebra and you just want to verify it, then I would say just go to the answer that you thought was right. 5a squared minus 6a plus 8, and make sure you type everything right. 5a squared minus 6a plus 8, a to the third, yep. And then notice we get the same number, right? Same number that we got here and here. And if we adjust the slider, notice it's the same number every time, right? And that's really the point, is sometimes we start with a number when we arithmetize, which is what we're doing here. We're arithmetizing. We start with a number that, works in both places, but that's just a coincidence. And so we might need to try a second number. So none of this is really necessary for this question, but I think it's important to notice opportunities to use the strategies, even if you go a different path. It's about having options. And for a question that's easy, if you notice that you have 3 or 4 different ways to solve it, that's great. Because on a harder question, you might not have all 3 or 4 ways, but the fact that you're recognizing it on an easy one means that you get something out of a hard one. So just something to keep in mind. Maybe I'm wasting your time, but whatever. Let's move on. You're watching an 8-hour SAT video. You've got plenty of time. Okay. The equation x plus y equals 1440 represents the number of minutes of daylight between sunrise and sunset, x, and the number of minutes of non-daylight, y, on a particular day in Oak Park, Illinois. If this day has 670 minutes of daylight, how many minutes of non-daylight does it have? Well, this is perfect because this is essentially a plug points into equations question. Now we have an equation, so I'm thinking, okay, did they give me some point to plug in, right? So I'll just do this in Desmos just to show you. I normally would write something like this out. And there's our equation. And so, okay, the 670, what is that? That's the number of minutes of daylight. So now go back to the question. Make sure you understand which variable corresponds to that. So the number of minutes of daylight, x, right? So there you go. That's going in for the x. So essentially what we're doing is we're doing 670 plus y is equal to 1440, and we're solving for y. Now, I would just get a regular calculator and subtract it, but just since I'm already typing into Desmos anyway, let me show you what we can do here. Is if I zoom out, I'm going to get a horizontal line because I only have a y. And so basically what Desmos is doing is it's solving this equation for y for me. And it thinks of it as y equals 770, which is a instruction to graph a horizontal line. So it's just doing that for me. So there you go. That's the answer. But this is a case where I would just, in my calculator, be like, okay, this is obvious. 1440 minus 670 is 770. But Desmos is cool. It does all sorts of cool things. But, this is an easy version of a question we're going to see many times on the SAT, which is essentially a story where they give you a point. And sometimes the equation will be more complex. In this case, if we had plugged the 670 in for y accidentally, it wouldn't have mattered. We still would have gotten the same answer because there's nothing really else going on this side of the equation. But other equations, that might not be true. So making sure you plug into the right spot, very, very important. Moving on. And by the way, I'm checking all these answers as we go. We've been right the whole time. All right, moving on. In this one, I don't see any equations, but let's see. Scott selected 20 employees at random from all 400 employees at a company. He found that 16 of the employees in this sample are enrolled in exactly 3 professional development courses this year. Based on Scott's findings, which of the following is the best estimate of the number of employees at the company who are enrolled in exactly 3 professional development courses this year? Okay, well, this is a case where I'm creating an equation. I understand that essentially I'm going to have to solve for x. So this is a case where I'm not really using these equations that are in my my list here. You might think of it as a kind of a statistics equation in a way. It's essentially a ratio that we're going to make. So basically, I know that if we have this sample, 16 out of 20 of these employees are enrolled in these courses, right? So I want to know what's the equivalent, right? That's a percentage, in this case 80%, but we don't need to think of it that way. We can just say, okay, there's some number out of the 400 who are also enrolled, Right now, some of you are going to think about this by like multiplying how many times does this 20 go into 400 and kind of multiply that way. We could do that. But just to show you, again, the power of Desmos, if I set this equation up right, normally you would probably solve for x. Some of you would cross multiply, which I don't love. You don't need to cross multiply in a case like this because our x is on the top. But either way, you might multiply by 400 on both sides. But look at Desmos is doing it for me. And this is a key idea with Desmos is if you give it an equation with one variable, I should have zoomed, it's going to solve that equation for you, right? And so specifically, I use x most of the time. And so it's going to solve that equation by giving me a vertical line where that x answer is. So 320 here. And that's a very convenient way to reduce the amount of algebra that you do in the test. You still need to set up the equation correctly, but even something as simple as this, which you really want to know how to do. It's basic algebra, but it's something to let Desmos do if you can. And especially since I haven't talked about this, but for me, the hard reading module that we would have done right before this is extremely draining on my brain. All that reading, all those words, it's just so difficult. It's very hard. So you get a 10-minute break on the real SAT between that hard reading module and the math section, the first math section. So that's something. So I usually eat a snack, go to the bathroom, kind of just get up out of the seat and kind of like clear my head a little bit. But to be honest, 10 minutes is not that much. So I tend to use the first math module as a recharging time. I let my brain kind of like rest a little bit. Now, obviously, I still have to solve these questions, but even kind of stupid things like this, where the algebra is so easy, I tend to just outsource it to Desmos. Let Desmos do it. Let me take a little bit off my brain here. I know timing isn't going to be an issue in this first math module. I can finish this thing in like 10 minutes if I really wanted. But I'm maybe going a little slower on things. I'm using the calculator in places that I wouldn't because I'm trying not to be fast. I'm trying not to rush through. I'm able to I know I'm going to have plenty of time. So I'm able to kind of take it a little slower and be more robotic about what I'm doing because I want to save my brain because I'm going to need it again when I get to the hard math module. So that's something that's like a big picture pacing strategy of like, use this first math module if you are skilled enough as a way to recuperate. So there you go. That's what I would do. All right, points and equations again. Now this is a good example where there's definitely an SAT way they want you to do it. I see that I have, right, they want the same solution, right? Okay. So I see that I could find the solution to this equation. Right, I see that this is an equation with one variable. So essentially on the SAT, actually let's put this in here. Right, there's three things that can happen. There's three situations. You can have one equation, one variable. Let's type out the numbers. One equation, one variable. You can have one equation with two variables, or you can have two equations with two variables, right? So these are the three main situations, right? There's more, you can have three equations, three variables, you can have all sorts of things. But in terms of like how we problem solve, I'm always thinking about these kinds of situations, right? So if I have one equation and one variable, like I do right here, I can just solve for x. I can solve for the variable. I can find it, it's possible. If I have one equation with two variables, I'm basically stuck. I could graph a line, I could graph an equation, I could get a shape on the graph, but I wouldn't be able to solve for either of those variables. But if I'm got back to two equations, two variables, then I can graph to solve for x, y, right? So this is basically a situation where I would have a system of equations. So the point is, if I have number three, I'm almost always trying to get back, if I have number two, I'm always trying to either get to one or get to three. Right. So this doesn't really apply here, but I want to type this out because it helps me think about what I want to do in this situation. Right. So I'm in zone one here. This is great for me because I can just solve this, but I don't even need to solve it. Right. I can go to Desmos and let Desmos solve it for me. So 7 times 2x minus 3 equals 63. And this is the same method we've been seeing all along. Right. If it's only one variable and that variable is x, it's going to graph an up and down line for us, right? So the variable x is 6. Now, they don't want to get 6, right? They are not giving us the answers themselves. They're giving us other equations that supposedly have the same solution. And so, there are shortcut ways to do it. It's actually really obvious what the answer is, but I would still check my work. I would still do 2x minus 3 equals 9. And notice what just happened. I got the same line in the same place, right? So if I turn it off, you can see, and if I turn the purple off completely, there's 6, right? So why do I know that's the answer right away? Well, I can see the commonality. 2x minus 3 is in both equations, right? Basically what they're saying here is divide by 7 and get 2x minus 3 alone. So if I do that, 63 divided by 7 is 9. That's basic multiplication. I can do that in my head. But again, this is the first math module. Not only do I want to be kind of dumb and allow my brain to recover, but I also want to be right on everything. And so to me, the extra seconds it takes to type this into Desmos and be sure, whether I do it as my first step or whether I'm kind of using it only to check my answer, it is so worth it. You do not want to take anything for granted on that first math module. If you get anything wrong in the first math module, you have failed. You have basically made it very hard for you to get a 750 or better in math. So for some of you, if that's not your goal, that's fine. But if your goal is to get an 800, obviously that gets lost in the first math module if you're not careful. So you have the time. Be careful here. Be careful. And thinking of these 3 basic situations is really helpful for me because I'm always kind of like, I have a task in any of these, right? So if I have the top one, I'm just going to type it into Desmos. If I have the bottom one, I'm going to type it into Desmos. If I have this middle one equation, 2 variables, I have to get to one of the other situations. That's kind of my main goal. So let's see let's match that kind of as we go with our plug points into equations. This is a good example where I have an equation, I don't have any points, but they're specifically asking for me to solve. So solve for x using Desmos, using vertical line method. That's kind of where I went in this case, right? I'm not plugging the point in because there's a specific solution, but I can find that solution using the calculator. Good. All right, these are nice and fun, easy questions. All right. So this one I can tell I have an equation, I got a lot of variables. So maybe I'll arithmetize here. The given equation relates the positive numbers C, P, and K, which equation correctly expresses C in terms of P and K. So here's a case where I'd be like, oh, I could pick numbers, right? I can pick numbers for P and K. And then that would give me a value for C. And then I would just use all 3 of those values and see which equation still gives me a 4 equals 4 situation, like a proof of its existence, right? So this is me thinking, I have equations. They gave me those. They didn't give me points, but if I don't have points, maybe I can make them up and I can use Desmos sliders to help me. But then I'm also like, yeah, but the thing they're asking for is about as easy as it gets, right? They're asking for the value of C. The only thing in the way right now is 7 or negative 7. So if I just add that over, that's one of the most basic algebra moves, then I'd have C by myself and I don't even need scratch paper, right? I could just move it over like that. But again, if I had tons of time, it wouldn't take long to be like, okay, 25, this is something I'd probably do in Scratch, but like I would say like P equals 1, K equals 2, and then say 25P plus K is 27, right? So then I'd have something like C minus 7 equals 27. Now Desmos doesn't like that kind of thing. But you could just kind of be like, all right, well, it's obvious in this case that C is 20. Or sorry, C is 34. Because then 34 minus 7 is 27. So you see how you can kind of check as you go and just make sure? See, I almost had like a little bit of a thing. So you might as well check it. So now they're kind of scattered, but I have values for P, K, and C. I made these 2 up. I used them to find C. And now I can just double check. If C is 34, then 25P plus K plus 7 should also be 34. 25P plus K plus 7 is 34. That is by far not the most efficient way to do it. I would never really do that on the test because it's so obvious what this algebra is. But if you're really, really bad at algebra, keep it in mind. I've seen people get this wrong. So, I don't know. Hopefully you can get better at algebra for the test. That's maybe the best way to put it. But yeah, that is the answer. Let's move on. Okay. All right. I see equations. So I'm already thinking maybe I have points that I can plug in. Let's see. Function P estimates that there were 2,000 animals in a population in 1998. each year from 1998 to 2010, the function estimates that the number of animals in this population increased by 3%, the number of animals in the population the previous number of animals in the population of the previous year. Which equation defines this function where p of x is the estimated number of animals in the population x years after 1998? So you could absolutely plug points into equations here, right? They're giving us an equation. Specifically, it is a exponential equation. They're not really giving us tons of points. They're giving us one, but it doesn't really help us here. They're essentially giving us the point, and I wouldn't type this into Desmos, but I'm just too lazy to keep switching between the scratch paper and this. But they're basically giving us the point 0, 2000, right? They're telling you in year 0, which is how they're framing the x. They do this a lot. X years after 1998. So 0 years after 1998, which is 1998, the population is 2000, right? So if you plug 0 in for x into all of these equations, they're all going to give you 2000, right? And that's because anything to the 0 power is 1. So 3 to the 0 is 1. 2000 times 1, 2000. 1.97 to the 0, 1. 1 times 2000, 2000, etc. So that point, if you didn't know that, you could easily just put this in the calculator and be like, okay, what is 2000 times 3 to the 0? Hey, it's 2000, right? So let the if you don't know your rules about basic zeros and ones and the properties of numbers, let the calculator tell you. It knows the rules, right? So that point doesn't help us because it's not getting rid of any choice. From there, though, you could say, okay, well, it's saying there's a population increase of every 3%. So why don't I just increase 2000 by 3%? So you could do that. That would require some basic percentages, right? You have to say like, you could do this in Desmos, 3%, and it automatically puts the of there, and then 2000, so it's 60. So your actual point now would be 1, 60. And then you could plug the 1 in for all the choices and see what you would get. Now, this is something I might only do because I know the exponentials. There's a certain formula, and basically, I will use the scratch for this. Let's come down here and draw. Ooh, it knew to switch right over. So this is a case where I'm going to use one of the open formulas. So for exponential equations, we use the percent change formula. We're going to throw a little exponent up there, but essentially this mimics what we have. So O stands for the original amount. We know that that's 2000. They told us this is an increase of 3%. So that means I'm going to use 1 plus, and then the P is the percentage as a decimal. So 3% as a decimal is 0.03. So that's to the T, and the new here is just the P of X. So I guess I could write that, P of X. So the way we write it is kind of got the Y on the other side. That's just because I wanted to spell the word open, and the E is the equals, and it matches our percentage formula. So don't worry about that, but we can always move it back over. Point is, now we have a better sense of this middle piece, which is really the only thing that's changing here. So 1 plus 0.03 is 1.03, and that gets us choice C. Now, if I did that and I wanted to check my logic here, so 2000 times 1.03 to the first is 2060, which makes sense because I should have written it differently before. But we are taking and we are adding on an extra 60 to what we started with, the 2000. So there you go. That's the way it would work. This is just a point. But again, that's inefficient. The way to do it here is to really just get comfortable with the exponential. Pretty much any equation I'm listing here is something that probably just has something to memorize. The formula itself, the purpose of all the variables in those formulas. If you're not comfortable with things like y equals mx plus b, vertex form of a quadratic, the exponential equations, you are going to have trouble on the test. This would be a question that would take me all of 5 seconds on the real test because I just know the stuff. But in a way, you could plug points into equations if you needed to verify it. All right. Again, points and equations. Now here, this looks remarkably similar to this question, right? Very similar, right? Equivalent expression. You got a starting thing. You got some ending things. You have nothing to solve for, right? So nothing to solve for. Here's though, I can tell things are a little bit more annoying, right? There's an exponent involved. There's 2 exponents involved, right? There's this kind of foiling going on. There is no freaking way I am going to do this by doing algebra. I do not trust myself. But what I notice is that all the answer choices end with different numbers. And since these are very simple equations, these are polynomial equations where we just have kind of like basic x's and all that, I know that if I plug 0 in for x, if I arithmetize with 0, I can eliminate all these other pieces. And all that I'll be left with is negative 14 plus 96 plus 121 plus 146. 4 different numbers. Meaning, whatever number this top gives me, I'll know for sure what the answer is. So this is the kind of thing that I actually, old school, I would go to my calculator here my scratch paper here, because it's so easy to do this, right? So this is number 9. I would arithmetize that x is 0. And then on my scratch paper, I'd be like, okay, well, now this equation becomes 0 squared plus 11, which is 11. So 11 squared, right? Because don't forget the squared on top, plus 0 minus 5 is minus 5. 0 plus 5 is positive 5, right? This is what I literally write on my scratch. And now I can use a calculator if I need to, but 121 is 11 squared. And then negative 5 times 5 is minus 25, right? So that's what? 100 and then another 4, so 96. Should be B, right? Now, another way to verify that, again, if I had tons of time, I could verify that by seeing what the shape of these things is. So I could do x squared, x squared plus 11 squared plus, that looks weird, x minus 5, x plus 5. Now, what the calculator is going to do is it's going to default to this being like a y equals situation, and it's going to graph it. And it's a very narrow looking parabola, essentially, right? So there it is. Now I could then take my answer and I could say, okay, well, my answer should be the same shape, right? 23x squared plus 96, right? Is it the same shape? Yeah. If I turn the green off, it looks exactly like the blue. And if I graphed any of these others, I could just tell from the y-intercept we'd be at a completely different spot. So this is a good sign. I would not be doing this Desmos check to start, though. I feel like it's a lot of typing. I don't like that. For me, picking a 0 and plugging in is so easy. This is the kind of thing where, like, if we go back to this one, I'm probably not arithmetizing here for real, because I know that 0 and maybe 1, are not, 0 is not going to work. 1 might work. I forget if that works here, but it's just so easy to just think of this as simple distribution from the choices. So this is a case where I'm deciding, okay, I could arithmetize, but I'm going to do algebra. This is a case where I'm just thinking the algebra is risky. I would bet if you've taken this test and you got this wrong, I would bet it's because you did algebra from the start and something got lost. Maybe you didn't square this right. Maybe you got x squared plus 121 and you lost the fact that there's an extra 22x in there. And then I don't know how that affects things. Maybe that gets you D or something, but so many people are going to get this wrong because they just don't do the algebra right. Even if you got it right, you might have done an algebra step wrong in the middle and had to go back and kind of fix things. But this is one where it's instantaneous for me, and it needs to be for you. That if you just put a 0 in for all these x's, this math becomes childlike. And so you can just get an answer right away. So, this is what we're looking at. This is why I'm really diving deeply into this and doing this grind mode is there's decision-making processes, and you got to be, getting on the right path very quickly for questions. This is one where absolutely the right path is pick 0, plug it in, and just do some very basic arithmetic. It's so much easier and it's so much safer. Okay. Here we have another equation. An egg is thrown from a rooftop. The equation of this represents the situation where h is the height above the ground. According to the equation, what is the height in meters from which the egg was thrown? Okay, so this is a definition question, right? So this is kind of something I said before, is we need to be able to recognize certain equations. This is a standard form quadratic. I know that a standard form quadratic tells me the direction of the parabola, right? So negative 4.9, it's telling me it's opening upside down. And then 18 is the y-intercept. I know this from memory. Are they asking for the y-intercept, right? The height that it was thrown from. Right, so if it's thrown, that's kind of like the first thing that happens, right? Because t is the seconds after it was thrown. So I'm kind of almost like forcing myself to recognize that they're asking for the easiest thing for me to give, right? This is a good example of story questions are not really stories; they're just more complicated ways of asking about an equation. So, quadratics have three different forms, right? Standard form, vertex form, factored form. And each form is kind of responsible for a different aspect of a parabola, right? So the standard form I know tells me the y-intercept. The vertex form tells me the vertex. The factored form tells me the x-intercepts, right? So if I'm given this, I'm kind of like, okay, well, at least I know the starting point right away. That's what a y-intercept is. When I'm asked something about the story, I'm also kind of in a limited menu, right? I know that for parabolas, the things that matter are the direction, the y-intercept, the x-intercepts, the vertex. Those kind of four things are really all they're going to ask about. Maybe they'll ask about some random point, but generally it's one of those four. So it's kind of like, instead of being like, well, what do they mean when they say where the height of the egg when it was thrown? What does that mean? My question I'm asking myself in my brain is much narrower. Is that the x-intercept, the y-intercept, or the vertex, right? It's not the direction. So it's one of those three things. Well, the y-intercept, by definition, is where the x coordinate is 0. So the time is behaving like the x. So when the time is 0, you're throwing the egg, right? That's how this whole thing starts. So yes, that makes sense as a y-intercept, and lucky for me, they gave it to me. So this is all stuff that I would realize in split seconds. But I think it helps to narrow your options from the start. You're not looking at this equation and being like, what does it mean? You're like, okay, they gave me the y-intercept. Is that what they want? Now, if they wanted the vertex, if they said, what is the maximum height of the egg? At that point, I'd probably just graph it and then click the vertex point, right? So if I were to graph this, I would switch those t's to x's, just out of habit. Plus 9x plus 18. And there it is, right? So the maximum is some messy number. They would have to give me more information about how to, round that or whatever. But that I would not do any algebra there. I would just let the calculator tell me. But notice the equation doesn't include these numbers anywhere, right? So this is the case where I'd realize, oh, okay, I have the equations, I can get the full picture, but I want the vertex. That's not something that's just displayed in this equation. So being able to kind of read an equation is very important. It's going to save you a lot of time because when it happens this conveniently, I don't need to spend time graphing this in Desmos. If it's the y-intercept and they gave me the standard form, same thing if they had given me the vertex form and asked for the vertex, right? So those are cases where I think a lot of people lose time on the hard module is they don't have those things confidently memorized. And somewhere on a YouTube video, they heard, Desmos will solve everything for you. And they took that to heart. And they go to Desmos and they solve it, but they spend, 45 seconds solving something that I would have taken 5 seconds with. And that doesn't sound like a big difference, but multiply that by, let's say, 5, 10 questions, and suddenly, you're going to run out of time. You're not going to have time for some of those really hard ones because you wasted those extra seconds using Desmos to figure something out that you should have had memorized. So I'd rather you use Desmos and get it right for sure than make a careless mistake. But just keep in mind, if the reason you're running out of time is that you're not memorizing things that you should, you know what you need to do. It's not going to be fun, but you got to memorize stuff in order to make some of these questions super fast. Moving on. All right. We have an equation and they're asking for a point, essentially. Now they're asking for 6x, but we could easily find x, right? So this is going back to here. I have one equation, one variable. One equation, one variable. So what do? We do a little Desmos. 2x equals 16. Okay. Now I have a feeling, because of the radical, it's not going to let me tap this, right? It's the radical, just something happens on the back end in Desmos where it doesn't let me do it. That's okay. I can just zoom and see it's obviously 8, right? Now be careful. Sometimes they'll make 8 an answer so that you're just like, oh, x is 8. But luckily for us, they didn't do that here, but we just need to finish the job, right? 6 times 8 is 48. So that's it. There is no chance on the SAT that I'm doing this by hand. No chance. It's the first module. Like I said, I want to do as little work as possible. I want to rest my mind. And I immediately recognize I have one equation, one variable, so I can get the value of x using Desmos. So there you go. That's all I'm doing. Cool. All right, next question. I already see that I have equations. So maybe I'm plugging something in. Let's see what it says. The relationship between two variables, x and y, is linear. For every increase in the value of x by 1, the value of y increases by 8. When the value of x is 2, the value of y is 18. Which equation represents this relationship? I love this. So this is a perfect example of how my plug points into equations thinking makes a question that's kind of hard to understand super simple. I have equations. Do I have points? I'm literally asking myself that in my head. Yes, I have equations. That's obvious. Does the question give me points? Well, it's not written as a point, but this is clearly a point, right? What is a point going to look like? It's going to be an x value, a y value, hopefully both. And it does give me that. When the value of x is 2, the value of y is 18. So this is a point, right? This is the point, just to kind of type it on the screen. This is the point to 18, or I'll put it, I don't need the space, to 18, right? Now, I'm not going to use this, but Desmos is plotting that point for me. If I wanted to, it's right there. But instead, I'm just going to do this in my head. This is really simple, right? So I would not use scratch paper here, but I would just be like, okay, that point needs to get plugged into these equations. 2 times 2 is 4. 4 plus 18 is not 18, right? That's literally what I'm doing, right? So I'm plugging it in, and I'm not really plugging in the y necessarily because the y is off on its own. I'm just kind of thinking of it like, okay, this is the result, right? So 2 times 2 is 4. 4 plus 8 is 12, not 18. 8 times 2 is 16, plus 2 is 18. So that looks good, but it's possible this could work as well. But then quickly I'm like, okay, well, 3 times 2 is 6, plus 26, we're way over, right? So that's my answer. Now notice I didn't even use this other thing, right? For every increase in the value of x by 1, the value of y increases by 8. So many of you are going to fixate on that piece because that comes before the point, right? And there's just kind of a habit of like, oh, I got to read and I got to do it in order. But sometimes the SAT is genuinely testing your ability to sort through information and prioritize and decide what's the most important or what's the easiest thing. And so here they gave you a very confusing sentence that you end up not even needing because they know you'd be distracted by it and thrown by it. Like, what does that mean? For every increase in the value of x by 1, the value of y increases by 8. It's a slope, right? That's what slope is, right? Slope is a representation, right? So this is how one way I learned slope on the essay, or in all things, is it's the change, the delta in y over the delta x, right? The change in y over the change in x. They're telling you that for every increase in the value of x by 1. So a increase of 1 for x, the value of y increases by 8, plus 8. Now, I don't need the pluses, right? Because it's just 8 over 1, but there you go. That's the slope. That's the m. And there it is. And in fact, that's the only choice that has that. So if you did go that route and you understood that sentence as a direction to find the slope, well, good for you. You also would have gotten C without doing the other part of the question. But, I don't know. That to me is a more confusing sentence. And just because of the nature of the strategy I'm following, I am looking for points if I have equations. I want to plug points into equations. It's so easy because it turns most algebra into arithmetic, right? I could do that arithmetic in my head. 8 times 2 is 16, plus 2 is 18. Done. If you need to use a calculator, you could. But that's you want to have some mental math a little bit on the SAT. I love this question. This is great. This is a good example of how basically what I'm doing, this is maybe a bigger point for the entire math section, is I'm not necessarily looking at a question and choosing a strategy. Sometimes it feels like I'm doing that, and sometimes I talk like that. But in a way, I've almost done the opposite. I have chosen a strategy, and then every time I look at a question, I'm deciding whether that strategy is going to work, right? So the first decision I've ever made for every single question is that I'm going to try to do plug points into equations. Sometimes I can't, but the decision to do that, to try that, has been made before I've even seen the question. It's before I've even seen the SAT. That before that day of the SAT, I have decided my math strategy is this. And that really informs how I think about everything. So that's why I'm kind of like trying to get across here is like, that's always on my mind. And I think that really helps because so much of what's draining about an SAT is the constant decision-making you have to do. If you kind of decide on a strategy that's going to work in a vast majority of cases, and you decide on that before you even see the questions, you've kind of already made a lot of the decisions before you even got into the test. It really frees up the brain to think about other things. It's really nice. So let's move on. How many distinct real solutions does the given equation have? Now, some of you are just going to realize if you square something, you can't end up with a negative. So it has 0 solutions. How could we verify that? Well, we could use Desmos. It's kind of not ideal because you'd have to kind of see it as like, oh, I have that one equation, one variable, but they're not asking for the solution, right? They're asking for the number. And gosh, that negative 841, you're like, ooh, see, and I lost the equals. you're like, wow, I got to scroll out for a while. And I can scroll out, and I can get 841 in here. This is 10,000, negative 10,000. I don't see anything, right? Well, why don't I see anything? It's because there's 0 solutions. If there was one solution, or in this case, if I got rid of the negative, there'd be 2 solutions. Now, it looks like 1, right? But if I zoom back in, there it is. 2 vertical lines, 2 solutions. The trouble is, right? So this method with Desmos works really well when I see the solutions, right? If there were one solution, I would see only one line. If there are 2, I can see 2. The trouble is, what if I see one line, but the second one is off screen and I would have zoomed out, I would have seen it, right? Or maybe if I zoomed out too much, I have to zoom in more to see it because they're blending together. I don't love that. Plus, if there were infinitely many solutions, what would that look like, right? You know, we know there's 0, so we don't see anything here. But again, what if we didn't zoom out enough? You know, like that could happen. We zoomed out to 10,000, so I think we were pretty safe. But like, you know, I don't know. And plus, infinitely many solutions would also look like kind of nothing. You wouldn't see anything. So in this case, it ends up kind of working out. But it's one where I would say you're better off kind of knowing what's going on and thinking of it as like, oh, I just know how squaring numbers works. This is a property. This is a question about properties of numbers. You can't square something and get a negative number. So therefore, there's 0 solutions. Another topic that might come to mind, where is it here? Oh, I don't really have it on this thing. Okay, that's fine. Essentially, there's a whole category of questions where they ask about the number of solutions for an equation, a system of equations. And basically, when you have that situation, your first decision is, do I have an x squared or not? If you don't have an x squared, then you're dealing with lines, and you can think about parallel lines and things like that. If you do have an x squared, that's where we're going to use the discriminant if you have no other ways to do it, which kind of is happening here. And so you would have to get to b squared minus 4ac, which is going to come from the standard form of a quadratic. So in our case, we'd have to move that 841 over so that we have x squared plus 841 is equal to 0. There's no b term, so 0 squared minus 4, a is 1, that's the number in front of the x squared, and c is 841. Now, without even really solving this is a negative number. This is a big negative number, right? So negative, big. And if this discriminant, this d, is negative, is less than 0, then we have no solutions. That's just a thing to memorize. So you could do it that way. You could also have graphed it, plus 841, and gotten your parabola. And now I can see there's no solutions, because when we have a standard form parabola, the solutions are going to be the x-intercepts. And I don't see any, right? It's kind of way up here, so it's never crossing the x-axis. I don't like any of these ways to do it, but for those of you who don't understand the algebra and why it's 0 just by looking at it, Desmos can help. This is very complicated, but you might need this in other situations. So at least have the thought that like, oh, I could use the discriminant. Oh, I could use Desmos if I graphed it this way. Again, that's kind of my point of this grind mode thing, is like all of those thoughts are passing through my head as I see a question like this. And then I'm just realizing I don't need any of them because of the way this equation was written. So there you go. All right. A little statistics. 2 box plots show the distribution of numbers of books read over the summer by the students in 2 different English classes. What is the positive difference between the ranges of numbers of books read over the summer for the 2 classes? So the key word that we first need is range. The range of a data set is its maximum minus its minimum. Lucky for us, that's the easiest thing to get on a box plot, right? Because you have these whiskers, as they're sometimes called, that are the maximum, right? The maximum number and the minimum number. So let's write it here for 14. Come on, you know what I want. There we go. 14. So the range of A and the range of B are kind of the first things we need to find. So the range of A, I can see, right? It starts at 5 and it goes to 0. So, okay, technically, if I'm using the formula, right, which is maximum minus minimum, That's 5 minus 0, which is 5, right? So 0 doesn't seem to really matter, but it matters, right? It's part of the formula. And if we do the same thing for b, I can see the maximum there is 10. And this is where most people mess up. The minimum is 1, right? It's not 0, it's 1. I don't know why people mess this up, but I see it all the time. Every time I teach this test, people get this wrong. They get the minimum, or sorry, they get the range of b as 10. I think because they just look at how far out it goes and they don't look back. I really don't know. But I would say it's at least 25% of people get this very easy question wrong. And the answer then is, well, they want the positive difference, right? The positive difference between these things. So 9 minus 5 is 4. But so many people put 5 here as the answer. And they always tell me the same thing. They're like, oh, I misread it. Guys, we're in the first module, so these are easier questions, but we're already at question 14, where we know that the difficulty is starting to increase. So it's not a hard question, but like they're going to try to slip some things by you, right? They're going to see if you're paying attention at the very least. So if you got this wrong, you weren't paying attention. The bare minimum you have to do on these questions is pay attention, is read what they say. So a lot of people are just kind of like looking at this number and seeing the 0. I don't know. I don't know what causes this. This is so obvious. But just since we're also talking about box plots, the median for each of these sets is going to be given by this number in the middle, or this line in the middle of the box. So in this case, the median number for class B is 7. The median number for class A is 2. That wasn't relevant to this question, but in terms of, sometimes we need to memorize things. This isn't a plug points into equation situation if they're asking for the median. It is maybe if they're asking for the range, like they did here, I'm plugging into an equation. But that's something to memorize, is you got to know median, not mean, not average, median. So yeah, I don't know. People get this wrong all the time. It's kind of a shame. All right, geometry. The length of the edge of the base of a right square prism is 6 units. The volume of the prism is 2,880 cubic units. What is the height in units of the prism? So this is definitely a plug points into equations situation. Oh, it's over here. Right? Do I have equations? Yes, this is a geometry situation. My reference sheet gives me a bunch of equations, right? You're talking about the volume of a prism. So open your reference sheet, right? We've got a bunch of volume formulas here. Now, the main reason people get this wrong is they forget what these shapes are called. This is a pyramid, guys, down here that I'm circling. That is a pyramid, right? Think of the things in Egypt that you've seen a million pictures of, that you probably did a whole diorama in elementary school about. The pyramids in Giza look like this, pointy triangles. A prism is this guy, right? Now, you might be thinking of a prism, a triangular prism is the kind of thing that, you hold it up to the light and it shows a rainbow. That's still a prism. A prism is just a shape where you have two ends that are whatever the name of the prism is, and then they're connected by rectangles. So here they told us it is a right square prism, meaning we have two squares that are then connected by a bunch of rectangles. But that's essentially just a box, right? So that's this. Here it is, right? That's this. So this is a case where I'm going to use my plug points into equations, right? I have an equation, so let's start just by writing that down. This is number 15. Volume is length times width times height, right? They tell it to me. There you go. So what did they give me? Just plug things in. Well, they gave me the volume, so plug that in, 2880. They're asking for the height, so I know that's kind of like the unknown here, right? So that means they must be giving me the length and the width. Well, I only see one other number. I only see the 6. But notice they told me that, again, follow instructions. It's a square prism, meaning that the length and the width are the same. It's if nothing else, you've no better option, right? So you got to do that. So it's that the length and the width are the same. So we have 6 times 6 times h. Now you could solve, right? But remember, I'm being lazy. It's the first module. So we're going to go here and we're going to go 2880 equals 6 times, now not going to do h, I'm going to do x, because if I get x, then it knows to graph it, and it graphs it right there as 80. And that's it. Right? So you could just, divide 2880 by 36. It's not so hard, but, good habits, right? So yeah, this is another one people tend to get wrong, mostly because they're not following instructions. Maybe you didn't know that a prism and a pyramid are different shapes. That sucks, but you got to learn your shapes. That's pretty basic. But yeah, this is another plug points into equations where you wouldn't necessarily expect it, right? But because I'm thinking of that strategy from the get-go, that's kind of my default move. I'm already thinking, okay, if I have some equation, let's write it down, let's plug things in and solve for the missing piece. And of course, one equation, one variable, right? The h was the variable. That allows me to use Desmos. All right. Scatter plot shows the relationship between two variables, x and y. An equation for the exponential model can be written as y equals a times b to the x, where a and b are positive constants, which the following is closest to the value of b. Again, I've already decided long before I sat for this SAT that I'm going to do plug points into equations. Well, you just gave me an equation, right? You gave me y equals a times b to the x. Do I have points to plug into this equation? Yes, that is what a graph is. Now, the key thing is I don't care about these dots. This is always something that comes up with scatter plots, is the dots don't matter to me. I don't care, right? Because they're telling me the equation for the model, the line, the curve is a times b to the x. So it's the dots have in some statistical way shown me this curve. They've gotten me this curve. They're essentially just doing that regression that we'll probably do more of in the hard module. But I would not do a regression here. That is a waste of time, right? They're asking for the value of b. So I think that honestly, the simplest thing here is just to kind of very quickly go, all right, well, the y-intercept here is really easy to spot, right? It's something like 125, right? I don't need to be exact, but that's my first point, right? Is 0, 125. 125 is my y, and what happens when I put in 0 for x? Well, an amazing thing happens. B to the 0 is 1. So it's kind of like this doesn't exist. A times 1 is just a. So now, without any work at all, I have a value of part of this equation. Now, why is that good? Well, because initially, right, before I crossed out the b, I almost had a bad situation. Almost, right? What's the bad situation? One equation, two variables. I get stuck. Right? When I plugged in the y and the x, it looks like I'm going to be in a bad situation, right? I'm stuck. I have two variables, I have two unknowns, a and b. But because 0 is such a special number, one of those things goes away. So this is something you get used to with this. It's like, okay, I need to get out of this situation where I have two unknowns in an equation. Sometimes we can find those unknowns using another equation or something like that. But other times, 0 or some other number is going to make things work out really nicely. So the goal is the same. If I have two variables in one equation, two unknowns, I got to get rid of them. And one way to do it is to pick numbers that work out nicely. Now, if I pick a new point and I'm going to pick something like 1, I'm going to just be lazy. The next kind of point here looks like 1, I don't know, 105, something like that, right? Between 100 and 110, right? So 105 is my y. My a, I now know, is 125. My b is what I'm trying to solve for. And now my exponent, my x, is 1. So notice that, again, that doesn't really matter. B to the first is b. So I'm just dividing 125 on both sides of this thing, right? So let's just do that in this calculator here. And I never use it, but you have a scientific calculator here. So 105 divided by 125, 0.84, right? Well, I don't have that as an answer, but obviously it's a, right? I was estimating as I was coming up with these values, so there you go. This is just so easy to do. Some of you are going to say like, oh, well, I knew it had to be 0.83 because it's a exponential that goes down. Yeah, fine, but this would be the kind of thing that I'd at least check. It's just so, those kinds of assumptions are what gets us in trouble. It might not get you in trouble here, but it's the kind of thing that gets you in trouble. So maybe you graph it and you play with a slider for A or something. I don't know. But like, to me, this move is so fundamental to success on the SAT. It is a plug points into equations move. It is me being a little lazy and picking the easiest points, which unsurprisingly involves zeros and ones. So this is something I'm going to do very automatically on a lot of questions. Here, There are other ways to do it, but I would just do it here out of habit anyway. And it's one of those things that's absolutely going to come in handy on harder questions where there might not be other methods. So getting used to it, understanding why plugging in that 0 is going to get you out of that stuck situation, that's really, really important. That's like a move that you're going to make in lots of hard situations. And some people are they're not comfortable making it because they're not doing it here and they're not seeing how it works in cases like this. I like this question a lot. This is a good example of how plug points into equations thinking is making me solve something that's a little scary looking within just a few seconds. This would take me less than a minute for sure on the real test. All right, moving on. All right. This is another good example of follow instructions. This is a case where many people do not understand the instruction. They are imagining questions they answered in school involving trigonometry, and they are following those instructions instead. To me, this is another plug points into equations situation. Now, if I go to the reference chart, I don't see any trigonometry stuff here, right? So this is an equation we have to memorize, or more accurately, this is a series of equations that we have to memorize. Specifically, I learned it as SO, CA, TOA, right? This is the acronym for memorizing the trigonometric functions. So cosine is the CA, and what does that mean? What does that stand for? That means the cosine of some angle is going to be the adjacent side over the hypotenuse, right? Well, I know the hypotenuse is always the side that's opposite the 90-degree angle, so that's the 28. So the real question is, do I have the adjacent side, right? Well, yes, because take your angle, and then it's the leg that's right up against it, right? So that's the 11. It's possible they could have given me this other side, right? Which would be the opposite, right? Go across the triangle. If that were the case, I would have needed to use Pythagorean theorem to get the missing side, but that's okay. I don't need to do that here, right? Take the win. Now, what did they ask for? They asked for cosine of x, right? What is the value of cosine of x? We just found it. It's 11 over 28. Put that in. 11 over 28. Don't bother with the calculator here. You can, and turn it into a decimal, but look at that decimal. Oof, now you got to deal with rounding. So if you are going to round, remember you got to type until you can't type anymore in here. So you would just do 0.3928, and then it would cut you off, and that's fine. You don't need to round that 8. You can just keep it. This is what's called truncating. Does it say that here? Yeah, truncating, right? So cutting it off. You don't need to round. Don't round unless they tell you. Just type until you can't type anymore. I have a whole video on how to fill out these SPR questions with decimals and fractions. So my advice is just do the fraction, but there you go. The main reason people get this wrong is they don't follow instructions. In school, you were taught, and you can do this in certain cases, right? You were taught to use the cosine button, right? The cosine button to find the value of this angle, right? You can find x. So it's actually very easy, right? We would just take cosine and do 11 over 28 in that. Oops, so no, this is actually not right at all. You would do the reverse cosine, which is this guy right here, and then you would do 11 over 28, and you would get the wrong answer because this is in radians. So it's not in, darn it. You would get 66.87 degrees, right? So that's the actual value of this x. But we just don't need it. We're not asked for it, right? They didn't ask what is the value of x. They asked what is the value of cosine of x. And so I'm making a big deal about this potential error because this kind of error shows up all over the place, not just geometry, not just trigonometry, everywhere in the SAT, where we've seen similar questions in school. We maybe had homework assignments in school where we had to do 100 of these, and so it gets ingrained in our mind of like, okay, this is what I do in this situation. We get a habit, right? But the SAT is sometimes specifically asking for things that are different from what we would have been asked for in school, knowing that some people can't break that habit. They don't understand, or they don't read, they're just doing these kinds of robotic moves that their teacher taught them. So a lot of you are going to solve for x because that's what you just kind of assume they're asking you to do, but just read it. Read it. That is not what they're asking you to do. So it's just one of those things that I see people lose points all the time. And it would be the kind of thing that on the real SAT, you would get this wrong if you solve for x, and you would never know, right? You would never know that you got it wrong. You would come out of the test feeling great. Oh my God, I crushed that first module. I know I got perfect. And then you come back and you get like a 680 instead of the 770 you were expecting. And you're like, why? Well, one of the biggest culprits for that is stuff like that, where you are so locked in that you are just answering questions that you think that they're asking, but they're not actually asking that question. And so that's why our main math strategy is plug points into equations. Our main SAT strategy is follow instructions. Just as much as possible, treat this test as it's just telling you to do stuff, and you have to do exactly what they tell you and not what you assume they're telling you, not what you have been told in the past, what they're telling you right now. So there you go. 11 out of 28. That is the answer. Moving on. What is a positive solution to the given equation? Well, a solution is an answer. And what do I have? I have one equation with one variable, right? Technically, it's 3 x's, but it's one type of variable. So, okay, I use Desmos, right? I don't even need to scroll down. There's no work to be done. Just type it in. So x plus 2, x minus 5, x plus 9 equals 0. And let's kind of rearrange some things. There we go. I don't know why I did that, but there you go. There are 3 solutions, and they want positive. So it looks like 5. Now, that is something you could easily get without going to Desmos, because if you're in factored form, which is what we have here, finding solutions is easy when we're equal to 0, right? Because essentially that's the entire purpose of factoring, is to use the properties of 0 to get the values of x. So you should know, without even needing to graph it, that -2, +5, and -9 are the answers, the solutions. That you will need to know for other questions, right? So I have no problem if you use that here, it's fine. But, how long did it take me to type that in and be really sure? Again, it's the first module. Take a few extra seconds, be really sure. Your brain is very tired from the reading module. So not only are we trying to save our brain and try to rest it a bit, but it's going to be more prone to mistakes than it might be normally. So having the picture is pretty good. Plus, I could easily see them kind of manipulating you here. I could easily see them doing x plus 2 times x minus 5 times x plus 9 equals 1 or something. Just changing that last number so that in your mind you see this side and you're like, oh, this is easy. I just do -2, 5, and -9. But because this isn't equal to 0, it's equal to 1, it now changes everything, right? So now watch, if I were to switch that here, very subtle, but they all moved. I can't see it, but look, they'd have to change the equation other ways, but you can see it's not 5 anymore, right? It's 5 and change. There's extra stuff. So they'd probably pick a different number where it just moved in a way that you'd still get the answer, but there you go. Cool. Yeah, I don't have much more to say about this. So let's move on. Okay. All right. This is where you're going to need your scratch paper. If you're trying to do this without scratch, you're an idiot. Don't do that, right? Your brain is tired. Draw it up, right? So we have this picture. So I'm just going to redraw it. So 19. And it doesn't need to be perfect, right? So I just drew a little bow tie thing. And label it. Don't cut corners. The whole point of this question, and I know this from experience, is they are trying to get you to make mistakes because you're lazy and you read things wrong. So don't let yourself read things wrong. Draw it out. All right. In the figure shown, WZ and XY intersect at point Q. Okay, that I can see. YQ is 63. So fine, put that on there. WQ is 70. WQ is 70. WX is 60. That's here. And XQ is 120 here. Okay. What is the length of YZ? So put a little question mark. All right. Now, is this a plug points into equations question, right? That's kind of how my brain is thinking. In a way it is. Yeah. Essentially, with geometry, like with grammar, there's a limited set of topics that they put on the test. And that helps us. That's really to our advantage because it means that we are looking at any question, there's only so many things that could even happen, right? There's only so many rules they can ask about. And so anytime I see some triangles and you're comparing them, it's probably a similar triangles thing. So essentially the equation is we have to set up a proportion. So it's not like a formula per se. It's not something we're going to find in the reference sheet, but it is something that kind of, I've got like a structure, right? I have this kind of like double fraction that I'm going to use, and I'm going to plug points into that. So you might set that up that way of like, okay, I have two fractions. My go-to is start with the thing we don't know, right? So YZ, don't write X, right? It's not an X. X is over here, right? Write it as it is, right? Write YZ. They gave you letters for a reason. And essentially what I want to do is both on the bottom here and on the top here, I want to have some side length that is related to YZ in some way. So there's multiple ways to do it, and there's multiple ways to set this up, and you will get the same answer no matter what. So don't comment here like, oh, what if I put it this way? If you got the same answer, you did it right, right? So the first thing I would say is like, well, the only thing that I can see is obviously in common with the YZ is the 63, right? That's the only other piece of this triangle I have. So I know I'm going to have to use that, right? So I'm going to put that on the bottom. Then I have two options, right? I can say again, well, what is the YZ related to? Or now I can even say, what is the 63 related to? Well, I can see that the YZ is this kind of side on the side. So it's probably the 60. And I can confirm that because I know that if these lines intersect at Q, I have vertical angles on either side in either triangle at Q. And when I think about similar triangles, I'm looking for sides that correspond, meaning that the sides are not the same, but they are across from the same angle, right? So if I think about across here, I can see that YZ is across from Q. What other angle, or what other side rather, is across from Q? Well, that's the 60. So it looks like that, but harder questions with similar triangles, it might not look as obvious as this, like what's equating to what. So this thing of thinking about angles is really important. So let's talk other correspondence, right? I also see there's this A angle, right? So the A is kind of across from QZ, which I don't know. But I do see that I have the A across from the 120. So you might be thinking, well, if I can get QZ, that's good. But no, not really. We've already got that one triangle covered, right? This triangle here is already covered. So what we want is what corresponds with the 63 that we really had no choice. Well, the 63 is opposite this other angle that we haven't really even touched on, right? We don't know anything about it. But that's okay, because there's another angle we don't know anything about on this side, and that's the X, right? So if I kind of go across from that, I realize, oh, that's the 70, right? So again, that might be obvious the way it looks. The 63 is kind of like on the top here, and the 70 is on the top here. But they could draw this in other ways where the way it looks is not the way it matches up. So you just gotta get in the habit of doing this angle thing. It's very easy. Now, once we have this, right? Once we have our equation, I'm going to solve it. And it's an equation with one variable, right? YZ is just a single unknown. I am going to let Desmos solve it for me. But here I am going to switch it to X. I don't switch it to X on the paper because I don't want to lose track of what I'm solving for. But here, I'm going to just type it in. I know it's going to be a positive number somewhere. So there it is, 54. Right? And just make sure you, with any geometry question, always double check before you move on. Did I solve for the thing they wanted, right? So we kind of were doing that at the beginning. So YZ, yes, is what they wanted, but it's very important to kind of like, just be careful that one of their most favorite traps on these geometry questions is they know what you're going to solve for, and then they deliberately ask for something different so that they can catch you, again, not following instructions, not paying attention. Just since I have it drawn, I'm going to show you. Normally in school, we learn to cross multiply and multiply the 70 by the YZ. That's something you're taught when you're really young and you don't understand really fractions. And so they just kind of teach you this as a safety mechanism. But one of the better things to do is whenever you create proportions, make sure your unknown is on the top. If you do that, you don't need to cross multiply. You don't need to do an extra step. We can just do 60 divided by 70 and then multiply both sides by 63. And now the YZ is by itself. And right, we just have to do this. And it doesn't matter what order we do it in. It'll be the same, right? So you can do 60 divided by 70 first and then multiply it by 63. But because it's all just multiplication and division, order doesn't really matter here. So 54, and you could also do 60 times 63 and then divide that by 70 and you still get the same thing, right? So it doesn't actually matter. But that's the way, instead of cross multiplying, which I think confuses people, I think it's better to just create a proportion of ratios where the unknown is on the top. If it's on the bottom, then you're probably better off cross multiplying, but there you go. All right. Plug points and equations saves us again, right? That's plug points and equations here. All right, well, guess what? I've got another equation. Looks like I got some points, so I'm probably plugging points and equations. Let's see. The function g is defined by g of x equals x plus 14 times t minus x, where t is a constant. In the xy plane, the graph of y equals g of x passes through the point 24, 0. What is the value of g of 0, right? So this is so obvious because did they give me points? Yes. Here's one. Did they give me an equation? Yes. And specifically, they're telling me this point is on this equation, right? They're both in this g of x. They're both g of x's. So here, again, I like my scratch here. I'm a little old school. This is number 20. Plug points into equations. I have points, I have equations, plug them in. So just remember how this works with function notation, right? So 0, that's kind of like the g of x. So I'm going to get 0 is equal to, and then 24 is the x value. So 24 plus 14 times t, which I don't know, minus 24. Now notice, they're not asking for the value of t, right? They're asking for the value of g of 0. But I'm not even thinking about that yet. This is, again, this kind of mentality of like, I know my strategy before I even start the SAT. I know I'm going to plug points into equations. So when I get to this situation, I'm not debating how is plug points into equations going to help me. I'm just kind of like, yeah, that's what I'm supposed to do. This point goes in this equation, might as well do it. And so now I kind of see, all right, well, I have one of my best case scenarios, right? I have one equation, one variable. I can solve for x. So again, I can do this with algebra, but if I'm being lazy because it's the first module, I'm just going to do 0 equals, and I'm not even going to do 24 plus 14 because let the calculator do that. I am going to switch the t to an x because I want it to graph that line, and sure enough, it does it at 24. So what did I find? I found that t is 24. Now, some of you are going to say, yeah, isn't that obvious? Because if it's 0 and this isn't 0, then this has to be 0. Yeah, okay, fine. But like, why think about that? The thought didn't even enter my mind. I knew the calculator would spit the answer out for me. Why bother thinking about it? Again, I'm saving my brain. Now, though, because I have the value of t, I actually have the entire g of x equation, right? So I have g of x, and now I know all of it. It's x plus 14 times 24 minus x. Now, when they tell me this other instruction, what is g of 0, I can do it. I can solve it. Now, again, because I have the calculator, I might as well let the calculator do it and show and remind you of some things that Desmos does, right? If I have x plus 14 times 24 minus x, and I tell, it's like, why is this wrong? If I tell Desmos that, and I'm going to check always, right? Notice how I caught that error. I'm always going to check that I type it right. So yeah, this looks good. Now I can just ask Desmos, what is g of 0? And it'll tell me 336. So I don't need to plug it in. But essentially, what is this last instruction? It is a plug points into equations instruction as well, right? If I ask for g of 0, then that means plug in 0 for x. So 0 plus 14, which is 14, times 24 minus 0, which is 24. So this question is just asking, what is 14 times 24? It's 336. So there you go. I love this question. This cannot intimidate you. And it doesn't intimidate me because I'm thinking plug points into equations as I go in. I've got that strategy. It's just already like what I want to say. It's a reflex. So if I see points and equations, I'm already like, okay, I'm jackpot. This is what I want, right? So that's kind of the point of this trainer, is to keep getting you thinking of that. And these lists here are meant to remind you of things and be like, okay, when they talk about function notation, that's essentially points, right? They don't always have to have the classic XY format like this one does. You know, these are different kinds of equations, different kinds of points. When you've got them, just use that strategy. Great question. Yes, in the easy module, but this would be considered a hard question. Yes, College Board considers it hard, but this would be easy for me because my strategy is kind of priming me to succeed. All right, moving on to 21. All right, percentages. Percentages are notoriously tricky on the SAT. They are trying to mess with you. So, already I'm thinking plug points into equations. I do have certain equations that I've memorized for help with percentage questions. I'd love to get points in there in some way. Maybe they gave them to me. I don't know. But this is a case where I'm not cutting corners. You got to know this is where the traps are. So you got to be really careful. The number of zebras in a population in 2018 was 1.27 times the number of zebras in this population in 2014. If the number of zebras in this population in 2014 is p% of the number of zebras in this population in 2018, what is the value of p to the nearest whole number? So many of you are going to get this wrong because you're just going to put 127 or 27, right? Because you're like, oh, I get this. 1.27, that's kind of like a percent, right? That's saying there's 127% of those zebras, right? So, okay, depending on how wrong you want to be, you're either going to say it's 127% or you're going to say that it's 27%, right? You're going to either ignore the 100 or just, try to understand like, oh, I see the trap. They want me to say 27, but it's not. No, both of those answers are wrong, right? So no. And the reason you're getting it wrong is you're thinking about percentages instead of using equations, right? So we want to use equations. This is a dangerous situation. We want to be thorough. So using that scratch, in many cases, it slows you down, but it's worth it. So first of all, I'm going to say, okay, I can turn this first sentence into just kind of an equation, right? So essentially, I don't love doing this, but I will do it. They're saying 2018 was 1.27 times the number in 2014. So they're essentially saying 2018 was or is 2014 times 1.27, right? So obviously this is not 2014 or 2018. This is years, not numbers, right? But this is me understanding this. So essentially I'm already kind of seeing something that kind of looks like a percentage, right? I'm seeing that if I'm doing the percentages, I usually want to use one of my open formulas. This kind of looks like that, right? I have a new value in 2018 and I have a original value in 2014. Now they're not talking about it as a percentage, but I'm following it as an instruction. So essentially I'm recognizing that it's a multiplication between these two values, which I don't know. But okay, let's move on, right? So I'm in that place where I don't want to be. One equation, two variables, I'm stuck, but there's more information. So maybe I'll get unstuck based on the other information. So let's see what else they give me. If the number of zebras in this population in 2014 is p% of the number of zebras in this population in 2018, what is the value of p, the nearest whole number? So now I'm talking open formulas. And if you've seen my lesson on the open formulas and percentages, you know there's two formulas, but we're going to use the one I've already written down. This is what I think of as the basic open formula. Notice that it looks like the word open. The reason I know to use that is they're not saying p% increase, p% decrease, p% more than, p% less than. They are saying p% of. P% of. That word of makes a big difference. It tells me to use this formula. So, okay, we don't know the p, right? So I'm going to kind of write in this open form, I'm going to use that p, but I'm going to make it a lowercase p, and we'll talk about why in a second, but notice that's what they did, right? So it's a lowercase p, but, or actually, no, we'll keep it a uppercase p. So I know they look the same, but it doesn't matter for now. The population in 2014 is p% of. Now the of is also doing something very important. It's telling me the formula, but it's also telling me the placement of things, right? So the of is always pointing me to the original value, the O. And that's odd here because if it's pointing me to the original, then 2018 is the original, right? Okay, so you're telling me 2018 times the P is going to give me 2014, right? So the O is the original and the N is the new. But I know how time works. 2014 comes before 2018. So what's going on? How is 2018 the original value and 2014 the new value? Time is moving backwards. It doesn't make any sense. Well, that's the trick. That's the trap. That's the reason people get it wrong, is that they start thinking about it in a very logical way when the SAT is deliberately doing something a little illogical, right? So that doesn't bother me because I am just a robot who is plugging points into equations. If you tell me this point goes in this spot, I'm putting it in that spot. I don't care if it makes sense or that you're asking for something normal. That doesn't interest me. What interests me is following the instructions that you gave me. So the other problem here is I now have this issue of I don't know what's going on. I got too many missing pieces here, right? I can't really compare these originals and news, right? Because I have two equations, one here, two here. But if I start swapping things in, I realize that I have three variables here. I have too many letters. So this is a good example where my instinct to arithmetize comes in, right? This question would have been so much easier if they just told me how many zebras there were. And I can do that, right? I can easily figure out that if there's 100 zebras in 2014, right, then 1.27 times that number is going to give me a very easy number for the number of zebras in 2018, 127, right? So I don't know there's 100 zebras, but it's certainly a nice number, and it doesn't really matter what number I pick, but that's an easy way to think about it, right? So now when I plug into this formula, my goal entirely was to solve for P. Now I can do that because I have values for the 2018 number and value for the 2014 number. So now when I've made up my own points to plug into this equation, I realize I have 127 times some value of P is going to give me 100. Right, again, the new and the original seem backwards from what our logic would tell us, but that doesn't bother me. I'm barely thinking about that. If I were doing the test, I'd be thinking, a lot of people are going to get this wrong. That's about it, but not me, right? So I'm going to solve for P, right? So let's do it here. 100 divided by 127 is this number, right? Okay, so let's write a bunch of things here. 0.7874, right? Now that's the value of P in my open formula. And what is that? That is the percentage as a decimal. This is the one thing about the open formula is that you got to kind of remember. It kind of annoys me, but it's just better this way. So you have to convert that back to a percentage, right? So you have to move that decimal point 2 spots. So that's 78.74%, right? Now the reason we have to do that is that that's how they talk about the percentage, right? They're not talking about it as a decimal. 0.78% is a very, 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 very small amount. We can tell that 100 and 127, they're not that different, right? That's not a very, very tiny portion. So there's something else going on here. And so we need to convert it back to a regular percentage. So if you just can remember to do that, these become very, very easy. And then just follow the final instruction is round it to the nearest whole number. And 78.74 rounds to 79. And that's the answer here. And notice we started with a trap answer of something like 27 or 127, right? Because that's flipping it. That's putting the percentage in the order that our logic would like it to go, right? Where we're thinking, okay, the original number of zebras happens in 2014 and the new number happens in 2018. But as I've been saying all along, that is not what they said in the question. That would be a totally logical thing to ask for, but it's not what they asked for. So with percentages in particular, they're going to do that, where they kind of flip the order of things to see if you're paying attention. I know this is number 21 out of 22 questions in the hard module. I know there's trouble. Plus, it's percentages. So I know trouble is coming. So I'm already aware of there's going to be something. So that's why sticking to plug points into equations keeps you focused on avoiding those traps. All right, last question then, number 22. And we've got a graph and we've got equations, and graphs are points. So already I'm thinking plug points into equations. So that's pretty good. Let's just see what it says. Circle A shown is defined by the equation x plus 2 squared plus y squared equals 9. So they're just telling me how to graph that. Circle B not shown is the result of shifting circle A down 6 units and increasing the radius so that the radius of circle B is 2 times the radius of circle A, which equation defines circle B. So, okay, 2 times. So, okay, I don't see a 2 times here, but I know from memory that x, the second part at the end is the radius, right? So if it was 9 and you're multiplying it by 2, I guess you got to square it. Or sorry, this is the radius squared. So the radius you can see here is 3. I'm misspeaking, but radius is 3. It shows up as a 9 because we're squaring it. So if I'm going to double it, I better double it. So that kind of tells me it's either going to be A or C. And then, okay, you're moving it down 6 units. So it should be minus 6. Now, notice what I didn't do there. I didn't plug points into equations. I thought about it. I thought about the logic, right? So maybe you want to do that too on the test, right? It took me a couple seconds to think it through and I got an answer. But if that's all you do, you are going to completely, again and again and again, fall short of an 800, a 750, 700 even. This is poor logic, right? This is not going to cut it. Your logic might be right in certain cases, but if your instinct is to trust that logic blindly, you will have a lot of problems. How should we actually prove this answer? Well, lucky for us, they gave us the original equation, x plus 2 squared plus y squared equals 9. So it turns out I'm not going to plug points in equations because I want to see the entire equation. Plugging points in is going to let me see one little piece at a time, but I don't want to see one little piece. I want to see the whole thing. I want to see how all this comes together, right? So that was what I started with. They gave me some instruction. My logic brought me to this answer. Now, not trusting my logic because I'm halfway through an SAT and my brain is mushy and I know this is the last question of the section, so it's got to be hard. They're putting it last for a reason. My instinct is, well, let's make sure I'm right. Well, looking at it, I see some things that are good, right? I mean, I could zoom out here, right? What do I see? Well, I see it got bigger, right? And so it's supposed to get bigger. Radius of B is 2 times the radius of A, right? So we saw the radius of A is 3. We can see that by touching the center and then touching the top or the bottom. You can see it's 3. Here, the center of the black one is also the edge, or we'll just the top. The edge of the red is negative 2, 12. You can't touch the center easily, but you can touch both the top and the bottom. And so we can see the difference is 12, so that's the diameter, meaning the radius is 6. Well, okay, the radius was 3. We multiplied it by 2. Seems good. But they also said we're shifting circle A down 6 units. This isn't down. I know directions. This is up. This is up, right? So there you go. This is wrong. This is the wrong answer. And so it's going to end up being A. We can test that just by noticing that what they did is they flipped it, right? Is it's a plus. And now, right, it's going down, right? The center is negative 2, 0 for the black one. And then we want to shift it down 6 units. So if you shift it down 6, it's just going to be negative 2 minus 6. And you can just graph the point. And I think when you graph it, you're like, oh yeah, that's obviously the center, right? And if you understand how the circle equation works, you can also see negative 2, negative 6 is the center based on the x and y parts. But why? Why did that not do what I expected it to do, right? And many of you get this wrong because you just trust yourself way too much. You think about it and you're like, oh, this is obvious. I know these rules. The thing is, this is also a translation question. This is a question about shifting things. So what we learn with translations in school is that if we have f of x, right, that's our kind of standard equation. If we do a plus or minus on the outside, right, so if we do f of x, this is supposed to be what, down 6, right? That's going to shift it down 6 if we keep it on the outside, right? Now, there's another thing where if we do the x minus 6 on the inside, that's going to shift it, but it's going to shift it left and right. And it's also counterintuitive, right? I would think that minusing 6 would move it to the left, would move it backwards into the negative numbers, but actually this is going to move it to the right. And that's the thing that you're taught to memorize, and you're like, oh yeah, okay, I get it, right? That if it's in the parentheses, it's backwards, it's kind of the opposite of what I would think. But this doesn't seem to be that situation, right? Up and down works in a very intuitive way. It works the way you would expect. If you minus, you go down. If you add, you go up. So why isn't that happening here? Well, this isn't a function, right? This, on my paper, I wrote f of x. This is not an f of x. This is a circle, right? It doesn't behave those ways. In fact, essentially, the y now behaves like the x in the f of x because it's in parentheses. I mean, it's in parentheses here for function notation, but it's essentially the same idea, is it's going to flip. So it's going to be a plus because it's the opposite of what it looks like, right? They want to go down, just like here. If we want to go right, we actually look like we're going left. You know what I mean? Like that's kind of the opposite of what you'd expect. Now the y is also doing the opposite of what you'd expect. But think about school. Think about when you learn this. How often were you doing this shifting with things like circles? Probably not very often. So the SAT knows that. They know that you've done this shifting a bunch of times with functions. They know that you've memorized certain rules that apply to functions, and they gave you something that's not a function to see, are you actually aware of what's happening, or are you just memorizing a certain line on a piece of paper that your teacher wrote down, right? That's essentially what they're doing. Now, if this were question number 2, or even number 12, it's probably going to be the case that whatever you memorized is accurate and is going to work in the same situation on the test, because essentially what they're doing is they're just testing your memory on an easier question like that. But this is number 22. The math modules, even the first one, are organized by difficulty. This is a hard question. I have the thing right here. I have my answer key right here. College Board says hard question, no doubt. And most people get this wrong because they don't internalize that it's a hard question, right? Or maybe another way to put it is they think that they're smarter than they are, right? And that's one of the biggest hurdles for getting a 750 or 800 or something like that, is people think that they are better at math than they actually are. And I've been teaching a long time, and that is a big weakness that some people never overcome. They're too arrogant to ever bother going to the calculator here. But it takes all of 30 seconds to type whatever you thought the answer was into the calculator and just verify that you're right. But some people are so confident in themselves, so confident in their knowledge. I'm so good at math. That's me. I'm the math guy. I'm in Mathletes. I'm good at A+ in all my AB calculus classes. You are so overconfident that you just don't even acknowledge the possibility that you could be wrong about something. And that is a weakness that is going to hurt you on the SAT and in life. You got to be able to recognize when trouble is coming and just do the bare minimum to see if you're right. This would take me no time at all to type this in the calculator. And whether I thought it was A or C to start wouldn't matter, right? Because once I've typed it in, I can verify, right? So whether you were right in your assumption doesn't matter on this question. Whether you typed in the calculator, that's the habit that's going to get you more points later on. So I don't care if you originally saw this coming and you realized what was happening and you picked A originally. If you didn't take 20 seconds to type this in the calculator and be right, you might have gotten this question right. You will get something else wrong for the same reason, your overconfidence and your arrogance. So I like ending the first math module by telling you that you're stupider than you think you are, but it's the truth. And that mentality is in my mind as I take the test. And I've been taking tests for 20 years. 20 years of SAT is a long time, but I still succeed because I know that I make mistakes. I know that my logic is often wrong, and I will do what it takes to verify that my hunches are correct. And so you've got to do the same thing. Good place. Let's take a break here, and then we'll do the hard module. All right, here we go. Time for the hard module. Normally you wouldn't get a break here, but because I turned on extra breaks, I'm getting one, but let's get right into it. I am losing my voice. I am still getting over a cold, so I'm sorry, guys. There might be a lot of pausing here while I cough off camera, but let's go for it. We're going to still think about plug points into equations as much as possible. We've got a story question. Let's see what we have here. A manager is responsible for ordering supplies for a shaved ice shop. The shop's inventory starts with 4,500 paper cups, and the manager estimates that 70 of these paper cups are used each day. Based on this estimate, in how many days will the supply of paper cups reach 1,700? So there are lots of ways to think about this, but I honestly think this is one of those cases where creating some sort of equation just ends up being more trouble than it's worth. It's like, just kind of do it in a more intuitive way, right? So you start with 4,500. Actually, I don't need the scratch. Let's just do Desmos here, right? We start with 4,500, and then we want to get down to 1,700. So we want to use 2,800 cups. Okay. And you're using 70 of them each day. So 2,800 divided by 70, 40 days, right? Now, if you were a little unsure, it's the first question in the hard module, but the hard module, yes, but the first question is still going to be very, very easy. So it doesn't surprise me that this is just going to work. One thing you can always do is just kind of reverse it, right? So if you are going to check your work, my advice is go the other way, right? So, okay, let's do 40 days at 70 per day is 2,800. And then that's the number used. And then the supply, you still have 1,700. So now let's add in 1,700. And guess how many we have? 4,500, the number that we started with, right? So we're kind of reversing the process a little bit and confirming that we're right. That also doesn't take very long. What many of you are going to do out of habit because of your teachers, this is number one, is you're going to try to make an equation. Now we could, and if you're thinking plug points and equations, I don't hate this, but essentially what we have is a line, right? We have a constant rate. So 70 each day, that's a constant rate. This is a case where we have a line. So you can essentially say, okay, this is a y equals mx plus b situation. Let's plug our points in. Well, we start with 4,500 cups, right? That's our inventory. We have a negative slope because we're losing 70 every day. So then 70 minus 70x. And then that would be our equation. And then the x is the number of days. Y is the number of cups that remain, right? So you would just do 1,700 equals negative 70x plus 4,500. And then again, out of habit, most of you, if you've gone this far with your algebra, you're going to solve just algebraically anyway. But you could also just let it do it in the calculator. Negative 70x plus 4,500. We got to do a lot of zooming, but there it is, 40, right? So that's fine. There are going to be situations where maybe that's called for, but I think I said this in the first module is don't feel like everything needs to be solved to make your math teacher proud. They are not there. Who cares? You got to get it right. And so many of these story questions end up just being like, put yourself in the situation. You wouldn't create an algebra equation if you were a manager responsible for ordering supplies. No office manager is doing algebra. They're doing this. They're doing arithmetic. So I don't know. Just think of it that way. I think your life will be easier. But anyway, that is the answer. Let's move on. Okay, so here we have some geometry. Now that seems like we can't use plug points in equations, but remember that's always in my mind. In triangle RST, the measure of angle R is 63 degrees. Which of the following could be the measure in degrees of angle S? Okay, so this is something that we can get from our reference chart. They tell us the number, here it is, the sum of the measures in degrees of the angles of a triangle is 180. So essentially we do have an equation here, right? In kind of Desmos terms, we could think of it as R plus S plus T, the three angles, equals 180. Now I wouldn't type this in Desmos, but we could, and you can see we can start to make some substitutions, right? We know R is 63. At this point, yeah, I'm going to do a little algebra maybe and just do 180 minus 63, but just to kind of show you, what it looks like. So 180 minus 63 is 117, meaning I have 117 degrees left to work with, right, between S and T. But notice 3 of these answers are greater than that. And so these would put us over the limit of degrees in a triangle, right? So 116, that's a big angle, right? And then you have a 116 degree angle and a 1 degree angle. That's a crazy looking triangle, very skinny, but you could do it, it's fine. So that's kind of what we're dealing with here. And I don't know, to me, that's obvious. But in a way, this is still plug points in equations. This is still thinking in terms of like, there's an equal sign and I'm plugging what in what I know. We're in that rare case where there are things we don't know, but notice how they ask the question, which of the following could be the measure in degrees? And so maybe this is a good opportunity to point this out. One thing that really kind of bothers people sometimes about some SAT questions, maybe a little bit like this one, is you're used to questions asking you which of the following is the measure, right? There's a definitive answer. The SAT likes to sometimes kind of create situations where there's multiple answers, right? Which of the following could be the measure, right? Which of the following is a possible answer or a possible value of X or whatever. And that throws people off because that introduces this idea of uncertainty and choice. Now, obviously, something about the question will kind of force a decision in some way, right? Here, we have multiple choices, so we're limited in that respect. But I think that's one of those things that feels unimportant, but actually sometimes really helps me solve a question because I might feel like I'm stuck in a certain place. I don't know the value of S. I don't know the value of T. How am I supposed to solve, right? But if you follow instructions and you're very careful about reading those instructions, sometimes words like could or possible can kind of change the way you think about the entire question and give you that freedom to be like, oh, well, maybe I can make up a number. Maybe I can test out different things. So that's something that's often overlooked, but is often, helpful for understanding a question. So there you go. Plug points in equations again. And look what I've got. I've got an equation. Technically it's an inequality, but I got that. It looks like I got some points. So let's see. For which of the following tables are all the values of X and their corresponding values of Y solutions to the given inequality? So some of you are going to do some Desmos stuff here. This is just a case where I'm just plugging in, right? So I look and I'm like, okay, well, 2 has some different values here. So if I put 2 in for X and, in for Y, I'm going to be able to compare. So this is when I would use my Scratch. I don't trust my memory here or my brain because I don't know. The inequalities sometimes get messy. So I will put in the 2, right? So I'm going to put 4 times 2. So 4 times 2 plus 8. So that's 8 plus 8 is 16. And 16 is less than whatever the Y is, right? So is 16 less than 19? Yes. Is 16 less than 8? No. Is 16 less than 13? No. Is 16 less than 13? No. So you might be wondering, like, why am I saying 16 less than 13? Isn't it kind of like the opposite, isn't it? Y greater than 16? Yes, but notice I'm trying to read it in a way that makes sense to me. And with inequalities, it's good to be comfortable flipping it. So if you wanted to, yeah, just go down the line here and plug each one in, right? So you've got 19 is greater than 16, right? 2 times 4 plus 8. And notice, I guess the other thing maybe I should say explicitly is I'm noticing that the 2 is there for all of them, right? The x values are the same. So it's only the y's that are really changing. So that's helpful because then if I plug in that x, I get a certain number that's kind of consistent, right? So in B, C, and D, I'm just dealing with the y changing. 8 is greater than 16. No, it's not. 13 is greater than 16. No, it's not. And what we say this one was? 13 again. 13 is greater than 16. No, it's not. So there you go. That's how to do it. So yeah, inequality, right? Plug points in equations is instruction. And, my advice is don't be so literal about the word equation, right? If it doesn't have an equal sign, technically it's not an equation. But if you can plug something into some letters, that's kind of where we are. Yeah. All right. Well, guess what I have? An equation and some sort of point. Now, the key is recognizing with function notation, right, that, that is a version of points. It is a version where some people often confuse X and Y, right? Because it's just the way it's written. You don't see a Y. And so they get kind of confused about that. But that's something you got to really knock down and kind of really figure out. It also helps here that they say for what value of X does f of X equal Y. So thinking in terms of plug points into equations, recognizing they're asking for X, it's very easy to come to the conclusion that this is actually the Y value. Now I would plug this in using Desmos. I don't want to deal with this fraction. So I recognize that Y is the 5. So that's the f of X part equals 9/7 X plus 8/7. And I get a value. And luckily it's not a decimal. So I was worried it'd be a decimal, but there you go. 3. And if you wanted to, right, you could, now test it out by doing the reverse, kind of like we did before. So 9/7 times 3 is some crazy number plus 8/7 is 5, the thing we were supposed to get. So there you go. That does not take very long and good way to verify it. But, we're still, we are in the hard module, but this is still easy stuff. And you want to be able to get this right confidently. And I think plug points and equations just keeps us on track. Cool. All right. Some sort of inequality thing. During a portion of a flight, a small airplane's cruising speed varied between 150 miles per hour and 170 miles per hour, which inequality best represents the situation where S is the cruising speed in miles per hour during this portion of the flight. So this is literally just turn this into some sort of equation, right? It's got to be this. Essentially, they're saying that S is between 150 and 170. That's literally what this is. Like very literally, like in the sense that the letter S is between the numbers 150 and 170, but also that's what it means, right? There's nothing weird here. They're not asking us to do any calculations. So B and C don't make sense because you're leaving out half the story. A doesn't make sense because why are we subtracting the two? It doesn't, no. Some people are going to worry about this and be like, well, it seems too easy. Well, one thing I'll say about this is a question where, we are still in the easy module. We are still in the easy section of the hard module. It's organized from easy to hard generally, and the first few questions in the hard module will still be easy. So some people panic when they get to the hard module because those first few questions are easy and they're like, oh no, I must have done badly. Oh no, this is so bad. My score is toast. I'm screwed. And they start spiraling in their head, kind of just forgetting that even in the hard module, the first few questions are gonna be easy. So, do them, right? There's a reason we start with the easy ones anyway, is we want to lock in these points really fast. So yeah, do that. But I don't know. That just seems, it just seems like people who want to worry are going to find ways to worry. Let's put it that way. All right, moving on. The graph models the number of active projects a company was working on X months after the end of November 2012, where S0 is less than X is less than 6. According to the model, what is the predicted number of active projects the company was working on at the end of November 2012? So this is just asking you to interpret a graph, but notice, right, 2012 isn't on the graph anywhere, right? So this is just understanding this very common way that the SAT and just math story questions in general talk about time, right? So when they say that this is what they were working on X months after the end of November 2012, right? 0 months after the end of November 2012 is November 2012, right? So when they ask for November 2012, they're asking for the y-intercept, right? And so the X is 0, but that's the number of months. And then the Y is going to be the other thing. So that's going to be 5. So this is also very, very easy. I'm surprised that we're actually still dealing with easy stuff this deep. We're getting to the point where I'd really like to see some harder questions, but it is what it is. So nothing weird here, but just understanding scale, I guess, and the way that things are worded. This isn't really plug points and equations. It's just kind of like, in the most basic sense, following instructions and doing what they want, and they're telling you what this means, and just go where they say. All right, cool. Now we got an equation. In the linear function h of 28 is 15 and h of 26 is 22, which equation defines h? So couple ways to do this. A lot of them are going to involve Desmos, but I am just going to be very literal, right? Do I have equations? Yeah, right here in the choices. Do I have points? Yeah, right here. So just pick a point in an equation, right? So this is something I'd probably do more on scratch paper, but honestly, I would just go down the line. So negative 2/7 times 28, right? Because that's my x, is going to be plus 23 is 15, right? So that works. This is me testing this first point in this first equation. Now I will pick it, but I'm not done, right? Like, this is a case where I'm actually going to change the way I normally think about things. So normally, when I do this kind of plugging points in, I treat it like an assembly line. I don't want to have to think about too many numbers. So what I would do is I would take this point, 2815, and I would plug it into each and every choice. And I'm pretty sure here that 2 choices will work. I forget exactly, but that's just knowing the SAT, that seems like what's likely to happen. And so I would go down the line, I would get rid of 2 answers, and I have 2 left, and then I'd try the second point in those other 2. But because these equations involve sevenths and things that I just don't really want to deal with mentally, or maybe even in a handheld calculator, because that's probably what I would have done, is a handheld calculator if I were doing this myself. I don't want to have to retype all this stuff in Desmos. But so rather than do what I normally do, which is just like do all 4 equations with the same point, since I've already basically typed the first equation, the easier thing is to just swap out the x, right? So if we change 28 to 26, then I'm supposed to get 22. But guess what happens? I get some crazy number. So notice I picked A because the first point worked. That is one of the classic SAT traps, right? Is they know that some people are going to be lazy, and as soon as they get something that works once, they're done. But we have to check both. And so either you check both like I'm doing now, kind of subsequent, like one after the other, or you check all the choices, you get 2 that work, and then you check the second point. I don't really care. I like the assembly line because it's easier to think about. But regardless, we've just proven this wrong, even though it was the first choice and it worked at first. So if you pick this, you're just lazy, right? So that's kind of, you can't ever do that. The SAT is so predictable. They will do this again and again. Now let's go to choice B. Negative 2/7 times 28 plus 113 is not 15, so done. So we don't even need to check the other point there. So negative, this is very annoying. So I'm typing past my microphone, and it's very hard to see the buttons. Negative 7/2 times 28 is some number. Plus 23 isn't going to cut it. Yeah, negative 75. And I'm making sure I'm typing this right as I go. I hope I am. But it looks like it's going to have to be choice D, so 113. So that works for the first point. Now you might be thinking, okay, duh, that has to be the answer. It's the only thing left. But maybe I mistyped something up here, right? Don't assume. It literally takes another 2 seconds to just switch that 8 to a 6 and be like, yeah, okay, perfect. Now I have proof, right? You want proof. The more proof you have, right, the fewer careless mistakes you're going to make. So always, yes, pacing is an important part of the test, and you want to think about how fast you're going and where can I shave off a couple of seconds. But like always, you want to think of like a cost benefit analysis. If some extra step is going to take me 3 seconds And that is going to guarantee 100% certainty that I've gotten the answer right. Take the 3 seconds. That's a huge win, right? The cost is minimal. The benefit is huge. So yeah, like that's always kind of how I'm thinking as I take the test is like, should I take another 3 seconds here or not? If it's 3 seconds and it helps for sure, like, yeah, if it's going to take another minute to prove the answer, no, probably I'll move on. But there we go. That's it. And we just did what we've always done. Plug points in equations. I see equations. I see maybe points. Let's see. The table shows the linear relationship between the number of cars C on a commuter train and the maximum number of passengers and crew P that the train can carry, which equation represents the linear relationship between C and P. This is an obvious plug points in equations, right? Now, look, these are not written in a way that you would kind of recognize as a classic equation, right? They're lines, they say linear, but it's not y equals mx plus b. Now, if your instinct is to manipulate this back into y equals mx plus b, God, there's something wrong with you. Don't do that. Just do the equations, right? So again, this is something I'd probably just reach for my handheld calculator and do because it's just a little easier. But let's do it this way. Let's do C equals 3 and P equals 174. And we'll do a little slidery Desmos here. And then 55C minus P should be -9. It is, right? So that looks good. So am I picking that? Maybe temporarily, but I know it could be wrong. But at least 55C minus P doesn't equal 9, so I can get rid of that. And then let's try 55P minus C. All right, that's choice C. And that's 9,567, so that doesn't work. And then it's not 9 either. So this is it. We're done. So this time, it turned out that the first thing that worked actually worked and was all I had to do. And I don't need to, the other choices were wrong with the first point. I don't need to try a second point. But I'm not aware of that when I'm doing it, right? I'm always going to check everything just to be sure. But there you go. Now, if I wanted to check the other point, right, this would just be 5, 284, 284, and it's still -9, right? So at this point, you're done. But yeah, this is so easy, right? If you're doing algebra and manipulating this equation into y equals mx plus b or something like that, or doing some sort of regression, like, come on, guys, this is so easy. This is so easy to just plug in. Like, the benefit of plug points in equations is it just kind of gets you to the point sometimes really fast. So yeah, this is a joke. Let's look at the next one. Okay, so this is a question where I've got 2 immediate thoughts, and I don't really care which one you end up doing. I will show you both, but the 2 things that come to mind are, well, I have equations, right? I have 1, and I have points, right? They're asking for the solution, but they've only given me 4 options. So I can just guess and check. I can just test these out, right? This is a good example of just like put them in and see what happens, right? So I can do that. I will show you how to do that. But probably on the test, if I'm being honest, my first thought is kind of going back to our list here. I have 1 equation with 1 variable, right? It's 1 equation. The only variable here is a w. So that's a case where I can solve for x using the Desmos vertical line method. So I will do that first, just to kind of show you. Now, again, Desmos speaks the language of x and y, right? It's an xy plane. So I can't use w. I'm going to do x squared plus 12x minus 40. And I will put the equal 0. There are ways to do it without that. But you can see I get these points, right? So they're messy numbers, but so are all these choices, right? So I would just be like, okay, let's just see if I can get these numbers, right? So 6 minus 2 square root 19 is some messy number, -2.7. That's not quite this, right? This is -14. So this is a positive 2.7, but you can see maybe if I had done algebra and I lost that negative, then this would be a really good looking choice, but it doesn't work. I can see I typed this right? So I'm checking that. And I typed this right, and it's close, but positive and negative are different numbers. So no. And then 2 radical 19 is 8 point something. So again, I don't see that here. So that doesn't work. Radical 19 is 4 point something. Again, it's not there. So no. And then this one is -6 plus 2 radical 19 is 2.7, 2.7. Right, so there you go. And you can tell Desmos is rounding it on the graph because it can only go so far. So it's rounding it slightly, but you can see where that's coming from. So that would probably be how I do it on the test, mostly because it's, to me, very like, all right, I'm just matching numbers. It's pretty straightforward. I will show you the other Desmos way to do this, which is just type it as it is, w squared plus 12w minus 40. leave off the 0 because that's what's going to equal. And then we're going to see if we can get it to equal that, because when we use the slider with W, you can change it, right? So you can move it around and get different values for that thing, and we want it to be 0. But I'm not going to move it around. I'm just going to test out what I've got, right? So just for the sake of time, we'll just do C and D. But C, right, square root of 19, right? I can see if it's taking that W and now it's putting it into this top equation for me, and it's giving me some number that I don't recognize, right? I need it to be 0. So that doesn't work. So, okay, if I did the same thing now for choice D, the correct answer, -6 plus 2 square root 19. Ooh, interesting. I wasn't expecting that. So it's actually technically not giving me 0 because it's there's some rounding issues here. Huh, interesting. I wasn't expecting that. But this is a good example of, yes, Desmos is amazing, but you have to understand what it's telling you. You have to speak its language in order to get the most out of it. And I think what happens is a lot of people like using Desmos, but they only speak English. They don't talk to Desmos the way, Desmos needs to be talked to. So what's happening here is they're going to see this and they're going to panic. But if you understand the math here, 1.4 times 10 to the minus 14th is a very, 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 very small number. 0.00000 a bunch of times, 142, right? It's so minuscule that it is effectively 0. Why isn't it exactly 0? Because of something going on with Desmos and the way it's treating this radical and rounding that number. It's then causing some sort of rounding issue that is creating a false number here, basically, right? It is 0. But because of the rounding, the 0 isn't popping up in the answer. So knowing how Desmos works, I'd be like, oh, yeah, this is it. This is clearly the answer. All the others would give me crazy other numbers. So I'd just be like, yeah, this is definitely it. But I could see how this would panic someone. And so this is why if you have decided that Desmos is your main way of solving things, you also need to understand math. You need to understand what math looks like and how it reads and all that, because otherwise this will seem like a wrong answer to you. But if you understand what scientific notation tells us, you'd be like, oh, I see what's happening. This is a 0. Desmos is doing something with the rounding. And this is just like a very, very precise rounded answer where it just doesn't know how to understand that the actual answer would be 0. So, Desmos is great, but sometimes it's going to talk to you in a way that's a little unusual. And so you got to get comfortable with it. But for me, I don't know. Like I said, I would have gone to the lines first and just compared decimals that way. Cool. Okay, so this is easy, right? What is the y-coordinate of the y-intercept of the graph of 3x over 7 equals whatever in the xy plane? So most of you are just going to do this. You're just going to go to Desmos. You're just going to do, okay, I can find y-intercepts easy. Desmos is good at that. 3x over 7 equals, and just make sure you type it right. The number of people who forget that negative in front of that is going to be pretty high. There we go. 37.8. 37.8. Yeah. Let's double check. Yeah, that is the answer. So that's fine. I have no problem with you doing it that way. That's very intuitive. And notice what it allows us to do, right? Desmos is amazing because unlike other graphing calculators, the handheld ones, you can graph anything. It doesn't need to be in a function form, right? And in order to graph most things in a graphing calculator, at least the ones that I used growing up, you had everything had to be in y equals format, right? So we would have to rearrange this equation first before we could even put it in a calculator. Desmos doesn't care. It'll do it for you. If you had to rearrange it to y equals mx plus b, at that point, you wouldn't need to put it in a calculator because the b in y equals mx plus b is the y-intercept. So there you go. Now, I see this question slightly differently because I think about points and equations, right? So I see it as I have an equation, and when you tell me about the y-intercept, you're telling me a point, right? You're giving me a point, or at least you're giving me half a point, but it's the best half to have, right? So this is a case, I'll just show you on the graph paper, on the scratch paper, number 10, where you're telling me I have the y-intercept. So I have 0, and we'll use b just for the sake of consistency. I don't know the y-coordinate. That's what you're asking for, but I know the x-coordinate. And plugging that in is really easy because if I do that, right, if I plug in 0 here, this whole side of the equation just disappears because 3 times 0 is 0. 0 divided by 7 is 0. So I get 0 equals negative 5y over 9 plus 21. Now, I'd still have to do a little math, right? I'd subtract 21 from both sides. At this point, I could also go to Desmos, but negative 21 is equal to negative 5y over 9. So we'll get rid of the negatives, right? Then multiply by 9/5, multiply by 9/5. And then this is maybe where I'd hit a calculator. 9/5 times 21, 37.8. Now that is also it's a little algebra, but it's very simple, very simple. So I don't necessarily say that that's the way to do it. But I would say that if you are really good at the strategy of plug points and equations, and you're really thinking about it right, then that would have at least come to mind as soon as you saw this question. You would have said, okay, they gave me an equation, they gave me a point, right? Look at my trainer here. It says x and y intercepts are points. It doesn't need to look like a point. They don't need to give you the coordinate. If it's an intercept, you know that one of the coordinates is 0 by definition. So that's something that's really important for some of the harder questions. Sometimes they will tell you something as an intercept, and your job is to recognize you've got a 0. And so thinking and recognizing that anytime they bring up intercepts, you have a point, even if they don't phrase it that way. That's very, very important. That's, again, kind of me nagging you about plug points and equations and being able to recognize all the different ways that they can give you equations and give you points. So whatever you did here, it's probably better than most of you are probably not rearranging this into y equals mx plus b form. So I would hope you're not. That would be the worst way to do it. Everything else, probably fair game. Moving on. Right. So this is a good example of I have a system, right? I have equations. I can plug points in. I could easily plug in 8, 0 into all of these, but I could also just let Desmos tell me, right? This is picture matching, right? I have here a picture. These would each produce a picture, and here you go. Let's just see if we get the same picture. So I can't see through my microphone. 8x plus 4y equals 32. I don't love that already, but let's zoom. Yeah, I already don't love that, right? So I'm not getting an 8. So I already know that this is wrong. So 8x minus 4y. Nope, wrong way. Okay, well, that got rid of 2 answers pretty quick. 4x minus 10y equals 32. Well, I get the 8, but I'm going the wrong way. So 4x plus 10y equals 32, right? So I get an 8 and I get a 3.2. That feels about right. Now, shouldn't I just pick D? Isn't that the only one that could work? Why not just type it? Again, 3 seconds. It's cost benefit, guys. This will take you 2 seconds, 3 seconds. We get the 8. We get 6.4, which looks right. Everything looks good. Now we have proof, right? Took another 5 seconds. Whatever. Worth it for sure. You might have mistyped here, right? There's a lot of things that are very similar between these choices. You get a plus or a minus, you put it in the wrong place, boom, you get a graph that looks wrong, but might actually be right because you just typed it wrong. So it can't hurt to just be absolutely sure. This is a good example too of, especially if you're someone who overuses Desmos, right? You saw some TikTok or something and you were like, oh my God, this guy is saying I can solve everything on the SAT with Desmos. I'm just going to do that, right? So some people get addicted to Desmos and it becomes their main way of solving things. To be clear, that is how you should solve this question. This is a Desmos question. But I would say the thing that makes me confident that that's the best way to do it is I'm not just going to Desmos. I'm not just opening Desmos out of habit. I'm not just opening it to see what happens. I think the best way to tell whether you're using Desmos as a tool or whether you're addicted to it is when you want to use Desmos, do you have a plan? I'm opening Desmos because, right? I knew as soon as I was opening Desmos for this question, what the plan would look like. I'm going to graph each of these things. I'm going to make sure the line matches the line that they gave me, right? I knew what Desmos was going to tell me. Maybe that's another way to say it, especially before we were talking about the language of Desmos, right? I know that I can have a conversation, so to speak, with Desmos, and together we will come to an answer. I'm not kind of like just throwing stuff at Desmos and helping it tells me the answer, right? I think that maybe that's the difference is I know that it's a conversation. I know what I'm putting in. I know what I'm getting out. It's back and forth. And so the more you can kind of think of, Desmos as something to use in certain situations, the more likely you will use Desmos effectively. It's when people just open it all the time and it's like, oh, let me just type this in Desmos. Let's see what happens. Like sometimes that's better than nothing, right? If you got no other plan, fine. But I think there's a difference between that kind of situation and what we did here, where we opened it and had a plan. So just, something to keep in mind. And so Desmos is down here. I don't ignore it, right? Solve for X, we've been doing that. Solve systems, we're kind of doing that here. Graph equations, we're definitely doing that here. So, these are alternatives, but notice there's a purpose involved. All right, moving on. All right, points and equations. I see equations. The solution to the given system of equations is xy. What is the value of 6x minus 2? So this is that situation we keep coming upon, right? So I have two equations, two variables, right? Two equations, 1, 2, two variables in each, x, y, right? So this is a situation where I'm definitely going to Desmos. Graph to solve for xy. I keep thinking I'm on the same page. Solve systems using Desmos, right? This is a system. Now, I know that there are shorter cuts to do here, but why bother? Let Desmos do it. This is a good example of I know what I'm putting in. I know what I'm going to get out. Y plus 7 equals 117. X minus 2 plus 4. Y minus plus 7 equals 442. Now, before I start scrolling around looking for my answer, the first thing I'm going to do, again, because I've trained myself and I have a good habit, is I'm going to make sure I typed it right. X minus 2 minus 4 times y plus 7 equals 117, and x minus 2 plus 4 times y plus 7 equals 442. So yes, everything's right, because if I type it wrong, I'm obviously going to get the wrong answer. Now I'm looking for that point of intersection. I kind of see it. There it is. Now, what do they want? What is the value of 6 times x minus 2, right? So I don't care about the y coordinate. I care about that x coordinate, right? So it's 281.5. So 6 times 281.5 minus 2 is 1677. Great, done. That is the answer. And there kind of are certain ways to get this that are maybe some might say faster, right? So I would not do anything else here. But if this were me on the test, I'd probably bookmark this and I'd be like, I recognize what I'm supposed to do, right? They want me to eliminate the y plus 7 thing because I see x minus 2 here, I see it here, right? There's a lot of things that kind of work out nicely. So I might say mark for review, not because I'm unsure of this answer, but because I'm like, if I have any time left over, I'm going to come back and I'm going to do this the algebra way. I'm going to just do what they want me to do, just to see that I'm right. Maybe I typed something wrong in Desmos, it can't hurt, but I'm pretty confident I got it right. What they want you to do is essentially, if you were to go down the line here and add these equations together, right? If you added these together, these would cross out, right? Negative 4 y plus 7 plus 4 y plus 7 is 0. So these go away. So that's actually very convenient because then it leaves us with 2 times x minus 2, right? Because those add 1 x minus 2 plus another x minus 2 is 2 of them. And then these other numbers add. So 117 and 442 is 559. And then how do we get from this to this? Well, you could solve for x like we kind of did with the graph, but that kind of defeats the purpose. You should see in order to, we have 6 of these x minus 2s. Here we've only got 2 of them. So we multiply by 3. That gives us 6 times x minus 2. And then if you do it to one side, you got to do it to the other. And just since I've already come this far, 559 times 3 is 1677. So there you go. Same answer. Again, I wouldn't be doing that right now if it were the test. I would be continuing on because you might run out of time on the hard math module. I don't want to have to solve everything twice. If it's going to take me 3 seconds to do the second solution, fine, I'll take the 3 seconds. This is more like another minute, maybe another 30 seconds if I'm really fast at algebra. But I would say it's a good example of let's make sure we've got the time for that before we commit to that. Let's trust the calculator. But I would definitely have done the calculator first, right? Why bother even taking the chance of thinking about the algebra wrong, essentially. Cool. Moving on. What is the minimum value of the given function? This is Desmos, right? This is a quadratic. It is written in standard form. When you talk about minimum, you're talking about vertex. So I don't know what the College Board explanation would say here, but I would bet it says something like, complete the square to put this in vertex form or something like that. No, that's dumb. Why take the risk? Don't do algebra. The whole point is avoid algebra, right? So we have x, I don't even need to type the f of x. So x squared minus 48x plus 2304. Okay. Zooming, right? 2304, big number. So we got to find it. Why does this happen? Sometimes it just disappears. There it is. Okay. All right. And the minimum is the vertex, which you're always going to be able to tap. Now, one of the most common mistakes with this exact question is people don't read the question, right? They're asking for a single value. And obviously a vertex is two values. It is an x coordinate and a y coordinate. So your task is to provide them with whatever they want. They're not saying for what value of x does the minimum value of f of x occur. They want the minimum value. They want the y. Whenever we talk about x's, whenever we talk about maximums and minimums on a graph or on a function, we're talking about the y, right? It's up and down. In school, you might have learned about the domain and the range. The domain is the x limits, right? How far does it go? How backwards does it go? Those kinds of things. That doesn't really come up on the SAT. I don't think I've ever seen the word domain on an SAT and a math question. So I just don't think it's going to happen. But range is an important concept, right? So maximums and minimums, vertex obviously is kind of pertaining to that. So your task is, if you're asked about maximum and minimums, it's to think about the y maximum and the minimum. But sometimes they might ask for the x coordinate of that minimum, right? So you do have to be careful. So if you put 24 here, you just misread, right? They're asking for the minimum itself. So it's 1728, which I know is a bigger number than 24, but that's what they wanted. So that's the way to do it. I would 100% go to Desmos here. There is a way to do it using here, axis of symmetry. That's another formula you should know. It might come up in harder parabola questions, but if we have a parabola in standard form, we can do this number 13. The axis of symmetry formula is going to give us the h coordinate, right? So if we think of vertex as h comma k, the h coordinate is negative b over 2a. So the b here is negative 48, so that's negative 48. But right now we've already got a double negative. That's an opportunity to mess up. So that's positive 48. And then a is 1 because that's in front of the x squared. So that's over 2 times 1. So guess what we get? We get 24. But again, that's not the answer, right? Because that is where the minimum happens. The axis of symmetry formula is going to tell you where the minimum is. In order to then make use of this, we would need to plug that in for x, plug points into equations, and then solve for f of x, for the y. So you'd still have that other step. But I think that this is making you more likely to put 24 because you feel like there's like a mission accomplished moment, right? You have this kind of x equals, h equals, and you're kind of like, oh, that's it, I'm done. But no, we want the k value of the vertex, the y value. So, as always, I think algebra is more prone to mistakes for all sorts of reasons. And here I can just see it with my eyes. Make sure you type it right, but otherwise, piece of cake. All right, next one. Okay, we saw one of these in the first module. How many solutions does the given equation have? Now, the big difference between the first module version and this version is these are lines, right? So I think about these there's a routine here. It's not really my plug points into equations because I'm not really interested in the solutions, right? I don't care what the solutions are. In fact, there might not be any, or there might be infinitely many, right? So I don't know, but I just want to know the number. So if I have lines, and I know these are lines because there's no x squared, I'm essentially going to split these sides up and create two y equals mx plus b equations. So y equals negative 49x, y equals negative 98x, and I'm going to get them in a y equals mx plus b form. So they're basically there already. If I really wanted to, I could add a plus 0 to kind of get the b going, but it doesn't really matter because I don't actually care about the b. I care about the slope, right? So the reason I'm doing this, even though you can visually kind of see it, is essentially I know I've memorized rules, and the rules that I've memorized are that if we have the same slope, and in this case the same y-intercept, then we would have infinitely many solutions because they would be the same line. Now, here we have different slopes. And it actually doesn't matter about the y-intercept. If we have different slopes, then we have one solution. That is always true, right? If we had the same slope, but, oh my God, my handwriting is terrible on this pad, but different y-intercepts, that's lines that are parallel, so they're going to have 0 solutions. 0. So those are the only 3 things that can happen. You're never going to have 2 solutions with lines. Can't happen. You can have 2 solutions with a parabola, but never lines. So these are really the only 3 options. And, I just see, okay, well, I have different slopes, right? If I split them up, so different slopes is one solution. So that's how I would do that. I would not use Desmos here. Now you could. You're going to get some things that I don't really like though, because if I just typed it as is, I get that vertical line, which makes sense because it's an equation with only one variable. So it's solving that for me, and it's telling me 0. So how many of you picked A because you saw that 0 and you were like, oh, there you go. Well, the question wasn't what is the solution. This line here is telling us that the solution is 0. And that is true. You can see if I plug 0 in for x, 0 equals 0 would come up here, right? So that's a solution that works. So the solution is 0, but 0 is one solution. So they're asking for the number. But I think if you plug it into Desmos, you're more likely to pick A because you see a 0, you see the word 0, you kind of lose track of what you're asked about, and you maybe don't even understand what Desmos is telling. Again, we are talking about, do you speak the language of Desmos? Do you understand what it's telling you? Are you having a conversation, or is it just kind of it's spitting something out and you don't speak that language, so you're just kind of misinterpreting what it's telling you? I think that's likely here. In fact, I think they probably wrote this question knowing that would happen. But for me, I have a bit of a process. Number of solutions is one of those topics that has very kind of set rules and things to memorize. And if you just kind of go by those rules, it's very hard to mess it up. So here, even though it's very obvious how this equation works, splitting it up into y equals mx plus b and having 2 equations and comparing slopes just kind of definitively gives me the answer without running the risk of a mistake. So I recommend that. Cool. Okay, I think I should add that to this alternatives because it's technically not like a plug points into equations in many cases. A little bit maybe. I don't know. I don't know what that is. It's out of its own little world. But here I see an equation and I see a point, right? So here's the equation, obviously. This is a point. The value of g of 7 minus w is 0, right? How do I find points? Function notation is a way to present points. Now, it's annoying that the point has a w in it, but that doesn't bother me too much. So let's see here. I would probably on my scratch, let's go back to black here, would say, okay, let's at least just keep track of what we got, right? So 7 minus w is the x coordinate of this point, right? The y is the 0. Okay. Now maybe there's a way to use Desmos and plug this in and get the w's. But this might be one where I'm like, I don't know. I'm starting to maybe get to one of those places where I'm going to Desmos to see what happens instead of having a set plan, right? Or maybe I don't know what Desmos is gonna, if we're gonna be able to have a conversation or we're gonna speak the same language on this question. But I speak the language of plug points into equations very well, right? I understand what that means. So I'm just gonna do that, right? So the y is 0. That goes in for the g of x part. So that's the left side. And then I just gotta be careful with my parentheses, but that first x can be replaced with this x, 7 minus w. And then we can do that again for here. And I don't need another second set of parentheses because there's nothing in front here. So minus 2. And then same thing here. So we get 7 minus w plus 6 squared. So now asking for the sum of all the possible values of w. Well, I could start to solve, but one thing I really like here, I notice, is that 0 is really convenient when you have equations with these factors, these kind of parentheses terms, because I don't need to do anything. The reason we factor is because if it's set to equal to 0, we can just find all the values, right? So with this one, it's really easy. I know that w is 7 because 7 minus 7 is 0. And 0 times anything, no matter what's going on over here, is going to be 0. So this is the power of the number 0 and understanding why that number is so great, and especially in a case like this. Now for these other ones, I got to clean it up a bit, right? So let's clean this up. So this is going to be 7 minus 2, which is 5 minus w. So w is 5. And this one is going to be 7 plus 6. That's 13 minus w squared. But the square doesn't matter, right? Because if w is 13, well, then 0 squared is still 0. So the 0 doesn't affect anything, right? So what are all the possible values of w? Well, we have 7, 5, and 13. 7 plus 5 is 12. 12 plus 13 is 25. Done. Now, some of you are going to be like, wait a minute. The square does matter, right? The square is telling me there's 2 13s, right? This had happening twice. This is a great example of you answering a question that you're not being asked because you've been asked a similar question in school. In school, you might have been asked, what is the maximum number of x-intercepts that this graph could have? And because it has an even exponent, right? 1, 1, and 2, right? So 4, you could have a maximum of 4 possible x-intercepts, 4 possible solutions. However, that's a maximum. That's not what it always is going to be. Sometimes they double up. In this case, they doubled up. So here they're saying, what is the sum of all possible values of w? Well, 5, 7, and 13 are possible values of w. If you say w is 13 again, what have you added? You haven't added a new value. 13 and 13 are the same value. You still have 3 different values, right? So some of you are going to argue with me. I have the video of me going over this question as an individual. I'm pretty sure has like several comments of people like telling me I'm wrong. No, 13 and 13 are the same number. Like, no, come on. And this is a great example, I think, of what I've said in a couple other questions so far in this test of like, you guys do some math in school that, your teacher will give you a homework assignment that's like 20 or 30 of the same kind of question, and you'll have a test and a quiz and all this stuff on the same kind of question. So much of school math ends up being, here is a type of question that I want you to memorize the 5 steps to do to solve it. And if you do those steps, you will get this answer, and that'll be your answer. And so there's no creativity there. There's no thought other than just like memorizing things. Then people who do that very well come to the SAT and they're surprised by how much creative thought you need to solve math questions. So many of people who are arguing with me here are doing so because you're not solving the question you're being asked. You're not paying attention to what they're asking. You have internalized something that your teacher asked you 100 times, and you're like, no, that is the only thing that could be asked. But no, this is just a different way to word things. If they had said, what is the maximum number of possible solutions you could have, the answer would be 4. But that's not what they're asking. So don't answer your memory of a question you've seen in school, on a past SAT, whatever. You're not answering a ghost of a former question. You are answering the question in front of you, and being careful about what they're asking is very important on the SAT. To show you more how this could have worked, right? If we had plug points into equations, right? We could have said g of x is equal to x times x minus 2 times x plus 6 squared. And we get the wacky looking thing. And we see the zeros, right? So there's 1 there, 1 there, 1 there. I think one weird thing that's going to happen, though, I think this gets it wrong. So these are the solutions of g of x, but we're shifting g of x. So some of you are going to think, oh, I got to move it 7 and might move it the wrong way. What we could do is g of 7 minus w equals 0. And it's going to be like, what the heck does this mean? I don't know. But if we kind of play with it and we're like, you know what? We want to get those vertical lines. I can't give it w. I have to talk to it in its language, which is x. Right? If I give it an x here, it's going to tell me all the possible values of x, and then I can add them up, right? I have to see where they're equal to 0. And so you can see it's shifted the thing. But if I put equals 0, yeah, I get lines, right? So this is me taking this point, and the only thing I'm changing is making the w and x that it can graph the lines. But you can see there's a problem here. That's as big as it gets. Okay, there's a problem here. I can't really show you. This is so stupid. I'll just keep it this way, right? We can see the black one has 3 solutions, which we expected. Now the red one is supposed to also show 3 solutions. Where is it? I see 2, right? I see the 5 that we got. I see the 7 that we got. I don't see the 13. Where is it? Well, Desmos is finicky sometimes. It's doing calculations on the back end that are not quite the same as the calculations we would do. And so it's doing calculus, essentially, I believe, and kind of like limits. And so sometimes things happen that are kind of weird in Desmos. And so essentially what's happening is the graph understands that, in this case, at -6, or for us would have been at 13, this thing is kind of popping down and just glancing off the x-axis. And so for whatever reason on the back end, the calculation doesn't see that. It doesn't understand it. Something is happening. I don't know what, to be honest, but something's happening where it's not registering that point, right? Because it's kind of getting to 0, but not going through it like these other ones are, right? They're going through. So this is something I've actually seen people get wrong. They do it this way in Desmos. They get kind of these red lines. They get 2 of them, at 5 and 7, and they add it together and they get 12 as an answer here. So I don't know what to do with that. There are probably other ways of using Desmos and doing some of those complicated regressions to get this. But this would be a case where I think, the normal manual plug points and equations is so easy. I would just do that. I'm not doing it here because I know the Desmos fails. I'm doing it here because, to me, that's so easy. And again, I going to Desmos, I'm kind of confused about what I want it to do for me. And so that's the red flag that's like, you know what, maybe let's just write this on our scratch. And I think that you should kind of think of it the same way. Unless you've got a really clear sense of what Desmos is going to do for you, don't go to it. There's doing things on the paper is sometimes better. And here it gets us the right answer pretty easily. I think if you get Desmos, there's a chance it goes wrong. And so I don't know. It's a great solution in certain cases, but when things get more complex, equations with x to the 4th, essentially, more of a chance things go wrong. So word to the wise there. But yeah, plug points and equations saves the day yet again. Okay. All right. Now, we haven't talked about pacing because this is a module where we will, encounter some problems. Normally, my strategy for pacing in math in the hard module and even in the first module is question 15 is usually where things start to change. And I think that we've got a little bit of a shift here. This is an easy question if we think about strategies, but it's hard in kind of like the kind of more raw sense of it for the SAT. So I think when you get to number 15, regardless of how much time you have left on the clock, you have to start thinking about pacing better. You have to think, okay, this question might take me a long time, or I don't have a quick kind of solution to it, or I can't go to Desmos, I can't plug points and equations, whatever it may be. If there's anything within 5 seconds that kind of alerts you to potential danger, you need to move on. You hopefully will have time to come back anyway. It's not like we're saying when we start skipping around that we're giving up permanently on certain questions. What we are merely doing is saying that for the remaining questions, 15 to 22, I didn't even put an answer in here, 15 to 22, we are going to do them in the order that best suits us. That is going to get the easiest questions done first. It's very similar to our strategy for the passages in reading. We're not doing them in the order presented. That is a trap, right? We are going to do them in the order that best suits us, that maximizes our chance of a good score. The more questions we get right, the better. Now, if you do them in order, you might hit a wall. You might get a question that's going to just take a very long time and drain that clock. And so you don't want to be thinking about which questions to skip only when your clock is almost out of time. You want to be thinking about which questions to skip as soon as you get to the place where things could mess up your clock, right? That's the point. So 15, I would have absolutely done, right? This was what we say the answer was, 25. This is a question where I'm like, oh, this is an obvious plug points and equation. So I'm very happy with that. This is one I'd be doing for sure. Now getting to 16, it's a probability question, right? I can see it from, selected at random, probability, right? That's a topic that can be very difficult, especially where we would expect difficult questions to be, like number 16. Plus, look at all these numbers, right? There's a lot of reading. This seems like there's a lot of information. So normally this would be one that I would skip and say like, this is probably a time suck. This is something that I might get right, but it might take me 4 minutes to do it. And that might be enough time to get 2 other questions right, 2 other hard ones. And 2 is better than 1. So you got to make that choice. This question right here is actually a big reason a lot of people struggle with this particular test is they get locked into this and it takes them 4 or 5 minutes and they maybe don't even get an answer. And then now they're rushing. They're rushing through things that are going to be actually easier. And so you've got to keep in mind, don't just start skipping when you run out of time or you're running out of time. Start skipping where we know the clock starts to matter, which is really question 15 and on. So there you go. So let's do this though. We're going to keep it in order for the sake of, just the coherence of the video here. Okay. And this is definitely a place where we're going to use our scratch paper. So let's see what it says first. A grove has 6 rows of birch trees and 5 rows of maple trees. Each row of birch trees has 8 trees 20 feet or taller and 6 trees shorter than 20 feet. Each row of maple trees has 9 trees 20 feet or taller and 7 trees shorter than 20 feet. A tree from one of these rows will be selected at random. What is the probability of selecting a maple tree given that the tree is 20 feet or taller? To be clear, since I'm telling you literally every thought that goes through my head for these questions, I would have read it like that. I'm not absorbing this information. I'm not writing this information down. I got to get a better sense of what they want. So I know a couple things. I know it's probability, and I know it's conditional probability, which is something I have a lesson on. My probability lesson goes into conditional probability. You should definitely watch that. It is a very common way of creating kind of a deceptively hard question. It feels easy, but it's hard. This one obviously feels hard too, but it's a good topic to know. Now, I know it's conditional probability because of this phrase, given that. That is a way of limiting what we're talking about. Now, this does not look like a typical conditional probability question, but because I know what a typical conditional probability question sounds like, it's hard to say this, I know that I do need a chart, right? This is how these usually work, is I get some sort of chart. So I'm gonna kind of build one, right? So now I've got a plan here, is if I am gonna do this, we've got different situations, right? We've got birch trees and maple trees. Birch trees, maple trees, okay. And each type of tree has 2 different sizes, right? So we have birch trees that are 20 feet or taller, so 20 plus, and then others that are shorter than 20 feet. So we'll kind of do a 20 minus here. Just shorthand, right? Just as long as you know what you mean, whatever, doesn't matter. Okay, so now let's start to put information on this thing, right? So 6 rows of birch trees, that I don't really know where to put that, right? Because the thing that I want to put on here is each row of birch trees has 8 trees 20 feet or taller and 6 trees shorter than 20 feet, right? That I know kind of goes there. Each row of maple trees has 9 trees 20 feet or taller and 7 trees shorter than that. So where do I put the 6 and the 5? Well, I'm just going to kind of put it off to the side, right? Because it's kind of like multiplying, right? If there's one row that has 8 that are 20 feet or taller, then there's 6 rows total. That means there's 48 of this particular type of tree. So I think of it kind of like, I'm probably going to multiply it. And this right here is kind of the weird thing. This is what I often call a twist. It's taking a very typical type of question, one where the SAT gets very repetitive in what they ask, and adding a little extra something, right? And that's really, to me, what makes a question hard, is we can study forever. We can kind of get the sense of the patterns of how certain types of questions work and kind of memorize the steps for solving them. But the SAT is so good at coming up with situations where they throw that little extra twist in that you would have never seen before. Even if you'd studied for 20 years like I have for the SAT, this was the first time I'd ever seen a question quite like this one. So you have to be prepared for those twists, but it helps if you understand the basics, the basic chart that I'm making here. So that way you're like, okay, this is still my anchor. This is still the thing that kind of this question is about, but now I have to account for this other weird piece. So I'm still going to think of it in terms of like the conditional probability, right? So what is the probability of selecting a maple tree given that the tree is 20 feet or taller? So this part here is not a twist. Well, I shouldn't quite say that. It is a predictable twist. It is one that I have seen many, many times. It is what makes conditional probability a little harder, is they're limiting us. So they're telling us we're not selecting from all these trees. We're not selecting from the whole chart. We are selecting from this row, or column rather, right? Given that the tree is 20 feet or taller. So we are only interested in the big trees. Yeah, I filled in the chart with the little ones. They don't matter. Now, my general way of approaching a probability question is I make a fraction, because I have the top, which is the number that I'm choosing, the thing that I want, and the bottom, which is all the things I'm choosing from. Now, the bottom is the number they tend to mess with, and it's the number that they messed with here. So now, instead of kind of adding all these trees together and being like, okay, there's 8 plus 6 plus 9 plus 7, or doing like 6 times 14 times 5 times 16, like that, none of that would be right. And that's kind of where these wrong answers come from. I'm assuming 164 is kind of what you'd get for the total number of trees, but that's not what we want. We are limiting ourselves. There's a condition that limits us to the 20-foot or taller trees, the big trees. So for that, I'm still going to multiply. 5 times 9 is 45. So this number here is really 45. 6 times 8 is 48. So this number here is really 48. So the total number of trees I'm interested in is whatever those two are added together. Then what is the probability of selecting a maple tree? Now I'm only interested in the maples of that group. So it's 45, right? It's not 9 because 9 is the number per row, but there are 5 rows. So we have to, this is that twist. We have to account for the fact that there's multiple rows and it's not even, right? There's more birch than maple. So the multiplication is affecting that. So there you go. So now I actually have everything I want, right? So I would see if that's an answer. It is not. But 45 over, here we can just do it in Desmos at this point. 45 divided by 45 plus 48 gives you a fraction. Don't forget that this button exists to turn that fraction, turn that decimal into a fraction. 15 over 31. C is the answer. Even if I did this, I'd be bookmarking this. Certainly for a practice test where I know I'm going to come back and review things, this would be one where I'd be like, I've never seen a question like this. This is weird. I'm pretty sure I got the right answer, but I want to see how Mike does it because maybe there's a different way. Maybe this isn't as weird as I think. Maybe there's something to learn. If you have been practicing for a while, you will start to recognize when there's this kind of twist that is messing with things and making it's showing you something you've never seen before. And so those are opportunities to kind of, check in with yourself and be like, oh, I'm pretty good at this SAT stuff, but I've never seen something like this. How did I handle this? Did I handle it well? Did I handle it poorly? I'm pretty sure I got the right answer, but that ability to recognize when something is breaking maybe a typical pattern, that's actually a really good SAT skill. So here, yeah, that's what I'd want you to recognize is this is a weird question. And you want to recognize it as soon as you see it so that you skip it, but eventually, hopefully, yes, you would come back and have time and be able to work it through in this way. Moving on. Okay, geometry. A rectangle is inscribed in a circle such that each vertex of the rectangle lies on the circumference of the circle. The diagonal of the rectangle is twice the length of the shortest side of the rectangle. The area of the rectangle is whatever. What is the length? Okay, so again, I'm reading it fast to just kind of get a sense of what I'm doing. I'm not trying to solve anything quite yet, but I know that I have to draw a picture, right? So plug points into equations, right? Sometimes I don't have any equations yet. I don't have any points, but I do know that drawing a picture is going to help me here. This is what scratch paper's for, guys. So we have to understand what it is saying. A rectangle inscribed in a circle means we have kind of a circle that's the big shape and it's kind of lumpy. But then there's a rectangle that's inside it. And when they say vertex, they mean, in this case, the corners of that rectangle. It's not pretty, but hey, your drawing on the test might not be pretty either. Get used to drawing with messy pictures, and it's more about what you write on the picture, right? So don't waste time drawing the perfect circle. Okay, so each vertex lies on the circle. I got that. The diagonal of the rectangle is twice the length of the shortest side. Okay, so we have a diagonal, means go across. Okay, and that's twice the length of the shortest side. So for now, I'm just going to label it X and 2X. I don't love that, but that's kind of what I got, right? And it's a rectangle, so I'm doing a couple of things that maybe I don't have a plan yet, but I know are part of a good plan. Right? First of all, I'm labeling things. I have a right triangle. Making triangles is awesome. They kind of force me to make one here, right? They're telling me to make one. And so a right triangle, that's really cool. Plus, they tell me the area of the rectangle, right? So suddenly we're back to plug points into equations, right? Because now we're talking about things that I know I have equations for, geometry situations, right? The reference sheet even provides this, right? You might not think of it, that you need it, but yeah, area of a rectangle is given, length times width. So it's not enough to know that, right? I think that's the key. Area equals length times width. You don't just hold that in your head. As stupid and obvious as that formula may be, length times width, write it on the page. That way you can start to get the plug points and equations juices flowing, right? So, okay, so the area of the rectangle is 1089 root 3. So 1089 root 3 is equal to the length times the width. Okay. They want the length, right? So this is what they want. Thinking in terms of plug points and equations, right? I have kind of my worst case situation right now. I have an equation with two variables. I'm stuck, but I know that eventually I need to get one equation, one variable. I need to get this L, because if I only have the L, I can solve for it, right? That's number one on my list, one equation, one variable. So how do I get to a situation where I only have the L? Well, it's to get rid of the width, right? I have to solve for that width. So notice how, like I said, holding areas length times width in your head doesn't do you any good. When you see it on the page, you start to form a task based on that equation, right? I can put this number in. I notice I'm still missing two numbers. I know that I'm going to end with the length, meaning I must be able to get the width at some point. So it kind of gives you a new task. It's like, let's find that width, right? So, okay, is the width X, right? What's going on here, right? Like maybe that's it. But regardless, I'm thinking, okay, the length and the width together are the two sides of this triangle, this right triangle. And a couple other things are starting to clue me into what might be going on, right? I know I have triangles. I know it's a right triangle. So that already kind of points me in one direction. Plus, root 3 is one of those numbers that's got to like trigger something in your brain. Root 3 is not a coincidence number, right? Where does root 3 appear? Right here. Special right triangles, right? I see a root 3. But look, I also see an X and a 2X. So, hey, seems like I got a lot of pieces here that kind of point towards this triangle being right. And notice the X is one side. It's what did they say here? I gotta move. They said the short side, right? The diagonal, or what would be our hypotenuse, is twice the length of the short side. This is the short side. It's opposite the short angle, right? So that's kind of how that works. So notice now I can just kind of copy. I know this now. This other side is X root 3. So I thought I was going to solve for the width and then use that to solve for the length, but that's actually not what I'm going to do. But that's okay, because my problem is solved either way, right? Length and width are these two things, right? So we have now my equation. 1089 root 3 is equal to, technically, I guess the length would be X root 3, right? So X root 3, and the width is X. So notice I got to where I wanted to be. One equation, one variable. Now there's only one thing. There's only X's, right? So I got there in a way I didn't necessarily expect, but it all started with just this thought of like, okay, like this is a good place to be. I have a task here. So I need to understand this other side in some way. So there you go. Now I would let Desmos help me. Where'd my Desmos go? So 1089 square root 3 is equal to X square root 3 times X. There it is. And this time I can touch it. Sometimes you can't, the radical, but I guess because the X isn't in the radical. But there you go. 33 is my value of X. So that's cool. So X is 33. Now, the danger here is some people are just going to put that as their answer, but what do they want, right? What is the length in units of the diameter of the circle? So the diameter is this diagonal. Oops, geez, hard to draw. Is this diagonal that we drew originally, that they told us to draw? That's the diameter, right? So that's 2x. So 2x is 66. That is the answer. It is not unusual for someone to get this wrong because they put 33. And so that just is a reminder that no matter what, if it's a geometry question, before you move on to the next thing, you have to, every single time, reread the actual question at the end and be like, did I give them what they want? Right? If they had asked, what is the radius of the circle? 33 would be right. But of course they didn't ask for that because they knew that they could get you by just changing it to diameter, because most people are going to solve for X. And then out of habit, once you solve for X, you're done with the question, right? So you stop. But geometry is one of those places where they love to just ask for something slightly different. The last step is always very, very easy, but it's the ability to do the step, whether you recognize that there is one more step that separates people who get the 800 from the people who don't, so can't get this. If you got 33 here, again, you're falling short of the main SAT move, which is plug points into equations and then follow instructions. This is a good question. Now, I didn't talk about the pacing, but this might be one that I actually probably would have skipped at first, because I do find geometry questions can sometimes be a time suck. A lot of times we have to notice something. In this case, if you didn't notice that this was a 30, 60, 90 triangle, you could have done Pythagorean theorem, but that's going to take time. So if you didn't notice this, you would have been wasting a lot of time on this question. You may have been staring for a long time, wondering what to do. So geometry is risky in terms of pacing because oftentimes you have to recognize a very specific rule is going to apply, and that could take a long time. You could be staring at a picture for a long time before you are at a point where you're like, oh, this is the thing I'm supposed to do. So I don't like that. I don't like anything where I have to have like a moment of inspiration. That can be a few seconds or that could be a few minutes. And so this would be one I might skip for the sake of getting to some other things before I start really committing the time to this. But let's move on. Let's look at 18. Now, this might be something that you'd think, oh, I should skip this. You know, I said before, percentages were kind of tricky, but I actually would do this question because percentages are tricky, but the way we solve them is actually very predictable and routine. So, let's read it first. The sum, the positive number A is 2,241% of the sum of the positive numbers B and C, and B is 83% of C. What percent of B is A? So I know I'm going to use the open formulas, right? And so I might write both on my page just to get them out of my head. And then I'm just going to follow instructions, right? So the positive number A is 2,241% of, so that's telling me that's this formula, the sum of the positive numbers B and C. So sum is add. So they're telling me the of, right? Of is pointing to the original, right? So it's telling me to use this formula, and it's telling me the original, which is going to be the sum of B and C. So B plus C is my original. P is my percent, but remember it's percentage as a decimal. So I actually have to change this, right? So it's 22.41, right? If 10% is 0.1, we move the decimal 2 spots. Here, 2,241% is going to move the decimal this way. So you got to get in the habit of doing that. And that is equal to A, right? That's the is. Now I got a problem here, right? I got 3 variables in one equation. So right now this isn't really doing me any good. But that's okay because I have more information, right? B is 83% of C. So there's that of again, telling me to use this formula. So C C is my original because that's the of, right? And then 83% is 0.83, and B is the result, the new value, right? So there you go. Now I like this equation better because there's fewer things going on. What most of you are going to do is you're going to think like a math teacher, and you're going to be like, oh, B, I could substitute, right? So I could substitute this C times 0.83 in for that B and then solve in some way for that. But notice what they want. What percent of B is A, right? This is getting confusing, right? I don't know. This is getting weird. I don't like this. I don't like that I'm getting rid of the variable that I need to solve for. So that's no good. What I like instead is I realize plug points into equations, right? I have equations. Do I have points? No. Do they ever ask me to solve for points, right? Like, are they ever saying solve for A, solve for B, solve for C? No. Everything is relational. So I don't need to think about this in this kind of stupid way where I have all these unknowns floating around. Let's just arithmetize, right? Let's just make up points, right? Always come back to these strategies, right? If I don't have points, can I make them up? Yeah, right? I think so, right? So if I said that C was 100, then B would be 83% of 100, which is 83, right? That's about as easy as points get, right? So B is 83% of C. So I made up 100. I made C as 100 just out of convenience. That forces me into B being 83. And suddenly this equation, right, where I have one equation, 3 variables, very bad place to be, has now gotten to my best case scenario, right? This is 83 plus 100 times 22.41 equals A. So this is a situation where now I have only one variable, right? And I can solve for it really easily. So 183 times 22.41, that's my value of A. Let's see what it is. 183 times 22.41 is 410103, right? So that's A, right? Now, none of that is an answer because that's not even what they wanted, right? What percent of B is A? So I got to do one more open formula, one more. But again, it's pretty straightforward. Of, right? So B is the of, so that's the original. The P is what I'm solving for, and A is the new. So notice I'm putting in the letters because I want to make sure I get it right before I start substituting the numbers in, right? So what percent of B, of pointing to the B is the original, is A, that's the new. So I have these things, right? I said B was 83, P is what I'm solving for. And A, we said, was 410103. So 410103 divided by 83 gives me my P of 49.41. So many of you are going to pick B very confidently and think you're right, but this is the one drawback to these open formulas. So we have to remember that our P is always the percentage as a decimal. We know that from the start because look, 22.41, where did we get that? That was 2241. So we have to manipulate this. So we have to multiply it by 100. We have to move this decimal 2 spots. And that gets us to the percentage the way they talk about the percentage, which is as a number, not as a decimal. That is an annoying thing. I get it. But I would say that that's the only real problem with these open formulas. Otherwise, they are really good for this kind of stuff. They really keep us on task. They make it much more robotic so that we're just plugging things into places instead of thinking about how the percentages work. Humans are not good at thinking about percentages. So I would highly recommend getting comfortable with this formula. Remembering this thing with the P needs to kind of be changed at the end sometimes. So once you can deal with that, it's fine. But I do think that after many, many years of watching students get percentage questions wrong on their SAT, this is the most reliable method I have found. The P thing is, the P as a decimal, that's maybe the only thing. And I think most people mess it up once. And then once they do, they kind of realize, okay, I just got to build a step in where I think about that. And so here, you could mess it up and get it wrong. However, I wonder if I've said this before, but it's worth pointing out, is a lot of times on a multiple choice question, the existence of the choices tells you what the most likely careless mistake is going to be. So even before I solve this question, you're kind of being told, don't mess up the percent. Make sure that you solve that correctly, because if I forget, right, I'm going to get A and C are the same number, just multiplied by 100. B and D are the same number, just multiplied by 100. So the choices are telling you from the start, don't forget to multiply by 100, and so you can even write that on your scratch paper. If you see it at first and don't want to forget by the end, you can write that on the scratch, but let the answer choices in many cases tell you what the careless mistake is going to be ahead of time. That way you can kind of force yourself to avoid it. So there you go. It's a great question. This is one, like I said, I would do this because I know percentages very well. They're very predictable. And arithmetizing, especially on a case like this, really helps. All right, moving on. All right, so the first thing to say about something like this is this might be a skip for some people. It looks crazy. We do have equations, but we don't have points. We're not really being asked for points, right? In fact, they're telling us that there are no points, right? There are no solutions to this equation. So we don't know what's going to go in there. Or there is nothing that's going to work for X and Y. So some people can go to Desmos. I will show you that, but I don't think that's what I would do here. So I'm not going to be honest. I'm not going to be dishonest. I'm going to, try to show you what I would normally do. And Desmos here, I sense risk with Desmos. So you can take that risk, but I wouldn't. So what I know is that even though this is a question that might be tedious, it at least has a predictable pattern, right? We've talked about this in other questions, this number of solutions thing, right? So I have a system for going through that. And so for me, I would probably just follow that system and use my scratch paper, because even though it's going to be tedious and take some time, I know it'll work. And I would rather take a little bit more time on something that's predictable than worry about something that's a little bit more chaotic that might have a quick solution, but might not. So I always prefer predictable questions over kind of, ones that maybe look a little faster. So my solution here, or my process, is I know that I'm dealing with lines because these equations don't have any exponents. And when they say no solutions, I've memorized what that means, right? No solutions for lines means that we have the same slope and different y-intercepts, right? So they're parallel lines. And this is where Desmos could help you. If you could see if they're parallel, that might work. So again, I'll show you at the end. But for now, I get a sense of, okay, I want to make these things look like y equals mx plus b. And if I do that, I want to compare both the slopes and the y-intercepts. But specifically, I think I'm going to want to compare the slopes because the p that I'm solving for is attached to a y, right? It doesn't seem to affect the y-intercepts or the terms that would become the y-intercept in any way. So I would just literally go to my Scratch and we're going to do this the old fashioned way. And don't forget, writing stuff on Scratch paper is a step, especially complicated equations like this, where if we write them wrong, we're going to make a mistake. So, or we're going to be working with a bad number, right? So I want to see, did I write all this right? Yep. And I know that in order to get this to y equals mx plus b, I'm going to have to like add the 7/8 y to both sides. But I'm not going to do that while I'm writing the initial equation down because it's risky, right? That's two steps in one. If you mess up one step, then, if you're doing two steps at once, you're more likely to mess something up and not notice. So what I will do though, because I do consider this the same step, is I will move the 5/8 x over because it's kind of like just cleaning up sides. That's my step. So this cancels out. This cancels out. 7/8 plus 7/8 is 14/8. Should I simplify that? I don't know. Maybe. Let's just hold. I'm going to move this to the front so it starts to look like mx plus b. So 5/8 x plus 4/7. Now, to really get it to y equals mx plus b, I want to multiply both sides by 8/14. And this is why I didn't reduce, is multiplying by 8/14 is actually really convenient here. Now, technically, I have to distribute. But this is where practice makes you much, much better. Not necessarily perfect, but I know that this 4/7 thing doesn't matter, right? Again, I'm not interested in the y-intercept here. So this is where I'm going to kind of let my, this is educated laziness. I don't care about this number. I know I'm going to end up with different y-intercepts regardless. It's the slopes that I'm going to care about. So I'm only going to worry about the math that involves those slopes. So what I end up doing is this goes, this goes, this goes, this goes. We get y equals, and then the 8's cancel, and we get 5/14x y-intercept, right? But that slope, 5/14, that's what I want. That's got to be the same as the slope for this other equation. So I can get this other equation now to kind of do the same thing that this one did, right? I'm going to write it down. So 5/4 x plus 7/4 equals py plus 15/4. And again, I want to get it into mx plus b so that I have a slope. I know this is part of a y-intercept. I know this is part of a y-intercept. Those don't matter. The only thing that's going to matter to me is getting that y alone. So now if I multiply both sides by 1 over p, that's going to happen, right? The p's, these cancel, and I get 5p, or sorry, 5, I hate the eraser. Where's the eraser? There it is. So I get 5 over 4p, and that's the slope of this. So it's kind of, the y's on the right side, but it doesn't really matter. But now I can do this simple instruction that I gave myself earlier, right? The same slope, same in math means equals, right? So essentially what I have is that this slope here, 5/14, has to equal this slope here. So 5/14 is equal to 5/4p. So the 5's kind of don't matter. You could cross multiply at this point, or you can just say, okay, 14 is equal to 4p. So divide by 4, and you're going to get p is equal to 14/4, which is 7/2, which is 3.5. So you can write it literally any of those ways, but that is the answer. Now that's a lot of work. I mean, look at this. This is a lot more algebra than we've been doing for pretty much any other question. So this is a lot of work. Again, I would have liked this work because even though it's tedious, it's very predictable. And as long as I'm careful, I should be good. And I obviously would keep my Scratch in case I messed up. I can go look back at my process and see, that's why if I'm doing Scratch, I'm showing all my steps. If I'm going to combine like terms across an equal sign, I'm going to show the plus 7/8. I'm going to cross things out. I'm going to show the distribution. I'm going to show the multiplication. Everything that I'm doing in my head, I want to show on the Scratch. So I have that kind of self-checking as I go. Now, though, I would go to Desmos. I'd be like, all right, I think this is the answer, but I know what it would look like if this were the answer, right? So I would have 7/8. I'm going to type the thing out. Y minus 5/8 x equals 4/7 minus 7/8 y. So this is my line. You can see it's a line. Did I type it right? Yep, looks good. Let's do the other one. And I'll do it this way. So 5/4 x plus 7/4 equals py plus 15/4. So you see it prompts for the slider. So we'll add the slider. But we know the value of p, right? It's 3.5. So what I'm looking for is, do these lines look parallel? Yes, I think so. I think they look parallel, right? I mean, I can zoom out and see they kind of seem to be going the whole way, right? You can kind of slide with it. Does it seem like they're merging towards each other? No. But this is why I wouldn't have wanted to use Desmos in the first place. That's a hard thing to really see. It kind of looks good as a check, but if you had done this Desmos originally, you would have essentially done the same thing I did here. And you would have started, right, with P being 1. And you would have said, okay, well, no solutions mean they're parallel. Does this look parallel? No, this does not look parallel. So I got to adjust this P. So I can kind of move it this way. Seems to be making it worse. If I go this way, though, we're getting closer, right? So then the question comes, how do you know when they're parallel, right? So this is 3.2. I can kind of see that it's bigger distance here than here, right? Like I can see that still. 3.3, well, maybe a little better. 3.4, 3.5, right? Like, is there a material difference between 3.4 and 3.5? I mean, we know 3.5 is the answer, but maybe you can kind of see them merging there, right? 3.5, they kind of look better. 3.6, you kind of see them merging. So my hesitance, right, is this would obviously be quicker. If you did this and you just kind of play with that slider until 3.5 popped up, great. My hesitance is, though, what if instead of 3.5, it were like 3.52? Now look at that thing, right? That still looks parallel. Can I tell? Is it drifting apart here or getting closer? I mean, it's hard to see, right? What if I go this way? It kind of looks like it's maybe getting closer. What if it's 5.23, right? What if instead of it being a fraction of halves at the end, it was a fraction of thirds, it was a fraction of sevenths, it was a fraction of thirteenths, right? The reason this is something that we can do in Desmos in this case is that it's halves. It is a fraction that is going to have a very nice terminating decimal. But, the College Board knows that we're using Desmos for this stuff. And they know that a very easy way to make a question go from an easy Desmos to a very, very hard Desmos or an impossible Desmos is to just change the fraction from something convenient like halves or fourths to something very inconvenient like thirds or sixths or sevenths or thirteenths. And my method with all this algebra wouldn't care about that because I'm just using fractions the whole time. So if it ends up being, 7/13, doesn't matter. I still see it as 7/13. I can just still put that in to the thing, right? I didn't need to put 3.5. I could have put 7 halves, right? So keep that in mind is all I'm saying is I think, again, what I'm trying to get you to understand with this grind mode, exceedingly long SAT video is to understand that there's so many decisions that you're making in a split second. And right now I'm taking the time to really break those decisions down into every little thing and voice it to you to make you understand how much I'm deciding in the moment. I would avoid Desmos in this case because I'm aware of the danger that I might go to it and I might end up messing with that slider and not being able to get an answer because it might be a weird number. So for me, the risk of that is high enough that I would rather just know that I'm going to get the answer from the algebra. But I'm good at algebra. I trust my algebra. If you don't trust your algebra, then fine. Maybe trusting Desmos is safer. So just understand that that's a decision that you're making and understand the risks on both sides. That's all I'm asking is if you can see the test as that, as a series of decisions and cost benefit, you will have a better time. You might make the wrong decision sometimes. I make the wrong decision as well. But if you can understand that it's a decision and it's not just always use Desmos for everything, then I think you'll be happier. So here we go. Let's move on to the next one. We got 3 more. And I love this already. I see points. I see equations, right? So this is great. The table shows, so again, this might be one that I would do because I like that it has all the things that are the ingredients of my main strategy, points and equations. The table shows the 3 values of x and their corresponding values of g of x, where g of x equals f of x plus 3, and f is a linear function. What is the y-intercept of the graph of y equals f of x in the xy plane? So there's some shifting going on, there's some changing, but I understand these points go in this equation. So I would probably solve this a slightly different way nowadays, but if I'm being honest, this is what I would do to start. Probably when I first, started taking this test, I'm going to plug points in equations, right? I have x and g of x, and I have a g of x equation, right? So let's take the simplest point. Let's take that middle point, -9, 0, and let's plug that in. So 0 goes in for the y, and -9 goes in for the x. And plug points into equations is an instruction, right? So 0 is the g of x value, and then we have f of -9, right? -9 goes in for x. There's an x in that f of x. It's a different equation, so we can do that over -9 plus 3, right? So -9 plus 3 is -6, but it doesn't matter because in order to simplify, I would multiply both sides by -6, and that cancels with the 0. So what I really end up with is 0 equals f of -9, which remember is a point, right? Function notation. Notice points when you got them. That's a point. Now that's a point that goes into my f equation. Oh, okay. Well, I only have 1 point for that, but if it's a line, I know that having 2 points is pretty good, right? 2 points is what I want. So then I'm going to just take another point, right? So let's do the 5, 21, so I don't have to deal with negatives. 5 is equal to f of 21 over 21 plus 3. So that's 24. So times 24 times 24. 5 times 24 is the same as 10 times 12, which is 120. So 120 equals f of 21. And don't worry, you can use your calculator there. So 21, 120. In fact, let's not get cocky here. Let's just make sure 5 times 24 is 120. Okay. Now I have everything I need for a line, and I have 2 points. And by far, the easiest way to find the equation of a line on the SAT with Desmos is to make a table with the points and do a regression. So -9, 0, and 21, 120. So we're going to give it both the points. It's going to pop me this add regression button. We're going to hit it. It's going to default to linear regression. It's going to give me the equation, y equals 4x plus 6. What do they want? They want the y-intercept, 36. Done. That's the answer. This step in the past, I would have done more by hand by plugging points into equations and doing, okay, so y equals mx plus b, right? I can take these 2 points and find the slope. This is not the y-intercept, by the way, right? Notice how they're trying to trick you with that. But I could find the slope. I could plug points into equations. I could build the y equals mx plus b equation by hand. That's also not that hard. But here I've learned that, yes, this default regression is the way to go. So let me show you the other way, which is we could have done a regression from the start. The problem is, if you open this drop down, you're never going to get an equation that looks like this g of x that they gave us. So we have to create a custom regression. So let me start over. And this would be what I would do maybe to check it, at the very least, is I would take these points and I would pop them in. So -27, 3, -9, 0, and 21, 5. Oop, 5. Right. So if I hit the regression button, again, it's going to create a line. It's a messy line. This is nothing, right? This is no quadratic. This is some weird thing. But if I hit this triple dot, I can export it as a custom regression. And when I do that, it is basically just showing me the exact same thing I did here, but now it's giving me the ability to create what I want, right? So I don't want a line. I want this. I want this g of x thing that they gave me. So I can do that. Let's turn the line off so it doesn't get in the way. But I can do that by being very clever, right? Because the y1 is referring to these y1s, which are the g of x points. And the x1 is referring to these points, right? Now, there might be a way to do it where you put f of x1 here, but I don't think that's going to work the way we want. So it doesn't really matter. What I want is f to be a linear function. Well, mx plus b is a linear function. Right? So let's just keep that. Let's just, kind of put some parentheses around it. So we keep it on the top and then divide. And then what do I want? I want x plus 3 on the bottom. But if I put x plus 3, it's going to be like, what the heck is going on here, right? Well, notice what they did with the x's and the y's. They made them x1 and y1 because we need to tell the regression to go here, x1, y1, right? So x1 is all we need to do. Just type a 1 and it becomes that. And you could see it's some weird graph, but it goes through the points that they gave us. And they're telling us the value of m and the value of b. And because the top is a linear function, the b is the b of the f of x function, the y intercept. So we get the answer either way. And notice too, the custom regression doesn't use an equal sign, it uses this little tilde. But if you get comfortable with the formatting, then you can do anything you want. If they give you points and there's some wacky equation that goes with those points, you can create it yourself. You just need to be comfortable with the formatting. If you can't remember the formatting, every time you hit export as custom regression, it just pops it down and then you can remember it that way. But this is a question, yeah, that over time, my ability to solve this has changed, or my tactic for solving this has changed because I just, the regression I've gotten more comfortable with. But I still think this is easy enough that you should recognize to do this, right? This is a question where it feels like you need a plan to solve it. But if you just think of your plan as plug points into equations, you can at least get this first part and just be like, oh, I've got some points. Yeah, I can make a line from points. You don't need to have that middle step in order to do these first steps. The first step is just plug points into equations. All right, let's move on. This is definitely one I would skip because it's crazy geometry and I'd be like, oh, let's see what else is next. Okay, this is crazy algebra, but at least it's got equations. Maybe I can go to Desmos. So let's do it anyway in order and just kind of see what we got going on here. This is a picture situation. A circle has center G and points M and N lie on the circle. So let's draw a circle. Line segments MH and NH are tangent to the circle at M and N respectively. So let's put a point here. Let's put a point here. And this is circle G. So G and M, N. And essentially what they're saying, right, is it's tangent. So just try your best, right? So it kind of does this, it's a terrible line, but does this, and then H is out here. If the radius of the circle is 168 millimeters and the perimeter of quadrilateral GMHN is 3,856 millimeters, what is the distance in millimeters between points G and H, right? So they're telling you to draw the radius, but you should be doing that anyway. They're telling you to draw the radius because they're telling you to make a quadrilateral out of these points. So four-sided figure, right? So you should still be drawing those radiuses. Anytime you can draw a radius to connect some dots that they gave you, you should do it. But then the thing they actually want is G of H, or GH as the length. And again, they're telling you to draw it. When we do it, we do another great thing, which is we make triangles. Now, the key is, what kinds of triangles do we have? Well, there are right triangles. And the reason I know that is they didn't say it, but they used the word tangent. A line that is tangent to a circle forms a right angle with the radius at the point of tangency. You have to memorize that. That is exactly what we need to solve this question. Some of you might just assume it because it kind of looks that way, but that is a provable thing based on what they gave us. Now just fill in the rest of your thing, right? So we know the radius is 168. So there it is. So 168 is here. 168 is here. They told us the perimeter, right, of this quadrilateral is 3, 8, 5, 6. And we need GH, right? So my kind of dumb thing is almost in like a plug points into equations way, right? The equation is that the perimeter is these four sides added together. Well, we've got two of them, so let's just minus 168 twice, right? So what do we get? I wish there was a clear all button in Desmos. Maybe there is, and I just don't know where it is, but I wish there were. 3, 8, 5, 6. Minus 168 leaves us with 3520. Are these all the right numbers? 3856. Yeah, okay, 3520. 3520. Now, remember, that's these two sides. Some of you might be like, well, are they the same? Are they not? I don't know. Because of congruent triangle rules, they're the same. But this is one of those cases where I'm okay with you just being like, yeah, like, what else am I going to do? 1760. So that's this. Now, we have a right triangle. We have two sides of a right triangle. This is a plug points into equation situation, right? A squared plus B squared equals C squared, right? 168 squared plus 1760 squared is the GH that we want, right? GH squared. So how do I know that? Well, I'm always thinking plug points into equations. So I'm thinking, are there any equations that work with right triangles? Because that would be awesome. And sure enough, there's three, right? There's these things, but we don't know any angle measures, so let's not touch this. And then there's basic Pythagorean theorem, which we just use whenever we have two sides and need a third. So that's pretty easy. However, many of you might notice that you don't even need to do that, because if we have a right triangle, the hypotenuse is always going to be the longest side of that triangle. And if we look at our choices, the only number bigger than 1760 is 1768. So that has to be it. But if you were going to do it, right, just do, 168 squared plus 1760 squared. Oop, what happened there? Squared equals x squared, right? Just let Desmos solve, because many of you are going to mess up and not think you have to square root whatever your answer is. So it's a big number, but there it is, 1768. And the only reason to really do that, right, is to if we didn't have answer choices, right? If this was a fill in the blank kind of question, then you would need to do the Pythagorean theorem, and I don't really think it takes much time to do it. But the key is, this is a very hard question that could take a lot of time. But in most cases, I'm either plugging points into equations, right? I'm thinking perimeter as kind of having an equation, right? Add up all the sides and kind of solving for the missing pieces because I can. I'm thinking of Pythagorean theorem as an equation. I've got a right triangle, plug in things. And then the other stuff is stuff that, like, for kind of any geometry situation I would be doing, which is anytime I have geometry, especially if I'm confused or just need to do something, one thing is draw a picture and label everything, because you never know what label is going to get you kind of thinking of the right thing. So don't skip steps, label everything. And then, generally speaking, draw radiuses and make triangles, right? So they kind of forced us into both of those moves, but even if they didn't, draw radius, make triangles, that's kind of some safe moves. They tend to work, right? Radiuses are predictable lengths for circles, right? They all measure the same thing. So a radius is good for us because it's predictable. It has some sort of known quantity, and it relates to the area, it relates to the circumference. It has powers, Triangles are great because they're limited, right? The SOHCAHTOA limits triangles, and we have these three formulas that we can use for right triangles. So both the draw radiuses and make triangles ideas are there because they kind of limit our options. They let us see things we might not otherwise see. They kind of force us into certain types of formulas and ways of thinking, angle measures, things like that. Circles are 360 degrees, triangles are 180 degrees. So we didn't use angle measures here, but the idea is the same. It's like, I don't necessarily know where I'm going next, but I know that making triangles and working with circles in certain ways is going to kind of limit my options in a good way, in a way that hopefully lets me see the next thing I'm supposed to do. So this is a hard question, but I think having certain moves like plug points into equations and these other ones can help it just kind of move along, All right, last question here. And of course, it's a plug points into equations, right? How do I know that? Well, I have an equation, I have points. So, yeah, my default move is just plug them in. And so how would we do that? How would we plug these points in? Well, I don't know. We could try that regression thing, right? Now, I don't love that because that feels like me going to Desmos without a plan, right? So, all right, let's see what happens, right? 7, 0. And -3, 0. Now those are x-intercepts, and we can hit the button, and we do have the ability to create a quadratic the way we want, ax squared plus bx plus c, right? It's one of the defaults, but look at what it does, 0x squared plus 0x plus 0. So obviously we have some sort of problem, right? And that's how Desmos gets you guys, is if we had a line, 2 points is enough to find a line. But it's not enough to find a quadratic. You need 3 points, because it's basically Desmos is going to find the simplest path between those 2 points. And in this case, is literally just a flat line, which we know we don't have because this is a parabola, right? It says a quadratic. Okay. So, and plus it says the a value here is greater than 1. Here they're saying it's 0. So how do you deal with that? Well, there's ways. But honestly, like, this is a good example of like a couple of subtle things that you notice in this question can make a big difference, right? It says if a is an integer greater than 1, which the following could be the value of a plus b, right? So that's interesting because it suggests that maybe there's multiple values of a plus b. And so maybe there's not one single answer here, right? Well, that's odd. That means that one of these choices is right and the other three are wrong in some provable way, right? They somehow fail. So this is where confidence can kind of help you. We have the points, right? What if we started kind of messing with the a, right? That's kind of the only thing we need to know, right? So I don't think if we could do it here. Yeah, so that didn't work. What I wanted to see is if that would change this. And there might be ways to do it. Some people are better Desmos than me, but this is a case where I'm just going to do export as custom regression. Let's turn this one off. And then notice it did A0. I don't want it to be A0. That's because, here, hold on. Let's do it this way. Let's export again. And now it's got a regular old A, right? And now the A, B, and C here are going to be the same A, B, and C that I could set up with a slider. So now if I say A is 1, right? Now notice what happened. Our parabola changed shape. Our A disappeared from our custom regression, and it's going to use this A here. So as I manipulate this A, everything's changing, right? So let's go back to 1 for a sec. What do I know? Well, if I have A as 1, right, which I know it's not supposed to be because A is an integer greater than 1, but let's just say it's A for 1 for a second, right? B is -4. Again, Desmos, if you speak its language, it's really good at stuff, right? If I just say A plus B, I get -3, right? Which is an answer here. But notice it's referring to the A that we made up and the B that it's kind of finding for us, right? So this is really cool, is we don't even need to kind of do that ourselves. We can just use those numbers. And now as I adjust the value of A, I'm going to get different values. But I know this isn't right because I'm not following instructions, right? Essentially, this is a question that's giving me a bunch of instructions about a quadratic. And there's lots of things that could happen, but as long as I follow those instructions, only one of these answers will make sense, right? So the -3 is wrong because I haven't followed the instructions. I've made A an integer, but it is not greater than 1. It is equal to 1. So this doesn't seem right. Well, what's the next integer greater than 1? 2. Notice what happened. B changed, C changed, equation changed. A plus B changed. A plus B is now -6, right? 2 minus 8. And that's an answer. Honestly, that's enough. Pick it, right? Notice what the question is saying. Which of the following could be the value of A plus B, right? So we have that value. Did we follow the rules? That may be the only thing I would check, right? So do I have a function that is a parabola in standard form? Ax squared plus bx plus c. Yes, that's this, right? The graph of it passes through the points 7, 0, and 3, 0. -3, 0, right? Does it do that? Yes, -3, 0, 7, 0, right? And I told it to do that, right? So check, right? And A is an integer greater than 1. Check. 2 is greater than 1, right? And it's an integer. So everything checks out. So what else is there, right? Now, there are other values of A plus B, right? If I made A 3, right, that wouldn't be wrong to do. That follows our rules as well, right? 3 is A. Now B becomes -12, and -9 is the value of A plus B. That is a valid answer to this question, except that it is not a choice, right? So this is a case where they literally could not ask us a version of this question that was a student-produced response, right? That didn't have multiple choices because there's literally infinite values, right? A could be 3, it could be 4, 5, 6, 7. We can go up infinity, right? And as long as it's integers, we're going to keep getting different values of A plus B. So essentially here, we just stumbled upon the right one, and we did it early because we made the laziest assumption, which we often do when we arithmetize. Right? We're essentially plugging points into equations here. We have to follow certain rules. So it's not like we can arithmetize like we normally do with a number like 0. We can't because 0 is not an integer greater than 1. But if we follow the rules, right, we get a number that works. It happens to work early on. Now, it would be annoying for the SAT to make the value of A something like 17, where we got to keep trying it. But, you know, I don't know, maybe eventually you'd slide your way there and get to it. There are other ways to do it, this question, but I have no problem with this Desmos way. I like it because I'm going to Desmos kind of like a plan of like, all right, I know that these points, I know the regression works. I know that I can create my own regression where I limit the values and I can control the A, which is the important thing here, right? If you don't know how to do that, then yeah, you're going to get stuck with this stupid line and you can't go anywhere, right? So knowing how, again, Desmos is a great tool, but you got to have a plan. If your plan is let me put this in and see what happens and nothing happens, that wasn't a plan, right? That was the opposite of a plan, right? So that was you just hoping. That was a prayer. So you got to know what you're doing. But this is a good example of if you can get good at it, there you go. But the reason I know how this is going to work out is I also understand what they're telling me, right? So there are a couple of ways to do this. Another way I'm going to show you, well, with the time I've got left is 20 minutes, is kind of let me just make sure, did I get to every question? Yeah, okay. Another kind of way of thinking about these constants questions, right, is that they kind of like with number 21, where they were telling us the measure of that angle, that 90-degree angle, without using right angle or using 90 degrees. They weren't saying those things, but they were talking in code, right? It's our job to know that when you have a tangent, it's code for that there being this 90-degree angle, right? That's crucial to the question, and they are deliberately telling us in a way that is not obvious, right? So that's another way to think about a lot of SAT questions that are hard, is they're talking about something you know very well, a very obvious thing, but they're doing it in a way that's not obvious. So your job is to kind of understand that and bring it back. So here, one thing I kind of notice is they're talking about x-intercepts, right? These are x-intercepts, but this is not the x-intercept form of the equation. But I know that form, right? It's y equals, there's not always an a outside, right? Because the a is usually 1. And so we don't write it, but it's there. And especially here, because they told us it's greater than 1, I can't forget it. But then the x minus 7, x plus 3, that would correspond to the factors for these numbers, basically gives me a good situation, right? I have an equation that has fewer inconveniences, right? But this equation here, ax squared plus bx plus c, is missing 3 pieces. This one's missing really just the 1, right? The x and the y, we'll deal with that, but this a is really the only thing, right? So what I could do now is I could FOIL this out, right? So let's keep the a kind of outside for a second. So that's going to be x squared minus 7x plus 3x minus 21. Combine like terms, multiply. We end up with ax squared, so that part's the same. Negative 7 plus 3 is negative 4, so that's minus 4ax, right? Because the a is coming in with everything, minus 21a. And now in terms of going kind of all the way back to this way of thinking, right? The general rule here is the fewer equations you have, the better, right? Like the fewer equations, the fewer variables, you want fewer letters, right? Unknowns are bad. Unknowns are bad. So here I've kind of done a good thing. I went from having A, B, and C all missing to now just A, right? And I can understand that we've replaced the B with something. We've replaced the C with something, right? They're in terms of A. They're still unknown, but now I don't have to understand them as separate. I can kind of intertwine them, right? And so we are kind of given another equation, right? The thing we're solving for is A plus B. So A plus B. But now A is A, but B is this other thing. So A plus B isn't really A plus B. A is A plus negative 4A, which is negative 3A, right? So now the thing I'm asked for, notice, is also simpler. It has one less thing going on, right? I still don't know A, but at least I have to only worry about that A. I don't have to worry about the B anymore, right? So this is a kind of benefit of kind of recognizing they were talking in code. When they gave me x-intercepts, they were essentially saying, make this equation, write it out this way. You will understand what you've got better if you can do this. And I don't necessarily know exactly that it's going to turn out this way as I start, but I'm kind of trusting the process. So that's helpful. Now, how would I know what the answer is, right? Again, I could just say, all right, well, what are some integers greater than 1, right? 2 is an integer greater than 1. 3 is an integer greater than 1, right? I could just kind of do that and test it and hope I get one, right? So that's possible. But I also can plug points in equations. Essentially, this question ends with an equation, right? So these are supposed to be the value of A plus B, which we've now said is negative 3A. So there's an equation, there's an equivalence between these things. So I could just say, okay, so negative 3A is supposed to be negative 6, or negative 3A is supposed to be negative 3, or negative 3A is supposed to be 4, and blah, 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 it's supposed to be 5, right? I could just write all of these. And what's so good about this? Well, this is the situation I like. One equation, one variable. Solve for x, right? So even if I didn't know what I was looking for here, I might just be able to solve for x, right? So divide negative 6 by negative 3, we get A is 2. Divide negative 3 by negative 3, we get A is 1. Divide 4 by negative 3, we get negative 4/3. And here we get negative 5/3. Now you can kind of look at these and say, well, how would I know which is the right A? And hopefully at this point, if you had ignored this piece of information, you'd recognize it and you'd be like, huh, they told me A has to be an integer greater than 1. There's only one that does that. Choice A, right? So that to me is more of an example where I don't have a plan, but I know kind of what steps tend to move plans along, right? I think that, ideally in a lot of cases in the SAT, you will have a plan when you look at a question and it will conjure something and some sort of memory or some sort of process or whatever. However, that's not always the case for me. A lot of times I'm looking at a question, I'm like, all right, I guess we're just figuring this out as I go. I've never seen anything like this before. And so you have to be comfortable with that feeling and have a bunch of moves that you make. The main move being plug points into equations. That's kind of like a kind of default move that you always kind of have available to you, that you can make to kind of get back on track and to kind of piece it together as you go. And so many people, one of their weaknesses for the SAT is that they only start a question when they know how that question will end, right? They only start step 1 of a plan when they know step 10. If that is how you think and you're afraid to start without having the full plan planned out, then you will never do well in the SAT, or at least not as well as you want to do, because you will always be paralyzed by fear of failure on certain hard questions like this, where you'll never see anything quite like this again. But, you have to be able to adapt and be flexible to the situation. So just, keep in mind, if you are the kind of person who needs to know what to do and has to have a series of steps ready to go for every question, you will forever be kind of thwarted in your efforts on the SAT because they're deliberately writing questions you've never seen before. So rather than think of it as steps to memorize in every situation, we think of it as moves that kind of move the question along, moves that we can do to kind of learn something. And most of my moves involve plugging points into equations. So I know I've been nagging about that and kind of bringing it up again and again, but it is important. So there we go. This is the answer. We are done with this test finally. I hope that this was a helpful exercise. It certainly took me a long time to make. I am basically done with my voice and need to just spend like 15 minutes coughing. So I will not put that in the video, obviously. But if you have any other questions, ask them. If you liked this, please like this video. These take a long time for me to make, so I don't like making them unless I know they're going to help people. So if you want me to make these for other practice tests, you got to comment. You got to say, that this is what you want. So for now, I hope it helped. Good luck on your SAT. Make sure that you start thinking about how you answer every question, every decision that you make. The more conscious you are of your SAT decision-making process, the more you will have a solid, strong SAT decision-making process. So good luck. And remember, when it comes to your scores, don't settle for less. Settele for more. I'm Mike Settele. Thanks for watching.